Okay, I believe we should be live now. I'm just going to give a quick check across various channels to make sure we're going. Hello, everyone. Yep, there's me listening to myself. Thanks everyone who's already here. I see we've got 164 people already here, so I'm super psyched. I'm going to really quickly check on LinkedIn. It looks like there might have been an issue there, which is fine. Let's see. So we'll see. Hopefully, if everyone can make it. Well, we'll see. StreamYard just had an issue with what do you call it? LinkedIn. So may or may not be able to post there. Let me see if I can try to go live. Oh, okay, I can try again. Let's see. While we wait. Why not? Edit. So for some reason, LinkedIn is not working. This is great. Let me just go quickly and just call out the fact that LinkedIn's not working. Thank you all for being patient while I just get this started. Let me go find the post or the event. Posts. Let's see. Here. Thank you all for your patience while I just deal with this and then edit this as well. All right, let's just dive in then. Because for some reason again. Oh wait, I do see people from LinkedIn. Not sure why it's telling me it's got an error then. Cool. All right, thanks all for joining in. So like I said, today we're going to start our state of data infra. This is going to involve a bunch of people that will be talking about kind of different things that they're seeing, different things that they're doing. So just to kind of give you a heads up in terms of what's on the agenda today, here's kind of a pretty packed schedule. Yeah, Mehdi will be here first. I see him in the comments section. So he'll be talking about what is Rust, and kind of what role we'll be playing for data folks, right? Because I think there's a lot of us who have heard about Rust. We're all wondering, should we be writing data pipelines in Rust? Should we be, building data infrastructure in Rust? So he'll kind of tackle that problem. Not able to see on YouTube. Hopefully you can see on YouTube, but please let me know. Let's see. After that, we have May, and she actually has a team as well that will be speaking, and they'll be talking about building field level lineage with a few different tools, including Airflow and dbt. So that will also be great conversation in terms of like how you can actually build something. Suresha from Google will be talking about implementing self-service analytics. She's also written a book, and she's going to be giving away a few copies of that. So that's going to be great as well. Stefan basically has been putting together a few different things when he's worked at Stitch around kind of software engineering, data engineering. So he's going to be kind of talking about that mesh between both. After that, we're going to have Kostas. He works currently at Starburst Data, but I remember meeting him when he worked at RudderStack, as well as he's got someone else he'll be talking with, Brian, and they'll be talking about Iceberg and how you can enable streaming and ingestion. After that, we have Ming Cheng. If you know anything about Snowflake and just general cloud costs in general, we're all trying to figure out ways to reduce them. So he'll be talking about that and kind of his experience helping reduce those costs and kind of why he's built a solution around that. And then, of course, we have Zach Wilson. I don't think he needs too much of an introduction, but he'll be talking about data engineering at the Hyperscale. So that will be, I think, pretty cool just to hear about kind of his various experiences and how he's kind of put them all together. Hello from someone from Greece. Yes, and just as a heads up, yes, this will be recorded. So this will be on the YouTube channel. I might break this up as well. So at the very least, the entire whatever 8-hour clip will be here. And if not that, then I might break it up as well. Now we're at Chen Chang. This will be about 3:30 p.m. Mountain Time. All these times are Mountain Time. I worked with Chen at Facebook, and he ended up being like the head of AI or not head of AI, but head of AI for data engineering, or head of data engineering for AI. And then he went to Discord and is now basically doing the same thing. And so I wanted to talk to him and have him talk about his various experiences setting up data stacks. So I'm very excited for that. Thank you for everyone in the comments who's on LinkedIn, even though you probably can't even see me watch this video, and are commenting the YouTube, because the LinkedIn, for whatever reason, decided not to work. So please, help push people here if you're there. And then finally, there's two people. We have Chad Sanderson. He's going to be talking about his favorite topic, data contracts. So that'll be great as well. And then Ananth will be talking about functional data engineering. So it's a very, very packed day. I'm super excited for everyone that's talking here. Again, we're going to have this whole YouTube video basically be live, but it will be recorded and live here. So if you want to come back and watch all 8 hours of it, it will live here. So no worries. And then as people are doing their talks, feel free to ask questions. I'm going to do my best to kind of filter them and then try to share them with whoever is speaking. On top of that, if you haven't found my Discord, or hopefully you found my Discord, I've got a talk or channel for each talk where you can maybe post some questions if we don't get to them. That way, at the very least, I can go and communicate with them. And if they don't go look at the Discord channel, I can go bring them the questions and then get you guys some answers. So that's kind of the overall plan for today. Again, it's going to be really packed. I'm again super excited. Just talking about other things I'm super excited about. I will be doing 2 different giveaways for multiple books. Really, I've got a few books of the Fundamentals of Data Engineering by Joe Reese, and then Surisha, who's one of the speakers, also got us a few books that she's put together, which is Data Storytelling with Google Looker Studio. Hers will be digital, except for I believe 1 copy, whereas with the Fundamentals of Data Engineering, we'll be giving away probably about 5, and they'll hopefully all be not hardback, but a real book. I personally like real books, so I want to be able to send people books. The only limitation is if for any reason, I can't get you that book, maybe we can talk about either making the cash equivalent or whatever, based on where you live. I have been able to get these books to Turkey at the very least. I know I had someone that did something else that I was like, okay, I want to send this person a book, and they lived in Turkey. And we figured out how to get it there. Yeah, a real book. So hopefully, wherever you live, I can get you a copy of the book. Amazon seems to be able to deliver to a good amount of places. I think the only thing that sometimes happens is I need a little more information from some people. So that's the plan with the giveaways. That's something I'm gonna have some fun with here. We also have 2 great sponsors, so I'm just really thankful that they kind of ended up sponsoring this event. So we have SelectStar. For those of you who don't know what SelectStar is, it's basically a fully automated data discovery platform that helps everyone kind of find and understand your company's data. So they basically help you understand everything from column to table level relationships, data lineage. They also provide kind of features like data lineage, catalogs, and automated data documentation. So all of that's just meant to make your life easier when it comes to finding your data. So basically, by implementing SelectStar, you can just create a system of record of all your data across your company and teams, and you can do that for free. And you can check them out in the link below. Same thing with the Data Stack show. I've got a link below, and I've actually been on their show, and I really enjoy it. I had a few inquiries come from being on that show. So 1, it's been helpful to me from that way. And then 2, it's just a great thing that I listen to just to hear data practitioners talk and talk about their problems, but also talk about the solutions that they're implementing. So those are 2, I think, great sponsors that have thankfully, partnered with me to put together this conference. Both of them are in the YouTube link below or YouTube description below. So feel free to click and learn more about them. And I'll kind of probably bring them up a few more times throughout this conference. But again, just thank you so much from everyone who's kind of both showing up to this conference and who have sponsored this event. All right. So we're going to kind of quickly dive into something else that I've been doing, which if you've been part of the newsletter or if you've been just through anywhere from LinkedIn and you followed me, you know I've been asking everyone to help out with doing a survey. So we've been running a survey for the last about 2 months. It's been really fun in terms of the fact of seeing everyone's data stacks. We ask questions like, what are your data analytics platforms that you're using? Are you using Snowflake? Are you using Databricks? We ask questions about best practices, like does your company implement unit tests, and just a whole other host of questions. And it was great seeing everything. I think the biggest thing that I learned throughout this entire process of doing the survey, one, it's really hard to get people to fill out surveys, but two, I think the other thing that is considerably hard to do is ask good questions. After I put out the survey, I think I found 1,000 different ways to ask questions that would have been better than the way you ask questions. And we'll talk about that here in a second. But I think that's something that's very interesting. And you realize why there's like special companies and teams that do this. I have a friend who has a PhD in like surveys. And you realize why that is, because there's just so many ways you can interpret questions, and it really is important. Yeah, StreamYard keeps telling me that LinkedIn's not working. LinkedIn requires you go live before 10:14. Yeah, I don't know how this is going to work. I can maybe try to do it, but sorry, I'm just getting distracted by LinkedIn's error. I might try to fix that here once the first speaker comes up, so I'm not stuck having to deal with that while presenting. Okay, so for the next few minutes, we're just going to go over some of the results of this survey, just because I think it's interesting. I've only just started to touch the surface of this data. I've realized there's so many different ways you can slice this data. One of my friends pointed out, like, because I talked about which orchestrators have been really popular recently. And they were like, oh, well, does it matter like what data analytics platform that someone's on? So is someone that uses like Airflow, more likely to be on Snowflake, less likely? Same thing with like Prefect and Dagster, custom solutions. Are there other, correlations between stacks people use? So there's a ton of different ways to slice this data, and I've only just got started. If you haven't seen, I have like a quick analysis, and we'll kind of go over some of the similar points here from the newsletter. But yeah, let's just kind of cover some of it. So I'm hoping this is big enough. Let me know if this isn't. But basically, we are data nerds in my community model. I'm just like reading people's comments as well. Okay, so basically who responded? So just looking at industries, the biggest industry was finance. Technically banking was in there as well, but I kind of split those. So finance was one of the big ones. Software and technology was the next kind of biggest, followed by healthcare, retail, kind of what I think you'd expect mostly in terms of large industries. So we got a good healthy mix. In terms of job titles, it was like predominantly by a landslide, data engineers. You can kind of see that it's the main people that probably follow me, which makes sense. We have a lot of data engineers. Although I did a data dinner last night, and we had a healthy amount of data science managers come in, and that was really cool to see and talk to people on the other side of the fence, so to speak, when it comes to data world stuff. So yeah, so that's kind of who responded. Overall, tons of data engineers. Where are the DBAs? Snowflake killed them. I'm kidding. There's I think there was a few DBAs. It just wasn't. It was probably like 2 or 3, specifically DBA type people. At this point, data engineers have more or less kind of taken over. Oh, Luke Barros is in the comments, and he's like, data analyst number 3. I mean, they're number 3, so it's so close. and as Maddie is saying, my audience is pretty biased. That's probably the other hard thing. Whenever you do surveys, it's really hard to like mitigate selection bias, especially like with my audience. I talk a lot about Airflow, and so I'll have to work on that next year. But maybe that's why I had such a high Airflow kind of response when I asked like, what orchestrators do you use? So it's just those things you learn and think about more as you're doing a survey. Oh, I must have repeated this one. That's annoying. Great. Well, my other slide is not here. Let's see if I can. We'll just skip this. It was supposed to be what do you call it, size of companies, but we'll go to the next one, and then hopefully I'll fix this, and we'll come back to it later on when we're doing some parts of the rest of this whole talk. So we'll kind of keep going. Okay, so the next problem, or the next question that I asked, or one of the questions that I asked, was what problems are facing your data team? And then going back to the point I made about asking good questions, I realized that this question, to be more valuable, would have been much like better asked in a very different way, or more specifically. So, for example, to actually gain intent of what people are doing, a better way of asking this question, specifically around like, let's say, data quality, would be like, has your company invested or taken on a data quality project in the last 6 or 12 months? That would be a better way of trying to figure out what people really care about versus what they say they care about. Because you can kind of look through this list, and the problems, I think, do make sense. You know, talent and hiring, workload management, data quality, things like that. Oh, and someone asked, is this on USA? No, this is actually mixed across. I should have included that chart as well. I believe maybe 50 or 60% was USA data, 30%ish was European data, and then everything Asia was like 20%, and then kind of the rest, kind of fill in the rest. It was a good mix. It was a good mix of everyone from everywhere, and I really appreciate it. I didn't want to get too granular in terms of countries. Don't want some sort of GDPR thing, impacting me. So going back to this point, obviously, I think talent and hiring has always been a problem in the data engineering space and data science space, but especially in the data engineering space. I think the big reason most of us probably are accustomed to is, one, you don't learn about data engineering in college generally. Maybe you have your database course. I took a database course. The least exciting course I think I've ever taken, but one of the most impactful. And I always give the example that when I got into my first job, I was taking my database course at the same time, and we were working on a data warehouse. And for 6 months, I didn't really realize it was a different concept because, it's like, oh, this is a database. We're using SQL over here. We're using SQL over here. It's the same thing, right? And so it took me some time to figure out, okay, these are different concepts. So I do think that's interesting in terms of the fact that, yeah, talent and hiring will always be a problem unless we can fix that gap. Luckily, there are people like Joe who have put out the fundamentals of data engineering, which I do think will kind of help at least start to bridge that gap. Next is workload management, so this was just generally people who said like too many things to do, or more tasks, not enough people. So there was some sort of like insinuation that there was a lot of stuff to do and not enough people or not enough time to do it. So workload management was the next thing. As someone who has definitely worked on operational teams as well as, more production and dev teams, I can definitely feel that, right? Because you're constantly waking up in the morning, dealing with whatever pipelines broke, if there were any. Hopefully you've got none. And then building new things, and then dealing with ad hoc requests and everything else. So it can be pretty chaotic, and I totally can feel that. Data quality, I think everyone says it. I don't know if anyone does anything about that, and we'll kind of look at that in the next slide. But I think that's kind of the interesting thing there, where it's like, we can say it's a problem. I don't know if anyone's doing it. And I think maybe lack of data governance strategy can kind of fit in there too a little bit. It's a little more broad. It's not just data quality, but it definitely has some similar ties there. Old infrastructure, there was just complaints often of people would say things like, we don't have modernized tools. We're still on-prem, and some of the limitations there. Leadership. So this one was often a problem. Like, either our leaders don't know what they want. It was sometimes kind of business alignment issues, sometimes a little bit different. So usually there was just kind of a lack of clarity that was coming from leadership in terms of what needed to happen. And so that was why those were the leadership problems. It was interesting. Lack of best practices, often there's just some sort of insinuation that like we're just kind of doing things and making things happen. We don't really have a plan. Bart's over here without DBAs who guards access of the data. It's true. Without DBAs, we don't have access. We don't, but someone does. I think at Facebook, it was the data engineers. I'm sure at different companies, it's different. So this was interesting in terms of problems. Again, talent and hiring makes the most sense. And then data quality. The reason I bring up data quality is because I also asked a few other questions that I would say kind of have to touch a little bit with data quality. So for example, percentage of companies that don't have a data quality solution, at least 34% of people said they had nothing. That's, it's pretty extensive. There was another probably 35% that were custom solutions. And then everything else, the last 33% was a whole handful of options. So there's not a lot of people that implement data quality solutions. It's not terrible. I was surprised that 34% said yes, said it was only 34% that said no. But that was there. In terms of like testing, I asked about like unit testing, and only 46% of people said they don't unit test. Again, nearly 50%. I thought that was pretty extensive. Even to do something simple, I imagine as unit tests, it was pretty big. And then also 44% said they don't have a data governance strategy. So again, I can do a lot deeper analysis here where it's like, is there some correlation between size of company? Is there some way that this all correlates across all of these different metrics, which I will be doing. So if you haven't signed up to the newsletter, I'd say you should do that because I will be continuing to poke at this data. If you have different questions on this data, feel free to like ping them to me on LinkedIn or Discord or something, because it's a pretty large data set. It was really fun to kind of poke through. And I really kind of look forward to figure out what other ways I can learn more about this data. Someone in the comments was talking about the most common data quality issues. That's interesting. See, I'm just kind of reading through some of these comments. Contracts, I feel like, is the biggest. Okay. Just curious if there's any other questions here that I missed. Let's see. This is interesting. So just someone, I'm not trying to put anyone on the spot, but it's just interesting. So someone I assume is a data engineer too here at Amazon, and basically saying that data quality has been a consistent challenge, but we have a multi-layered internal solution to tackle it. So yeah, it's a big problem at most companies. I was literally at a dinner last night that was kind of focused about talking about data quality. I know, riveting things. I was the MC, so I tried to make it as exciting as possible. But data quality is a hard thing to beat, just because it can mean so many different things. It means accurate data. It means data that's on time. It can mean reliable data, and that's why they've kind of built a more broad set of terms to kind of cover not just data quality, but data reliability, data observability, because it is such a broad topic. So. It'll be interesting to see if we actually do anything in 2023. I think a good handful of people have talked about data quality, including like Zach Wilson and Matt from Disney have all brought it up. All right, so we're about 18 minutes away from Mehdi coming on and giving a talk on Rust. So to kind of before that, I will let me bring up this random picker. Let's see. So I've got this random picker that will kind of give us the giveaway. Let me go back to the giveaway. So as a reminder, we have two things to give away. I have put basically everyone's IDs for their tickets from Eventbrite into a random picker, and we'll use that. I was like almost going to put emails, and I was like, that just seems like a way that companies might scrape emails. So I was like, I can just use the IDs. So I'll be using the IDs. It's a little less exciting because I will have to do the ID, and then I'll have to figure out who that ID is. But it just feels more secure that way, to not be just dumping people's emails who knows where on the internet. So that's kind of my thinking there. Let's see. So I'm gonna bring up where's my random picker. I just had it out here. All right, let me share my screen just so at least there's something. Share screen. Let's see, window. Okay, so you can see this is the random picker. I'll look up the ID right after I hit pick random name. It's just gonna be picking an ID. So let's see, for the first person we get, I will figure out who this is really fast. Let's see. This should be, oh, quit. Don't do that. This is Petro, I can't say your last. Oh, you're challenging me here. It's Petro from vetted.ai. So I will get you Joe Reese's book. Email you afterwards. Probably I will be very exhausted today, so I imagine I will email you probably Friday, honestly, and ask you about how I can get you that book. So Petro from vetted.ai, thank you so much for signing up. Hopefully you're here listening. I'm actually let me add in fundamentals of data engineering. Fundamentals. All right, let me go back, see what this is looking like. Great. You guys get all the ads from this company. Gotta check if you joined though. Let's see. Let's do. Oh no, I didn't get an Eventbrite ticket. Oh, I'm sorry. I did my best to get as many people as I could. I have to pick some way to include people and not include people, but we will. Let me do another one for Joe Reese's Fundamentals of Data Engineering. Let's see who else we can pick. Let's pick a name at random again. And it's our name, ID. Okay, let's find out this ID. This is Nolan Trin. Nolan Trin. All right, Nolan, you also will get a copy. Again, this is as long as I can get it to you. If I can't get it to you, I'll do my best to get you a cash equivalent. If I can't do that, then it'll have to be, we'll have to pass on that. Someone asked, is this being recorded? Yes, this is being recorded. We will have it live on my YouTube channel. So no worries there. This will be live forever, hopefully, as long as YouTube remains a thing. Cool. All right, so now let's do a giveaway for the Google Looker Studio book. So Suresha put together a book. She works over at Google, and she focuses a lot on like self-service analytics. So I will be pulling that up, and let's do a few random things from there. Oh, there it is. Okay. Pick a random number. We had well over 1,000 people sign up, so there's definitely a lot of emails to possibly win here. All right, Karthik DB. Karthik and literally DB. That's the that is the last name. It's hard not to make a joke and be like, are you making the next Duck DB, but it'll be Karthik DB? That'd be cool. You have your name already is the product. That is the next product. Let's do one more for the Google Looker Studio book, and then I'll open up to a few questions, and then in about 10 minutes, Mehdi will be jumping on. So let me do one more random roll here, and then they'll be up for you guys. All right, one more for the Google Looker Studio book. All right, let me find this number. As per usual. Tazim Chowdhury. Tazim Chowdhury. There we go. All right, I'll also email you as well. Down so I don't forget. All right, so thus far we've kind of given away 2 fundamentals of data engineering books. I'll email you guys probably again on Friday when I'm awake and then two Looker Studio books. So let me remove this and add this back to the stream. So we just wrapped up some of the giveaways. Hopefully, hopefully that will be a great either gift for you guys if you haven't read it, or you can share it with someone if you already own it. I'm again really excited for being able to give these away. Now we've got about 10 minutes until the first talk starts. So I'd love to if you guys have some questions that you want to ask as we're kind of getting ready to really just dive into Rust. If you don't recall, I'll actually bring up the schedule again. Dive into Rust and what to expect with Rust and is what role it has in the future of data engineering. Feel free to ask some questions. I'd love to kind of answer things. If there's anything that you guys specifically have been thinking about. And then after this gets started, I will probably go over and try to figure out if I can figure out the LinkedIn situation, since that seems to not be functioning correctly. But other than that, feel free to post some questions. We're gonna get started here in a few minutes, fully going. But yeah, feel free to pose any questions you have. Here we go. Let's start with the classic. What's the future of junior DE? Well, junior DE or junior data engineering roles have always been hard. The hard thing I feel like with data engineers is there's this expectation to have a lot of different skills, technically speaking, right? You're expected to be able to work on the cloud, be able to code, be able to write SQL, understand data, data modeling, data pipelines, and it's just a lot of different experiences that are required. And I think that makes it a very hard job. And that's usually why I tell people hey, either try to focus on data analytics or maybe become a software engineer first, because those tend to be, I think, slightly more narrow to some degree. Obviously, you can broaden your skill set as a software engineer as well, becoming SREs or something like that. But data engineering just has such a broad swath of skills. Picking kind of one side to come from it is a little easier than maybe getting really, really stuck on trying to become a data engineer first. There are positions. Facebook started having internships, but as we kind of know, Facebook's had a hard time recently. So we'll see if they can continue to hire from interns. Bart, by the way, you don't have to raise your hand or say me. You can just you can just ask your question. But also I appreciate that as well, because it made me laugh. This is interesting, only because I've never seen, how does the blockchain data engineer roles grow in 2023. I have personally not seen any data engineering roles that are on the blockchain. I'm sure they exist. I just haven't seen them. I haven't had to work on them. It's a very niche subject area. It's a very, very niche. I'm sure they exist. I just haven't. This is obviously, I was hoping someone would kind of ask this. How does ChatGPT impact data engineering jobs? I imagine like anything else, it will likely help initially. Like we're already overworked as it is. As you saw, workload management was one of the biggest issues that people are facing. So the more we can simplify that work, the more we can reduce that work, I think the better. We'll see. I think the other interesting thing to me about things like ChatGPT is they also just point to how important it is to have good data that you can build the rest of everything off of, right? Because these things are still requiring data sets to be built. And so you can make the model, and they've almost proven that the model is arguably pretty not easy to put together. I shouldn't say easy, but it's being commodified, right? Like you can put it out as a product, and now you can sell it. The actual data is probably going to still continue to be the challenge. And as we create more data, they're just going to want to be able to process and manage more of it, more and more of that data, right? Like you're going to want to be able to build so much more data, like so much more complex data models on complex data sets, right? Like you want to do video and all this stuff, that you're going to need people that can process it so you can run your complex model on top of it. So truthfully, there's a lot of stuff in that space that I think will continue to be hard. Let's see. There's a lot of questions. I asked, and oh man, I received a lot. This is interesting. What business sectors are most likely to use modern data architecture? anything that's not generally like finance, and they'll use modern data architecture. I shouldn't say that, but there's like certain components. Like I did a quick job on a casino. There were certain limitations that they just could not like do because they have to have certain systems on prem. They have to have certain components here and there. They still were trying to modernize, so they're trying to get the data to a place where they could create or build the modern kind of data infrastructure. But there's certain components that just have to remain older because it's like, well, in order to get the data to S3, we have to use something that's a little older, that's on prem, that can deal with all the firewalls and things like that. So there's some juggling there. It's usually older industries that are forced to. Yeah. And it's just hard to switch. That's the other big thing. It's like, it's really expensive to switch to anything. Like if you're on Oracle already and not the cloud, it's like a hard switch. So, yeah. Do you foresee DE specialization being more common, similar to how analytics engineers have grown in popularity? Yes, I definitely see, just the need for DE specialization. I think it's been occurring for the last like few years already. Like data engineering to many degrees is already kind of a specialization out of data science. Like, not to say that it like perfectly came out of data science, but really what happened was like whatever 2010, 2012, people started hiring data scientists. Some of those data scientists were kind of forced to do data engineering work, which was like data pipelines and things like that, or writing Hadoop jobs. And eventually it's like, oh, this is a different thing altogether. So that was kind of like the very first specialization, although it was kind of more based off of a lot of other traditional roles we already had, like ETL developer and things like that. But yeah, it's just further specializing. I think that's kind of what's going to happen. I'm gonna kind of. I see Mehdi is in the. Yeah, he's waving. Do you want to jump on? You want to give me a thumbs up if you want to jump on, or want to start doing your talk since you're here? Cool. All right, let's just get started. I can kind of fill in some more questions later. I'm gonna kind of add you to the stream, and I'm gonna remove my chat, or I'll add your chat or your thing, and then remove this question. Great. Awesome. Hey, Mehdi, how are you doing?
Good. Yeah, I'm doing
Sorry,
great. What
I
about
just
you?
realized you're eating. Sorry.
No worries. I
Yeah,
was in backstage, so eating a banana.
perfect. Great. Just to give a quick intro for people who don't know, Mehdi has been a staff data engineer. I'm trying to remember, what company were you at before the recent shift?
Trade Republic.
Trade Republic, so staff data engineer.
And next TBD.
Yeah, next TBD. On top of that, you've been doing a lot of creation on YouTube. Definitely, like when it comes to editing, his skills. I mean, I don't edit at all, rusty. But sorry, I'm just reading a comment. When it comes to editing skills and like putting together some fun videos, you always do really interesting ones. So I really appreciate that in this space. And then you also put together what do you call it? The datacreators.club. Yes.
Yeah, exactly. Yeah, that's right.
Yes, I see the link come through occasionally on my website. Like, oh, this person sent you a website. So Mehdi's great. Yeah, I mean, I'm going to hand it over to you to see if you want to talk about Rust and is it for data folks?
Yeah, I mean, thank you for those warm words. Ben, I'm good at editing, but I mean, you're the one that inspired me to go in YouTube on the first place. So I think you're the RG that should be thanked for all your hard work. And first off, thank you for the event too, right? Because I know you've been running everything by yourself, and yeah, that's challenging and impressing. So thank you for that. And I'm uploading alone in my room, but I guess the others can show some love in the comments, right? To put such an event together. That's amazing.
Yeah.
Anyway, let's get started. So what's in Rust for data folks? First off, the official logo that you see on the left is the official one. It's the R with the gear. Next to that, you have the mascot, which is actually an official mascot, which is called Ferries. And it's been using a lot by people just because it's cute. That's the only reason. No, there is other reason, but not going into details there. Anyway, some disclaimer. We'll focus on the data ecosystem, obviously, because that's the main focus on these talks today. The best programming language is the one that fits the best your use case. The intent is not to start a war in the comment section, please. The intent is to, among all the noise and the hype that's being around Rust, to understand what's in for us as data people. And I'm not a Rust rock star yet. And a bit more quickly about me. My keyboard. So I'm Belgian, but I've been living in Berlin for the past 4 years now. I have more than 8 years in experience as data engineer. I started on-premise Hadoop era, working always as an individual contributor. I see. So people come to me when they have a technical problem, not when they want a salary raise. I worked for the past 4 years in hypergrowth environment, Klarna, back market, Trade Republic, and I create data content as Ben already introduced on YouTube, LinkedIn, Medium, and Substack, Intermedio. I play too much League of Legends during my free time, and I'm a husband and a father of a 3-year-old boy, and this is a GDPR compliant picture of my beautiful family. Anyway, let's get it started. So I have some confessions to make, which is not about my ranking on League of Legends, which was not pretty good lately, but I got a Python fatigue as data folks. So as I said, I've been in data for quite a while now, and I came first time as a data analyst, and my background is actually in electronics engineering. So my software engineering skills when I started my career were not that great. So Python basically was mostly my first and only language. And I always felt I had to catch up on some software engineering foundation, like testing, CI/CD, and so on, because I feel that Python in the data world is really forgiven on those software engineering best practice. Of course, it has changed these past years. I'm talking when it all started. An example of this is also notebooks. Notebooks it's pretty hard to respect software engineering best practice using notebooks. How do you do versioning? Have you ever done a PR with change on the notebooks? I hope you didn't. And there is Alexa, which is fighting with me for who should be talking into the conference. Let me shut up one time. And that's it. So, where I was, notebooks are pretty difficult to embrace the software engineering best practice. Of course, there is multiple frameworks and company have doing wrap up around that to meet those software engineering best practice. But it's just to say that in the data world, it's more about scripting and drafting in Python than really building software, at least from the data business side. And from the data survey that Ben showed up, we saw that more than 40% is not doing any unit tests, or at least I don't know if it's the other way around. Maybe you can comment on that. But basically, half at least is not really familiar with unit testing. So that being said, it's a bit difficult to have Python as a first and main programming language when you're not coming from software engineering software engineering backgrounds. And it still has been great. I've been using Python for everything, CLI, API, machine learning, web app, data pipeline. So that's pretty cool to have just one programming language to care. We also now put some Python in HTML. I think it's with PyScript, right? That was released like a year ago or something. But at the same time, I was thinking, okay, now we run Python within HTML. Don't we have enough JavaScript framework to fight over, right? To ever decide to put Python over there. So that's probably it. But before talking into Rust, I wanted to go back and see what were the other contenders again of before Python took the whole data world. And if you think of it, it all starts with SQL already in the 70s. So that's pretty damn old. And then the big data world era with Hadoop, MapReduce started with Java. Scala came along mostly due to the popularity of Apache Spark, which is built in Scala and the main APIs in Scala. And then Golang came around, but I think it never went through the data world specifically as we know. When I think about Golang, I think about more platform application. So Kubernetes, Terraform are big successful projects in Golang. But for data pipeline, I haven't seen really implementation of it. So Python and SQL basically conquered the whole data world today. And a fun information coming back to Apache Spark is that Databricks, which is behind Apache Spark, mentioned in their keynote in 2021, which is already 2 years ago, that most of their API call through Apache Spark is done through Python, 45%, and then it's SQL, 43%. And next to that, we have dbt, which is another big project nowadays. And don't get me wrong, I love dbt. I think it's a really great solution for a problem it solved. But at the very end, it's SQL with Python duct tape. So we have some limitation of scaling pure SQL pipelines because it's a bit more the scripting world, right? I have a video on my YouTube channel where I make fun of someone versioning their SQL pipeline in a Google Doc. I would be happy if you say that you've seen some SQL pipeline in a Google Doc or Office document. So not Git, basically. And what dbt is bringing is basically trying to use Python for setting all those software engineering best practice around versioning, testing, and CI/CD. So coming back to Rust, we have two options, right? Either we use Rust as main programming language instead of Python, or we use Rust with Python. So let's consider the first scenario first. But why Rust? I haven't talked about Rust itself. So let's summarize it. It's a modern programming language. So the first release is in 2010. To give you an idea, Python and Java the first release was in the 90s. So that is fairly a modern programming language compared to those. It's fast, concurrent, and safe from memory related error. It has low-level capabilities, similar to C++. It's a compiled language, strong statically typed, and is friendly for developers. So fact number one is that everybody loves Rust. And I guess you have seen that multiple times, but this famous Stack Overflow survey that come out each year. And Python has been the most loved programming language, so not used, be careful, most loved programming language for 7 years in a row, which is really damn impressive considering that the first release was in 2010. Another thing is that Meta last year, I think it's around summer, they did their annual tech stack recommendation. And for CLI tools, they recommended Rust, which is a new recommendation for this year. And that's often a good signal. I would not say always a good signal when you have big tech picking up some technology. We've seen that in the past. I think it was Kafka was implemented in production in some of the big tech company. Outside where it was born, but before that it was even version 1, I think. So they often are good curator and early adopters Does it mean that every big tech company is speaking, you should try it? No, because you don't have the same resource. But that's also some good signal to understand if it's going to become mainstream, I would say. Another thing is that Rust has been taking a step into Linux kernel as a second official language. Actually, this article is already pretty old. As you can see, it's December in 2021, so a bit more than a year ago. And last update, I think it's currently implemented. So the discussion is done, it's implementation. And I think it's in experimental preview, so really early release in the Linux kernel as a second programming language. So to give you a rough timeline when it's going to appear in your Debian or Red Hat distribution, usually I think it takes a couple of months before GA in the Linux kernel, and then each distribution takes a few months to update the Linux kernel within the distribution. So I would say roughly next year we're gonna see Rust natively in a lot of Linux distribution. The other point is Kata OS, which is an operating system focused for embedded system. And that was announced last October by Google, and it's fully built in Rust. All right, everybody loves Rust. That's obvious, but again, why? So we highlighted some points regarding performance capability similar to C++, but basically that's one important thing. And there is a studies that has been popped up a long time. It's already pretty old, 2018, which was about which language used the least electricity. It was done by some researcher from Portugal, I believe, from different university. But the bottom line is that you can see that Rust and C and C++ are on the top. So that's the programming language that uses the least electricity, while our dear friend Python is over there. Again, take it with some grain of salt, because that's still like 4 to 5 years ago, right? So there have been a lot of improvement, I think, on Python, especially on the last release, 3.11. So the second Rust superpower is safety and security. The point is that it forces you to have, it has a set of strict rules to keep you developer from writing bad codes. The borrow checker basically helps to avoid, it's a feature basically from Rust to avoid kind of data race and other concurrency related bugs around how memory is accessed and modified by setting those rules. And because it's a typed and compiled language, you're gonna detect most of the issue before that you run, that your code even run, which is a completely different approach from Python. If we coming back to the notebook experience where you just draw some code, there is an interpreter, we run it, and that's it. The error handling is also therefore pretty good, I feel, based on my experience. One thing on top of my mind is that it's a stupid thing, but I misspell last time a variable name, and the compiler hint me, oh, do you mean that variable? So this is like how good he can do things at compilation and trying error. Of course, we're gonna come back to that later. It comes with some trade-off of learning, but pretty good on that. The other superpower of Rust is interoperability. And by that, I mean that it works pretty well with other programming language. So there is a feature in Rust called FFI, or Foreign Function Interface. And basically that enables you to use C code, import C function within Rust code, and the other way around. But it also works with other programming language. To be a bit more specific, with C, it's a shared runtime. So the overhead would be that you have to be careful with the memory management, the types, convention, and with Python it's through binding, meaning it's a different runtime, and the overhead will be have to careful of the data types conversion, and it has to compile with the Python C API. But roughly speaking, FFI is like the most common and straightforward way to call Rust code from Python or other programming language, and it's working really, really well. Another Rust superpower is its portability. So this logo on the nice little hat stands for WASM, or WebAssembly, which basically a technology that enables you to run code in the browser with something else than JavaScript. And why would you do that? Well, there is some application for every browser apps like gaming. I put Figma because I know that there was a blog about some part of their service where they use Rust to WASM. Computer vision. And another thing is that the most popular language for WASM is actually Rust, based on the latest state of assembly survey from 2022, because you can use WASM with multiple other programming language. So that's pretty interesting, knowing that our web application within the browser has been growing and being more complex, right? If you look at it now, you can even have VS Code within the browser with GitHub Codespace. And so while I'm not sure if it's a good or bad pattern to put everything in the browser, that's another debate. It's definitely interesting to know that Rust play nicely with the browser too for certain AV application. All right, coming back for data, what's in it? Well, if you have to use Rust as a primary programming language for data pipeline, let's say, I'd be really brief, but the data ecosystem is pretty small at the moment. You have a lot of really nice library actually to do a lot of things around data, API management, doing HTTP call, and so on. That's pretty standard and works really well in Rust. For the data ecosystem, like what everybody's looking for usually is like, okay, what kind of library I can use for data frames and dataset manipulation. So Polars is a really good library in Rust. Another one has been growing quite a lot is Data Fusion. It was called Ballista before, and now it's part of the Apache Arrow project for AV compute. So for data compute in Rust, it's working also pretty well. And so how the development look like? Well, it's a steep learning curve. As we saw it before, it has different concepts to understand, the borrower checker, the notion of ownership, because it's low-level capabilities and it's strongly statically typed. This is definitely difficult, more difficult to use, at least if it's your first programming language that you ever tried. And you have to compile. Like, it might sound stupid for Java developers or other developers, but in terms of workflow, if you think about it, coming back to the notebooks thing, not that I'm a fan of it, it's a different workflow, right? It prevents you to do a lot of mistake before, because you can see those mistakes happening when you try to compile, but it's a different workflow. So no repo, no notebooks for good or bad. So let's dive into the second option, Rust plus Python. But first, why? I'm not sure if I really need to explain why Python. I think it's an existential question. But I think what's interesting here to notice is that the ecosystem and the ease of use can basically beat the performance, right? And since the beginning of this talk, actually, we've been talking about performance as the efficiency of the code, right? But what about the performance of being able to ship feature as fast as possible for business value? So that's something also to consider. That's performance, and that's fall into ease of use. And of course, maybe when it's going to scale, we're going to get other problem, right? We're going to ship a lot of features and get into some trouble. Coming back to dbt, you have a bunch of SQL scripts or Python scripts, and it's easy to provide first added value if you're not that much technical or don't have a strong software engineering background. But what happens when you scale over everything? Do you have proper unit tests? Do you have proper integration tests, end-to-end tests? Do you have your CI pipeline working? Are you testing against different environment? So all those things always come up for a trade-off. But my point here is that actually the performance definition is to take into balance, right? It's not just performance of the code, which has been discussed so far. Python loves data, but it also loves C. So a fun fact is that often when I get to meet less technical people and I'm telling them, or even software engineer in general, they know that if I say, oh, you work in data, I say, oh, you must be using Python and all those things. Yes, but the fun fact is that the entire machine learning, statistic, and other things in the data ecosystem is relying and built on C extension. So NumPy, Pandas, scikit-learn, they all relying heavily on C extension. So that's a fun fact that actually Python is popular within data, but it's actually being powered by C extension behind the scene. You remember FFI? I was talking about it. So the REST feature that integrates well with other programming language. So I guess maybe you understand where I'm going now with REST within Python. So basically, you can still use Python as a main programming language, but you can write some core elements of libraries, either with the C or C++ as it is today, or with Rust. But then the question is, yeah, but Mehdi, what about the others? What about C then? Because I've been there for a few years in Python and working pretty well. Sure, you can still use those, but there is more challenge regarding memory. You don't have any borrow checker, as I was explaining, that put those strict rule to avoid those things. Important information is that 70% of security bugs in software written in C or C++ are due to memory and safety. That's from the website of Chromium. For those who don't know, Chromium is the open source version of Google Chrome. So Google Chrome is based on Chromium with proprietary features, but basically it's mostly maintained by Google. Bottom line is those people know probably what they're talking about. It's also lack of standard build system, nor standard way to install dependencies. I think that has been changed quite a lot this past year in C++. To be really fair, I haven't touched any C++ for years, but that's like what at least I remember compared to Rust. And the concurrency can be challenging to handle because again, the memory management is a bit more manual in C and C++. So coming back to Python and data, it's happening. So Delta RS is an implementation of Delta Lake, so which is a modern data format compared to Iceberg or Apache UD. And this library is writing in Rust with some binding in Python. So a lot of people have been using it through Python. Polars is a library I just mentioned if you want to use fully Rust. But of course, there is Python binding. And it's a drop-in replacement for Pandas. So that has a lot of trying to match the same API. Modin, same story, also a drop-in replacement for Pandas. And then we have Pydantic. It's a really, if you don't know that library in Python, you should. It's an amazing library to do data validation. And it's also used within Fast API, right? Which is one of the most API framework, popular framework in Python. And it has been recently, the core has been rewritten in Rust, but you use still to Python. So all those libraries, the bottom line is that if you want to get started, using a bit of Rust behind the scene, you just have to do a pip install, right? It's transparent for you. Maybe some of you upgraded their version of Pydantic and they didn't even know that the core was rewritten in Rust. So coming back to the beginning, we have two options, but let's be pragmatic. We have actually three options. So what's in Rust for data folks? So let's put different persona, because I think like the audience can be really wide. I know that the audience of Ben is mostly data engineer, but even data engineer concept is pretty wide in terms of definition. Some people are more from the data, what I call data and business side, right? And other to more software engineer. So three different persona. The standard data people, I put DE, so data engineer here because the definition is pretty wide, but I'm mostly thinking about data analyst, data scientist, analytics engineer. So those people are using SQL a lot and a bit of Python, and they're really close to business and more focused on data. So they don't have any feeling for any other programming language because that's what they do mostly. For those people, we have another persona, which is a data engineer, platform engineer. That's actually more my profile. I've been working more as a data platform engineer, meaning I was maintaining data infrastructure and providing frameworks like dbt or an equivalent custom built to other data citizen like data analyst, data scientist, analytics engineer. And then we have a third persona. I call it data software engineer. I think it's Google, which is calling those their data engineer like this. But basically, I feel those people are the one that really build the service, like a database or a compute engine or a streaming engine. So really narrow it down at the lowest level possible. And those people are more usually coming from a software engineering background. So for the first people, I would say you don't need any Rust. Just watch out the libraries where there is some Rust, because there might be a huge performance boost. So coming back to the library I was presenting. So that's interesting to know and to understand why there is a performance boost over there. For the data engineer, platform engineer like me that has a Python fatigue, I would say it's a good use case to say which Python library can I speed up with some Rust, and why Python library? Because if you are still working as a data platform engineer and your other stakeholder like data analyst, data scientist, analytics engineer, the common denominator is SQL, and the second common denominator is probably Python, right? So it's really interesting to think that if you're providing library to those people, you can dive into another low-level programming language to boost some performance, but still providing Python interface for those folks. So I think that's a really interesting path. And the last path is if you're really building a database or something at this lowest level, then Rust is probably the best option versus C++. But again, there is counterexample. There is a few projects today. Cube.dev, for example, if you heard, is built in Rust. DuckDB is built in C++. So it's still a trade-off. But I think in the data ecosystem, that's how I would summarize what's in Rust for data folks. So if you want to learn more about Rust, there is the podcast held by Danny Lee from the Delta Lake team. They're talking about Rust. It's really interesting. The Delta Lake Rust library link, modding, so that's all the links to the library I mentioned. There is an interesting podcast about the rewrites of Pydantic, the core, into Rust. Some YouTube channels to learn Rust, how to call Rust from Python if you want to try it out, and other resources to learn Rust. And that's basically it. Thank you.
Perfect. No, that was great. I think I'm hoping a lot of people gained a lot in terms of like understanding Rust and where it fits. I liked that final slide where it was like, here's the different personas and likely where you fit in that whole spectrum. Because I think that's where a lot of the confusion goes. There are definitely a few questions. So if you feel like answering, I will bring up a few of them. So how can Rust contribute to specific data problems? So where do you really feel like it probably helps data people in particular? I mean, he's referencing lineage and observability, but I also imagine like performance and things like that are probably even more prevalent for use cases.
Yeah, but so again, I think every time where you need to have, I would say, a complex low-level project like a database, or here a semantic layer, for example. And I was mentioning actually cube.dev, right?
Oh, that's right.
And they are also writing everything in Rust, and there is a lot of work in terms of caching happening. So a semantic layer or a metrics store, right? It's just for putting some context. You can connect it, for example, today, at least because there is a wide definition, to a data warehouse, for example, or other source, and is going to provide a layer to query data with low request response as an API, GraphQL API, REST API. But that means that there is a lot of work doing in caching over there. Maybe you store it into a different database, intermediate database, you cache it from the data warehouse. And so cube.dev, everything is happening in Rust. And so this is this kind of use case where if you build such a tool that's low level like this, that's probably interesting to look at.
Yeah, that makes sense. I think that you kind of answered the, oh, not this one, moved too fast. I think you kind of answered this one, but so we won't be coding Rust data pipelines?
No, I don't. I really don't think so. I think it's really, at least for me, as I mentioned, based on my persona, it's a really nice opportunity to get out of Python. And I've done, with the website you mentioned, I've done also JavaScript, but I haven't got the opportunity to go more at a lower level. And why is that? Is that I feel I don't have any use case. It's like, okay, what should I build in C++? But if I can watch actually some Python package that are a bit slow and just rewrite some core in Rust, that I think could be really interesting.
Nice, that makes sense. Where did this? There was a question here. So, someone wanted to ask, can you spend a little more time on why you didn't pick Scala? Like, what was your reasoning there?
Yeah, I mean, personally, I've done Scala when I started Spark really early, and I think I was mentioning how Databricks is spending a lot of effort on Python and SQL. They've been putting a lot of effort and rework some foundation on the Python API in SQL. And then again, it's the same question: what are you going to do if it's developing data pipeline? Often, what I have as an experience when I was working with Scala is that I was working with data analysts or data scientists are more comfortable with Python, right?
Yeah.
And then there was a gap of communication, or I would say to work together, because, okay, I have this pipeline, maybe you can contribute. But it's in Scala, right? So I think that's also why the Python and SQL API on Spark has been so popular. So I think Scala is a good choice if you work in a isolated way in a certain service that you want to work on. But within the data ecosystem, at least for a data platform engineer and the person I was mentioning, which is me, your stakeholder are people with a common denominator, which is SQL and Python.
That makes sense. Actually, I feel like I've got a few questions like this around machine learning, because you mentioned data engineers. You didn't mention anything about machine learning engineers.
That's true. Simply because I've done some machine learning, but it's not at all my expertise. I think there is some use case, but again, I see that the ecosystem of machine learning as it is today is so big in Python, but so big, there is no way that you can't you can avoid that. So I think again, if you're a starter in the data ecosystem, data engineer, data analyst, anything, I would say the easy path to get like your first job would be Python SQL, and probably just SQL, because I think sometimes company are the requirement over there are a bit lighter, and then Python. But definitely Rust as a first programming language it's really hard to get your heads around, and I think for ML it's not there yet.
Yeah, I feel like that makes sense, and it's the reasons I think Python became popular is because I feel like, yes, obviously it's more energy intensive, improvements aside, but it's more accessible, right? Like it's like, oh, you don't have to spend all day understanding everything about your computer. You can just write something, and I remember the first time I wrote print hello world as someone that originally started writing Java, and I'm like, wait, all I have to do is write print parentheses hello world. That's it.
Yeah. The overhead, especially if you came from Java, right? There is so much overhead.
It's like, this is amazing. It's so much simpler. I don't have to remember public static void main anymore, and can just go there. You kind of lightly talked about, I think, Databricks, but have you poked around with anything else like Snowflake or things like that?
Not at all. What I can tell you regarding the clouds things is that all the big cloud provider are moving, investing quite a lot in terms of their SDK, for the cloud service. So I'm AWS, I know, as a Rust SDK, which is, in terms of performance, if you work with S3, for example, that's a huge difference. And actually, Delta IRS is quite a lot leveraging that. So typically, listing file or getting metadata of that, it used to be in Python. If you write a bit of script around that, then to do things of maintenance and series, it can be really slow. But like with the new SDK and Rust, that's like really interesting. So the others, Databricks and Snowflake, I think they might not have that much use case around Rust based on their user, right?
Yeah.
But because of the cloud provider has a wider range of user, they definitely embrace the Rust within their SDK now.
Yeah, that makes sense. Yeah. In terms of like, I imagine it'll just be made easier. Like you kind of referenced, there's just more and more solutions that are being developed on top of Rust. Like I think Jennifer is bringing up, right? Like their Python libraries for ML, Rust might not kind of be the best choice starting out, but if you've got some specific needs, and eventually there will likely be ML libraries that are built on top. I mean, you referenced Modin, and it's not necessarily ML, but it's a lot of the precursor to the ML side of things.
And the life cycle of ML is a bit more complex than a data pipeline or a data frame, right? So I think we need to have those, right, before jumping into the ML world area. If you need to train or something, you basically want to have a data frame interface. So probably build that library first, right?
Yeah. No, I think it makes sense. Are you going to be building any projects in Rust anytime soon to share on YouTube?
But I think it's just a matter of priority, of course, always. But one project that really excited me was these things around S3. I wanted to have like a small project that you run locally that give you a feeling of the same command line that you're going to have when you browse your local system. So you can do ls, cp, and so on. And today with S3 is super slow. I mean, super slow. You always do S3. There is a call and then you list. And what I would like to have is like a smart library that do some caching to some extent, in the tree of S3. So I connect to S3 and then I can navigate as it's a folder locally. So I think that's can be nice because sometimes I'm struggling for some S3 operation or just navigating to things. And I think that's a nice use case for Rust, but didn't take the time to build it. So if someone in the audience would like to start, I'm super pumped about it.
Yeah. No, that actually sounds, again, really cool, just because I've definitely worked with S3 sometimes in Python, and it can be a little bit slow. Here, if you want to go into more of like out of Rust questions, I like throwing people. I like not being the only one that has to answer some of these questions. Like, do you feel like you can get into machine learning or data engineering if you don't really enjoy data analysis or stats?
I think you should. It's like, yeah.
Good.
No. It's, I think you can ask a lot of. At least I had a lot of data scientists, like recovery data scientists, as Joe is calling them. But like when data engineering was not a thing and data science was super hype, like all those people were spending more time into actually building the pipeline rather on the model or the analytics. And I had like a few of them that start to love building pipelines because they say, yeah, but I would say the requirement is easier to handle, right? You provide the data set, and it's not like, okay, you need to provide an analysis to maybe help us to make a decision based on that, right? And that's more like blurry in terms of how you need to proceed. Where I think in data engineering, once you know what needs to be done, you just build it, and you care a bit less on. I mean, you should, of course, with the experience I raised, you should care about the business output. But my point is like, for me, it's all 1 and 0, right? And whatever it does with the business. So I think if you don't really enjoy data analysis like stat and probability, then we probably want to go more on the data engineer or data platform. I think machine learning is different. Machine learning engineering, you can focus solely on the engineering part, but not nowadays. It's often tied with others skill sets more on the analysis part.
Yeah. No, I think I kind of agree, right? Like with data engineering, if you enjoy the software engineering, the infrastructure, you like working with cloud, then that's a great place. But I can't see you diving into machine learning and not having at least a baseline understanding of stats and probability. That's why, like, if you go interview at like Facebook or any of those companies, especially if it's like a data science role or research, they'll have some probability questions in there, because how are you gonna do it? There's obviously machine learning engineers, and some of those sometimes. Oh, is that what you're saying? Yeah, sometimes those can kind of be a little more software engineering, and then maybe there's like a relationship with data scientists. But I know, for example, at Facebook, that's not the case, where it's like, no, machine learning engineers have to be good at both. You need to be good stat and good engineer. They expect both. So it's hard to get away with not being good at both of those things.
Ben, please don't pick the question. What's the best cloud provider? Just saying.
Is that one of the questions? I don't see it.
No, but I'm sure it is somewhere. I'm just teasing you.
Well, this one will be like, did you do any deep dives into like what industries Rust is kind of most widespread currently? I mean, he says for data engineering, but I mean in general, really.
I think like no, the industry. I think no, I haven't really looked. It's more like often I have like within the WASM deployment, so within the browser.
Okay, so you just said something that not everyone knows of. What is WASM?
Yeah, so this I mentioned in the talk. So WebAssembly. So
okay,
enable you to.
But I don't think you dove into it. I feel like you just.
Yeah, but basically it's enable you to run code within the browser. So it's a framework to run Rust within the browser. Yeah. And so AV application like Figma, for example, is also using that partially, not I think for everything. But when you think all those crazy web applications that we have like Maro and so on, I'm not saying that they're all using Rust, but there is a lot of use case around that because we start to have more greedy and complex, web application. So it's not really a specific, I would say, industry. It's more like the industry of web browser. That's what I feel like where it's gonna be mostly used. I think for machine learning at edge, maybe to do some analysis and compute within the web browser, that could be a thing. But I don't have that much thought otherwise about that.
Yeah, no, I think that makes sense. I didn't mean to I don't know, surprise you with the WASM question. Part of the survey that I did, I asked people kind of like more about trendy topics. So I was like, oh, do you know about Rust? Do you know about DuckDB? Do you know about, or have you heard about WASM? 70% of people said yes to Rust. They've heard about it. I think only 30% of people said yes to WASM. So It's just one of those things where it's like, in a weird way, Rust and Wasm are somehow affiliated because of like what you've referenced, the benefits of Rust. But not everyone kind of knows like what is this.
And how many percentage for DuckDB? I'm just curious.
Let me pull that up. DuckDB was 55% have heard about DuckDB.
DuckDB?
Yeah.
Wow.
Yeah. So pretty good. And actually, Wasm was 20%, not 30%, 20%. So, it's a pretty just getting started concept, right? Especially if you're on the data side. I imagine maybe if you're on the software side, it is a common concept. Actually, let me spell this out in the comments because we keep saying Wasm. It's WASM. For anyone who hasn't heard of it, it's like WebAssembly. Basically, lets you kind of write. You're referencing Rust, but it could be almost anything, right? It could be Python, it could be.
It's just that Rust is the most popular language used. But it's interesting to notice, right? That you mentioned like probably for software engineer, Wasm is more like something that they know. But why is it coming, more into the data world? And I think it's because I feel the data world is getting more software engineer in general. I think DBT is a path, like we put analytics engineering, right? We say, your metrics and your dashboard, it's a software engineering asset that should be versioned, deployed as a code, tested in different environment. If you ask like a few years ago, that Tableau dashboard, can you run as a code? Can it be versioned and deployed? I think it's like, a completely shift of mindset. And we see some, I would say, dashboard framework. I think it's Light Dash. I don't remember others, but that where you can basically deploy your dashboard as a code, which enable you to embrace basic software engineering foundation. And so I think in general, we're just getting more and more from the software engineering world, and that's why it's reaching us, those WASM things.
Yeah, no, I think it's really funny. Oh, someone put up, real data is another one. Yeah. I know everyone's. I feel like real data and DuckDB are also like two of these things that they came up at the same time, and everyone's like, oh, look what I can do with these components together. There's a lot of new solutions coming out there for everyone. We're struggling to keep up. If anyone's curious, it's like every.
So I have a question. Can I ask a question?
Because please do.
Like how do you keep up with? So obviously, your part of your content journey helps you to keep up with the technology space, right? Because you force yourself to put your things on paper or in video. But how on a daily basis do you source this knowledge?
Yeah, I mean, it's a combination of like certain people's newsletters, talking to people. I'm constantly what is it? I'm constantly like trying to talk to other data people. Like that's, again, you said my content. Like I love doing like the interview kind of style. I think you've done a few of those too, where it's just too. Like you just go and like talk about one subject. You're like, hey, I want to know how are you doing project management for data projects? That's been a recent one that I need to start putting together. Because it's like I have one brain. I can only so much time. So let me steal someone else's time who's smarter than me and has dug into this topic deeper than I have. Because there's a lot of those situations. So that's part of it. Part of it's the work, right? Like sometimes half of consulting, especially when it's more what I call pure consulting, which is just someone wants your opinion, is to now like take what you already know about the space and then spend 20% of your time looking at what's new in the space and being like, are these better solutions? Are these worse solutions? What are the trade-offs? So there's also that as well. So it's to some degree, it's just the nature of the beast. But it's
how much time? How much time? Like
time?
Do you spend on like
Oh,
that's
man.
like okay on the I would say everything combined on a day, like on a weekly basis, like how much time?
All week, I don't know, maybe like let's see, 10, maybe like 10 hours, depending, maybe less, maybe more. I also
I think that's an important number, right? I mean, so you're there. So if I'm starting, like for me, I would say I'm more between 6 hour a week.
That's
of
fair.
like pure consumption and learning. But I would say that like it's an interesting metrics to understand. Like, okay, if Ben is like just below the sun and I'm starting in my data engineering career, what's time should I allocate to learn things or keep things up to date, right? Even if it's you're struggling with the basic in Python and SQL, I think it's always important that you keep your mind open. I think Rust, like Talk, is a really good example where you can still use Python library, but maybe it's interesting to understand what's happening with Rust, right?
Yeah.
And so this time allocating, I would say that like 2 to 3 hours a week, if you start into the data domain, is a really good thing to allocate to just read things and keep you up to date, because things are moving fast.
Yeah, I think the only point I'd make is when I first started in the data world, it was like 20 hours, right? Like it was just me, like that was all you're doing. You're just like consuming. You're just like constantly like, I just need to learn everything, So when you're not working, you're just like, let me read a book on data modeling. Let me read a book on this or watch a video on like back when I was working on SSAS, I was like just spending time, pulling through that. So yeah, I mean, I think when you get started, it's really about trying to consume as much as you can to build a solid foundation. That way, as new things come in, you're not having to spend as much time
to go back.
But if you don't spend that time initially, then you're gonna have to spend time eventually catching up.
Yeah, but I would argue that you will still need to take time to go back. I think a really good example is that I start really early on Spark on 1.3.
Yeah.
I did like during time a lot of Spark before 2.0, and then little, and then now it's been like a while I haven't touched Spark. I haven't touched Spark, I think, since the .3, and there is huge features different. I know because I read about them, but I haven't, So if I need to implement the Spark data pipeline now, I'm probably gonna need to, take quite some time to be up to speed on the different things, like the different API. So I think like even if you're experienced in certain technology, you always need to sometimes go back on not square one, right, but bridging the gap. And so I think having a practice of just forever learner, I think it's give you an edge in the industry, definitely.
Yeah, it is the curse of our space, right? Like when I remember when I started my career, people would always say like, "Oh yeah, if you're in tech, you have to constantly be learning." And I was like, "What do you mean?" Like continuation, if you're a nurse, you have to do like continuing credits, and same thing with doctors. And obviously those things move fast as well, but like by the nature of their what they can't move that fast. You don't want to move things too quickly. But in technology, it's like every 6 months, it's like, oh, here's the new thing that everyone's talking about. We haven't figured out best practices, but we all want to do it now.
Yeah, exactly. Yeah,
we're still figuring out if it's good, but it looks cool. So let's all just jump into it. So
and it has a cool name.
It has a cool name. Let's all jump into it. So I think that's kind of this interesting part. Yeah. Well, I don't want to keep you too long. I can let you go. I know it's late over there, correct? It's like 8 p.m. or something.
Yeah, it's I have anywhere a hard requirement at 6, so I need to jump off. But I'll be around later on, and unfortunately, I will have probably to watch the recording for the rest, right?
I feel betrayed. I feel betrayed. You're not gonna just leave it open.
You know where I feel betrayed is like when you do your Saturday night during the night of your time, which is basically just impossible for me to reach out, right?
Yeah. Oh, you mean it's usually like Monday, but yes, I do usually Monday nights. I look, Joe Reese has his talk at
I know
8 a.m.
I love it because it's right on my good timing. Like I'm ending the first day, Monday, end of the day, I can a bit like, decompress and just watch it at 5. So yeah, no, I understand. Like it's a bit more challenging when you get a worldwide audience to please everybody in terms of time zone.
Yeah. I was actually thinking, honestly, this whole event, I saw that Andreas Krutz, if anyone who doesn't know it, also good channel.
Yeah.
Was doing a live today with Rivery, and I was like, ugh, sorry guys. It's like there's too much data stuff. Well, I'll let you go when I see the next speakers are here. And happy to kind of let you go so we can kind of go to the next talk and let you go to bed and take care of your family.
Thank you. It was amazing. Right. And yeah, good luck with that. When are you going to eat? Like, we need to send you some Uber Eats or whatever, because I saw in the there is no break. There is literally no break.
It's just me going. All right, like this is I'll maybe like jump off screen and grab a bagel or something. But yeah. All right.
Okay.
Thank you.
Good luck. See you.
All right, I'm gonna bring up the next set of speakers here. There is a whole group of them. Hey all, how y'all doing?
Doing well.
Doing great.
Perfect. It was gonna say, it looks like Helena is it's still pretty over there. Yesterday we did a quick dry run with everyone, and she was like in a tropical mall or something because she's down in Uruguay where it is summer, and I am staring at it's snowing currently outside for me. So two different realities. How have you guys been since then?
Pretty good.
We've slept, we've eaten.
Perfect.
Hopefully have some coffee.
Yes. Perfect. All right. Well, if you guys want to like kind of go around, give a quick intro to yourselves, and then we can kind of get started with your presentation. Maybe start with May. Sure. And then go from there.
I can get started. Yeah. Hello, everyone. This is May, and as you've seen, we're all from Monte Carlo. I am a product manager at Monte Carlo. Before entering in the data world, I used to be an investor. Most recently, I was PMing the data platform at a logistic tech startup. Very excited to see you all.
I can continue. My name is Elena. I'm part of the engineering team at Monte Carlo. Also come from a logistics tech company, a startup before called Portchain. And before that, worked for 10 years at Infralogistics, building a UI UX product and primarily focused on the UI and front end in Monte Carlo these days.
My name is Zhuanzi. I'm a backend engineer at Monte Carlo. I joined 2021 June. Before Monte Carlo, I was working on data a lot. Like I was at Uber for a couple of years, mainly doing streaming data processing with Kafka and Flink. And before that, I was at Google for 2.5 years building data warehouses. That's actually why I chose Monte Carlo, since I love data. I still want to be in this space.
Awesome. Thank you guys. I'm really excited to kind of dive in here because you guys built some data lineage solutions over at Monte Carlo. So I'd love to kind of hear kind of like what that was like. I think you guys have a presentation. You can feel free to bring it up whenever, and we can kind of start sharing it and diving into it. I can kind of bring this up too. Great.
All right. And are we all able to control the slides or?
Yep.
Let me see. I don't think I can flip. So. It's because you're sharing screen.
I'll do it. Yeah.
Okay. All right, let's get into it. Very excited to be here to share with you all a bit more about how we built a field level lineage as part of our data observability product. If you can go to the next one. Yep, so we've done a quick intro here. We are an all ladies team from Monte Carlo, building a core component of the resolution product within Monte Carlo. And we'll share a little bit about our journey there and what we've learned. So a quick background on Monte Carlo. We are the creator of the data observability category, and more about what that is later. We've been very fortunate to be able to raise over 200 million in funding from some of the best investors in enterprises like Excel, GGV, and Redpoint. And we've been very excited to be working with some of the most data-driven companies in the world, like Fox, Pepsi, CNN on a day-to-day basis. And we learn a lot from our customers as well. The problem that we are trying to solve here is data downtime. What is data downtime? It could be a stale report that your CFO is relying on because of the upstream table didn't update. The report did not include the latest customer order information, resulting in your financial data not being accurate. It could also be a table with a number of nulls or replication that your data scientist is relying on to build their data models. So any period of time where your data is incomplete or missing or inaccurate is what we call data downtime here. And as a result, go to the next slide. We are seeing our data engineering customers and also just including a lot of you out there spending up to 50% of your time fighting fires. And these are all time that could have been spent on more creative and productive work instead. What's worse, we're also seeing a lot of companies losing somewhere between 10 to 30% of their revenue as a result of these poor data quality. So we're here to introduce data observability. The way that we solve for data observability is to follow these three-step workflow process. First, we help you detect when there is a data issue that happened. Could be a table not updated, could be abnormal number of rows added, could be a distribution issue with your fields. We use a combination of ML-driven anomaly detection and rule-based custom detection to help you detect these issues. Once we help you identify that the issue happened, we help you resolve and find the root cause for the issues that happen. And finally, we also want to help you prevent those data incidents from happening from the first place. And what we're going to discuss, field level lineage, is a core component of both the resolution and prevention workflow. So why do we need field lineage? The two main use cases that we've seen from teams across is one, to assess impact. If there's a field that changed upstream, what are the downstream impact? If you're trying to deprecate a column on an upstream table, what are all the downstream columns that will be impacted that you need to treat? And what for a downstream errors, perhaps like a bunch of nodes in a ID field, what is the upstream causes that resulted in the abnormal numbers? So conducting root cause analysis. So both directions of top down and bottom up scenarios is where we've seen a lot of the data teams want to use field lineage for. We go to the next one. And once we are able to build the foundation of field level lineage, there are all types of use cases and features that we can build on top of it. One is that we are able to calculate an importance score for all the fields that we monitor in tables. We can look at the upstream and downstream field level dependencies to come up with how often are these fields written to or read from, to come up with how important these fields are. So as a data analyst is trying to run queries or build model, these could be helpful references. And we can also come up with the list of more accurate list of affected reports for anything that we want to deprecate upstream or any anomalous data that we see upstream. So with a table level lineage, you might be able to get a list of 50, 100 downstream reports that can be impacted by any fields upstream. With field level lineage, you can be more accurately assessing the much narrower list of downstream reports that are only affected by the field of interest upstream. So that can narrow down your impacted list to maybe 5 reports in total. So instead of needing to communicate to, 5 different owners of the downstream reports, you only need to inform a few people. And finally, this could also be very helpful with PII tracking. For example, if you have a customer email field upstream, you can use field level lineage to tag all the downstream customer email fields that's stemming from that upstream field. Next one. Given the impact of field lineage, the project is not a small feat. On the front end, you see that with the diagram here, you might have a complex web of relationships between many tables that you need to visualize. And on the back end, there are hundreds of SQL operators and combinations of these operators that you will need to be able to parse to be able to outline the relationships. And on top of that, there are also different levels of impact between upstream and downstream fields that will need to be able to surface. So in the example on the bottom right here, you see that the destination table is a result of us selecting the revenue from the source table by filtering based on the customer region. So the revenue in destination table and the revenue in source table are a direct field-to-field relationship because it is created by a select path. However, the customer region in the source table and the revenue in the destination table has a more indirect relationship because customer region is used to filter down to the revenue numbers downstream. So there's a subtle difference between different types of field level lineage among fields. So we took it to our customers to learn about their priorities. You can go to the next slide. What we learned is that what's important to them is getting value extremely fast. There are vendors out there that provide field level lineage, but they oftentimes require users to define them one by one. You have to say field 1 from table A is upstream of field 2 in table B. And with tons of tables and columns, it just takes a long time to be able to build lineage like that. And secondly, we know that once we were building this project in 2021, there was very little alternatives in the market. So our users are forced to look at their query logs and try to construct lineage one by one. So what we learned from these users is that anything is better than nothing. Just give me something that can help me. And then additionally, we also learned that some of the most popular integration that we will need to support included what you would expect: Snowflake, BigQuery, dbt, Redshift, Looker, Tableau, etc. And as we just described on the different types of relationship for field lineage, there's generally a lack of awareness on how complex they could be. And people generally have different views on what's more important to me, like a select relationship or where clause or other type of clauses. Go to the next slide. So what we ended up doing is scoping down to an MVP that we're able to ship in a mere 2 months. Some of the key decisions that we made were, first, we decided to automatically parse query logs from customers to be able to provide fast time to value. It's a plug and play solution where you plug your data in and then you get query logs a few hours later. And we're able to automatically construct field level lineage based on those logs. And we also decided to first show a field lineage view of one layer up and one layer down. If user want to traverse further up or further down, they can always click on each field to zoom in and traverse the graph. And out of those hundreds of operators that we needed to parse, we decided to apply the 80-20 rule and using 20% of the time to cover 80% of the scenarios. And over time, we're able to increase the coverage of our parser and get to closer to 100%. And finally, we also decided to visualize the different types of lineage relationship, select versus other type of field level dependencies. And with that, I will actually hand it over to Shenzi to share with you how we've actually built it.
Thank you, May. Yeah, I'd like to talk about how we actually built the field level lineage at Monte Carlo. As everyone here probably know that everything that happens in a data warehouse usually goes through some kind of queries, no matter you're creating a table, like inserting data into a table, or just modifying the table, like changing the schemas and stuff like that. That's why we decided to build our lineage within a data warehouse, mainly based on the query logs that we collect from our client side. Can we go to the next slide? Thank you. This is a general architecture of our lineage pipeline. As you can see from the left side, we have data collectors sitting on our client side. The data collector will periodically collect the queries executed in our client's data warehouses and then stream them to a Kinesis topic. This query logs would be handled by like a Lambda function. We call them like query log normalizer. The normalizer would first send the query to the query parser, which will send back like a parsed raw lineage structure. And we will resolve the lineage based on the metadata we have for the tables and columns within that data warehouse. And then the resolved lineage would be sent to another Kinesis topic and get further massaged in the data loader. And eventually the data would be loaded to Elasticsearch. And then our backend, we serve those lineage to our clients through APIs or like to our UI directly. Can you go to the next slide? Thank you. Yeah, so during the whole development process, we spent most of the time actually on the query parser. It's the most challenging part. So today we'd like to talk a little bit more about the query parsing part. It's basically a Lambda function hosting the query parser. It takes a string as input and generates the structured lineage data. As you can see, the example on the right side, with a simple query like select two columns from a table named the table with a condition that the columns 3 have to have the value as email. We generate the lineage on the bottom part. As you can see here, we have the sources, which contains like what are the source tables were used. And also the columns lineage basically indicates the lineage for the select part. Like we have two of them. The selected name is the column name used in the final query result. And in the column sources part, we show all the columns from which source tables are contributing to the values in this destination column directly. And also we have something called the non-selected columns. That contains all the fields used in the where condition from some source tables. We can go to the next page. Thank you. Yeah, so our query parser is actually built using ANTLR 4. ANTLR is a very powerful parser generator. It's widely used in building like new languages, frameworks, and tools. With ANTLR, you can define your own grammar, and ANTLR will, based on the grammar, generate a parser. And this parser can take a string as input and then generates tree-structured objects so that it's easier for you to extract information from it. Our parser is actually built on top of a grammar defined for Presto. Based on the grammar, we added support for Snowflake, BigQuery, Redshift, Athena, and a bunch of other like languages that we needed to support. We can go to the next page. Thank you. Yeah. So the query parser basically, the ANTLR basically provides you two ways to accessing the parsed tree object so that it's easier to extract information. The first pattern is a visitor pattern. The second is the listener pattern. Both of these patterns like traverse search tree using DFS, depth first search, but they do it a little bit different. Like with the listener pattern, you can define interfaces like when enter and exit a type of nodes, which is kind of flat. While with visitors pattern, you can define the function on visiting the node. It gives you more control, like you can decide whether to go to some of the children nodes given this node, or you want to skip them. And also it's much easier to carry the states from like some parent queries to the current node. At the beginning, we actually had a listener-based pattern. It actually worked for 80% of our use cases, but for some like complex cases, it was not working well. So at the last minute, we had to decide to actually switch over and rewrote the whole parser based on the visitors pattern. Here is an example. This query is actually not too crazy. As you can see, we have like non-commentable expressions defined here. And some of the commentable expressions would use the ones defined, would use the commentable expressions defined before them in their own query. And in the final query, we are drawing a real table with some commentable expressions and have like subqueries in the where condition. With a visitors pattern, we can resolve the queries along the way and carry in the states using the already resolved queries to resolve some other queries. So our parser is now working really well with like lots of like complex nested queries. Like you can have functions and expressions and subqueries in the select part or the where part or the from part, and our queries would work perfectly for them. And of course, there are always like new corner cases coming up that we didn't handle. It's just gonna be like a keep evolving process. Yeah, that's what I like to share. Thank you. Now I'll hand over to Helena to give us a demo.
Thank you, Shansi. So now I'm going to show how field level lineage actually is displayed in Monte Carlo UI. So as you can see here, within Monte Carlo, we have an incident section. So the idea for this incident section is to list all the incidents that Monte Carlo found over your data, both detected by our automated monitors, but also by your, if you want to define your own customized business rules, you can also do that. And in this case, I actually have a particular incident selected. So that's a field health anomaly. And I have it, so what this is showing me is that in particular, the event app URL field within the event details table has a value for percentage of unique that's very different to the historical value for that particular column. So historically, the percentage of unique for this field is around 99%, and I now have a bit over 56%. Okay, so I now would like to understand a couple of things related to this incident. First of all, I want to understand why this incident happened, right? Okay, so why the percentage of unique went down to 56%, and so that I can actually go and fix the problem, okay? So that's the first thing that I think a user would want to do here. And then the second thing that the user would probably want to know is what the impact of this incident is. So given that this already happened, who was affected by this? What happened to my pipeline after this happened? So that I can also like fix all the issues that this may have caused. Okay, so that's when field level lineage comes in very handy, both to understand the why. Okay, so and for that I will use the upstream dependencies, and to understand the impact, and for that I will use the downstream dependencies. So if I go to field lineage here within this same incident, I will see this chart that is very similar to what May showed at the beginning of the session. And as you can see, it has three different sections. So the section in the middle will show you the details on the field that you are analyzing. So in this case, it's the event app URL field. That is the field that's involved in this particular incident. And then here on the right-hand side, I will see the downstream dependencies for this field. And on the left-hand side, I will see the upstream dependencies for the field. So let's focus first on why this incident happened, okay? And for that, I will use the upstream dependencies. So in this case, the event app URL field gets populated with information of these 3 tables, okay? So this is what the UI is telling me, that there are 3 tables involved in getting the information that I use for populating event app URL field. So I can come here to each one of the tables and expand them, and I will get the details on exactly which fields were used within those tables to populate event app URL. And as May mentioned before, we're also categorizing these fields in these 2 different types of clauses. So if it's a direct select clause lineage, okay, which means that this particular field was actually used in the select of the SQL query, we will list it here. And then we will also list the non-select lineage, which are all the fields that were used in other type of clauses. It could be maybe a join or a where condition. And it's also very important to show these other type of fields because, for instance, if let's say that I use event type in a where condition in the SQL query, then the final results of what I'll get in the event app URL field will be different. So that's also why it's very relevant and important to also consider what's happening in the rest of the SQL clause and not just the select clause. So now that I have like the whole list of fields that were involved in getting the information for the event app URL field, let's say that, and I want to have more detail in context on exactly how this field was populated. So for that, I can actually come here and click on the SQL query, and I will get the actual query that was used for creating the table. And in particular, if I look for the URL field, here I see that we are doing a select clause here, okay, and the event app URL field over here is defined in this way, okay? So what this is telling me is that here I'm using the event ID field, and that's why we have event ID here in the select clause lineage. But on top of that, I'm also using other fields. For instance, incident ID field. So if I look for incident ID field in the query, I will see that I also use it here, for instance, to do a join. So that's also why it's relevant and it's important and why we are also listing it there. Oh, okay, so now I can actually analyze and see my SQL query. But then, and that's something that here the upstream, the information that the upstream dependencies give me, but that's not the only thing that the upstream dependencies give me. The other thing, interesting thing that the upstream dependencies give me is the ability to see if there was any other incident upstream in my pipeline that may be causing the incident in the percentage of unique in the event app URL. So for instance, if I go to the table level lineage of event details, in this case, I would get actually all the upstream pipeline for that particular table. And on top of that, I will get the incidents for all those assets that happen within a defined time frame. So let's say that I'm analyzing this particular incident and I want to know, okay, which other incidents happened upstream in my pipeline that same day, okay? So I can actually come here and select like one day of incident overlay, and I see that actually upstream to event details, I have 5 incidents here over the event table. Okay, so the event table is not directly related to event details. Actually, it's related to the incident table over here, which in turn is related to the event details. But since it's upstream to my table, it could actually be the cause of the incident that I'm having in the URL field that I showed earlier. So I can actually come here and see the details of each one of these incidents, and I see that there were actually some schema changes happening over this table, and I can go there, deep dive, and see, okay, yeah, well, maybe those schema changes had to do with the percentage of unique that decreased by half for my URL field. Okay, so that's also very helpful in understanding, doing root cause analysis for this particular incident. Cool, so that's how I could potentially use upstream dependencies. But now let's say that, okay, I already understood why this is happening. I already fixed the thing, but I realized that maybe for 3-4 hours, my pipeline was broken. I was having wrong data in the event app URL field. And now I want to fix it. And I want to also understand the impact that that incident had over my pipeline. And that's when the downstream dependencies come in very handy, because the downstream dependencies will show me all the places where this particular field was used. So as you can see in this example over here, I have a bunch of tables, local reports, and in a very similar fashion, I can also expand them and see exactly within those assets what's the exact field that is using the affected field in my incident. Which is also very helpful, because as May mentioned earlier, this also allows us to filter down the affected assets, and then I wouldn't have to notify, like, I don't know, hundreds of stakeholders. Maybe in this case there were only only three local reports affected, so maybe I only need to notify 3 different people. Hey, be careful with these particular reports, that there was an incident, it's already fixed, but yeah, we need to, you know, be careful with the information that we have there for the past 2-3 hours. So that's another way we can actually use the downstream dependencies. So leaving aside the incident, may also mention a couple of examples earlier. I think that are very good use cases for field level lineage. One of them is, for instance, if I want to deprecate a field. Let's say that I don't think that the client ID field here is getting used. Okay, so I can actually come here, select client field within the event details table, and I will get the whole list of where exactly it's getting used. So it turns it was used, but then I can actually here and if I want to deprecate, well, I have a whole list of things that I will have to change if I do deprecate that. But then not just that, I could also potentially keep navigating and saying, hey, yes, this client field is also being used in this client field in this data table, but I don't think this gets used either. So I could actually potentially click here and navigate to the client, the field level lineage on this other table for this other field, and start navigating downstream in my pipeline on the different dependencies for that particular field in the particular table. But it turned out that it was used. Okay, so I could potentially keep digging in. And well, in a similar fashion to what I showed earlier, you could also see the exact query here for this particular asset to see in context how this client field used the client field that I want to deprecate. Then the other interesting scenario for downstream dependencies is in case I want to understand how PII information gets spread across my pipeline. So let's say that I have some sensitive customer information in the account ID field, and I want to make sure that it doesn't get exposed in any logger dashboard, or if it does, but notify the stakeholders so that they can take action and mark them as private or wherever. So here I can actually go here, select that particular field, and also get the exact list of places where the dashboard uses which dashboards uses that particular information that's sensitive and that I should be careful with. Okay, so that's it regarding the demo. I want to mention a couple of things. So first of all, I want to leave you all, thank you all for attending our talk, and also leave you some contact details. Okay, so here are all our emails. We'll be more than happy to answer any questions that you may have about lineage, Monte Carlo, or anything really. And we also published an article regarding how we build field level lineage with more details on InfoQ, and you can access it here if you want to dig a bit deeper into how we did this. And but yeah, we were more than happy to be around and answer any questions that you may have. And then also finally, I want to invite you all to get a copy of our book, The Data Quality Fundamentals. So this book also covers some of the things that May mentioned at the beginning of our talk. And it was written by Monte Carlo co-founders, Bar, Leor, and also by Molly, who's head of content on Monte Carlo. And you can actually get a complimentary copy in this link. So you're all more than welcome to go out there and download a copy.
Yeah, thank you all. Thank you, everyone who's just finished presenting. I really appreciate all that you've shared. I had one question because I remember seeing Airflow somewhere. I think in your the topic. So I was curious, like where did you guys use Airflow throughout that whole process? And I might have missed it when you guys were talking, but just curious.
Yeah, so Airflow is actually like a core integration that we provide on the orchestration level as part of our data observability solution. And the way that we integrate with Airflow is that it's more for resolution use cases where we help users troubleshoot. Say if you are seeing a table that is not updated, you can easily figure out if there's a Airflow task or Airflow DAG that had an issue to help you correlate these data incidents together.
Okay, no, that makes sense. And then there's a question from Nelish. I don't know if you guys know who he is, but works over at DBT, and he's done a lot in terms of. Oh man, I'm sorry, I'm covering people's faces, so I'll remove this once I ask the question. But he's done a little bit, I think, in several kind of like data platform type work. But he's just asking, when he's built solutions, they spent time kind of doing listeners and events rather than parsing queries. So I'm just curious, like, what's the difference there for people out there trying to make a design decision? What do you see kind of as the trade-off?
I guess it more depends on which level of accuracy and which level of lineage you want to build. Honestly, if it's at the table level, you may derive the lineage based on lots of the events coming in. But then if you really want to know at field level, which fields are contributing to a specific field, since it was going through queries, you have to somehow parse it. But unless it's going through Spark jobs or some pipelines, then it's really hard, and we can't really extract information there. Yeah.
Cool. Okay, this is always a good question. I've at least every time I've seen it, and actually again, I was at a dinner last night. We were talking about data quality. So how do you actually discuss the idea of ROI for data observability when dealing with clients? Especially, I mean, they reference legacy systems, but I think this is regardless whether you're on Snowflake, whether you're on an older system, it's always the idea of data quality. I think I referenced this earlier. Everyone knows that data quality is an issue. Now, in terms of investing, I think there's always an issue there. So how do you encourage people to kind of do that, I guess?
Yeah, very good question. There are a few ways that you can think about, the cost or the ROI of having a data observability solution. One is being able to estimate, how much time the data team that you have internally are spending on dealing with data incidents. When they're, getting a report on a pipeline breaking, when they're hearing from stakeholders that some table is stale, reports are broken, and multiplied by the salary that you're paying your data engineers to fix these issues, and see how much of your time you're actually paying on an annual basis on fixing these issues. So that's one way. And the other is you can get some standard estimate on what it would take to build in-house solution of maybe data testing, building observability, or even building table level or field lineage in-house, and the market rate of these engineers, and then figure out how much it would cost for you to build a solution like that. So one thing to point you to, we actually have a calculator for ROI for data observability on our website that you can leverage by inputting some of your company data and then get a sense of what it would cost for you to build some solution, or what could be the return for you to have something like this.
Nice. No, that makes sense. Yeah, I think it's an interesting fight. Just as I've had that discussion with a lot of people, and it's I always tell people it's really easy to get money for ingestion or storage or BI. Everything else after that is hard. Everything after that is is always a little bit of a fight to get people to get in. This is less of a tech question, but more of do you guys have these slides linked somewhere that I could maybe share somewhere?
Yeah, for sure.
Yeah.
We can share with you a link, and then maybe Ben can help distribute it.
Yep. Yeah. If you want to share it in the private chat here, I can maybe even put in the comments.
Sure.
Cool. let's see this question. I'm curious, like, what are the orchestration and scheduling challenges you've seen? I don't know if that fits in your data lineage portion or not, but let me know.
It definitely does. So it is a critical part of our solution because it sits right upstream of what we typically observe. So our bread and butter is focusing on the more finalized tables, or the last stages of table that you have your data products or your reports built on top of. So any data issues that happen there is the most visible and the most painful. And a few ways of how this observability into orchestration or scheduling can help is one, oftentimes like data freshness issues or volume anomalies are a result of your Airflow task stacks failing, or your DBT model having an error, or your DBT test failing, things like that. So being able to see that what is happening with your DBT models, your Airflow DAGs, is helpful for you to understand what are the root causes for the issues that you're seeing surfacing. So that's one aspect of it. And then the other aspect is that we also help you understand, or quickly identify that there's issues that are happening. Something that we're providing to our customers is DBT incidents, where we alert you that your model is failing or your tests are failing. So you get quicker detection on things that are happening upstream. So you can have more time to fix it, and you can more proactively manage all the stakeholders that are relying on those tools. And being able to quickly identify things that are happening is also something that are where we're seeing a lot of data engineers and users are struggling with. So those are the two main ways of how some of the challenges that we're dealing with. Having the orchestration level as part of the full, your data stack.
Yeah, that makes sense. Where was the question I saw? I'm curious. So does Monte Carlo essentially block pipelines and when instances occur before publishing data, or where does it kind of stop things?
Yeah, that's a great question. So the main use case we're serving is to tell you, that there is an incident that's happening, since we're mainly focused on monitoring the layer of data that's feeding directly your data products. But on top of that, we also have what we call circuit breaker that lets you break the pipeline if we find, like a particular SQL test that you've set up is not meeting the standard, or if a SLOs that you've set up is not running, meeting the rules. So we do provide a way for you to break the pipeline before it populates your final table.
Yeah, that makes sense. And I was kind of curious because, it's good to have data quality, but it's also good to just sometimes not push things if you can avoid it altogether, just because.
Exactly.
Just to avoid, yeah.
As much as we want to help you resolve issues, it would be better if they don't even happen at all, and your data is intact.
Yes, exactly. It's always better just to not show data and be like, you got to wait an extra 4 hours versus show data, but then have someone come and tell you it's wrong or something like that. It's like it's better to be late or not there at all. Otherwise, it just causes confusion. Someone asked about integrations. So do you guys integrate with Power BI and any other, I guess, Power BI tools that they've kind of referenced?
Shin's actually built our integration with Power BI. You want to share?
Yeah, we support Power BI integrations, but right now we only have like table level lineage and some metadata for Power BI entities. We don't really have field level lineage for them, but we also have like Looker integrations and Tableau integrations with both like table level and field level lineage and lots of metadata there. And we have like BI integrations for other small BI tools like Mode, Chalio, and things like that. Yeah.
Yeah, nice.
Yeah. It's definitely a part of our plan to cover all the popularly used BI tools to support both column and table level lineage parsing. But we'll get there one step at a time. Power BI is a very commonly adopted tool among our customers, so that's high on our list.
Do you? I mean, since you have some insights into this, do you see more Power BI, more Tableau, more? What do you see the most of?
I would say out of all the customers that we have, the most common ones is Looker and then Tableau. Power BI is also significant, but not as high as the other two.
Okay, cool. Yeah, good to know. So just because someone's curious, does this work on on-prem data warehouses?
Shenzi, do you want to take that one?
We don't really right now, but we are, probably thinking about it. May probably knows our roadmap better.
Everyone's like, no, you answer. No, you answer.
we're very focused on the supporting the modern data stack.
Yeah.
And that is oftentimes, these cloud service warehouses and lakes. So that is our primary focus. On-prem data warehouse is something that we do hear from a lot of more of the legacy users or legacy enterprises. Not currently on our roadmap because we have to support modern data stack first and one step at a time.
Yeah, and I imagine most of the like on-prem solutions also have cloud offerings as well. Like I think Teradata has cloud, and most of them have cloud offerings. So it is kind of juggling it, and there's a lot of challenges with doing things on-prem. So I think it makes sense. It's hard to support everyone. You can't win every battle.
Yeah. But by the way, for DBT, we support on cloud and also like your self-managed DBT.
Yeah. No, that makes sense. Let's see. I don't know if I have. Is there more questions anyone has? I've got a lot of questions here that are breaking into data engineering questions, which if you want to, you can totally answer those if anyone has any interest. But
I actually saw a really helpful suggestion earlier from Alex. Probably got missed in the thread of comments. He was asking for ability to search for a field to see. Yeah, that's actually a really cool idea. So we didn't have a lot of time to give you a full demo, but feel free to reach out. We do have like a lightweight catalog solution where we let you search for both tables and fields, so you can land at the most interested field to see field lineage. And then within each table, in the view that Helena shared, there's also a search bar where you can find the field. Because like you might have like a list of like 100 and 200 fields in the table, so you can find your field from that list.
Makes sense. Trying to go through. So does it make sense to connect to product analytics tools with Monte Carlo? I assume they mean, I'm trying to think, they mean like mixed panel or something like that. I assume more than likely you guys just are on the data warehouse, and then that's probably more of the straightforward shot there.
Yeah. So we are a monitoring solution. So we monitor, the tables that are powering. Maybe you are using mixed panel and amplitude to power, to feed data into to your warehouse. So those are like the upstream source of data applications that's feeding into your data warehouse. And we don't have that kind of solutions to monitor upstream that much. But if you imported your mixed panel tracking data and your amplitude tracking data, and you have that in your Snowflake or in your BigQuery, we can monitor those tables and make sure that they're in good quality. But yeah, and we are also, power users of those tools as well.
That makes sense. All right. Well, I don't see too many, like, unless you saw some questions, May, that like, or comments that you really thought stood out. I don't think, again, there's a few questions here that I can maybe take after this, which are more on like data engineering and becoming a data engineer, which happy if you guys have some answers you'd like to share, but also at the same time, I know it's a little bit off topic, so let me know.
I definitely don't have any helpful advice on how to become a data engineer, but well, I can share with you my experience working with data engineers, which are actually like a lot of the data engineers come from traditional engineering background and got really interested in data, and those are a very typical background of the data engineers that I've worked with. A lot of them were also infra engineers. And maybe Shenzi actually worked on the data infra team at Uber, so I'm sure she has a lot more.
Sorry, the question is like how to become a data engineer.
Let me pull. There's a few different questions. I was more saying there's a general theme of questions that are in that topic. So, for example, let's see, what kind of project would be valuable for new folks to get like data engineering jobs?
Which kind of projects? I guess it depends on like where you are working at. Like definitely if you're working in a company, if you want to be more on data part, you probably want to at least be on the backend first, since at the backend you have to deal with data somehow. And from there, like usually if you are on a backend, you're more like writing queries to get data out somewhere. And you probably want to see like upstream where the data is coming from. Depends on like, but usually if it's transactional, then it's still kind of within the data product part. But then if you want to be really in the data part, maybe look into like the analytics part, and just trying to find opportunities get you on like working on pipelines of like maybe ingestion of data and stuff like that. It really depends on the opportunity and where you work at. But I believe like since every company, like data is so important for every company now, you definitely can find something there. Maybe try to see from analytics where they are getting the data from and where the data source is, and just try to pivot yourself there.
Yeah, that makes sense. Yeah, to add to that, yeah, I think like one thing you kind of reference is finding projects at work. So like, yeah, if you haven't if you're not working somewhere, you could there's a few videos. There's a YouTube channel. The guy's Darshell, I don't remember his last name. He's always putting out data engineering project videos if you need demos. But like you said, if you're working somewhere and you're wanting to like move into data engineering and you're on the software side, yeah, like you said, finding projects that have ingestion, that require processing large amounts of data, doing data pipelines. Those are definitely the projects you want to kind of get connected with, one way or the other. Whether you're just building the infrastructure for it, I know again we had Nellish have a few comments here, and that's his thing. Like he's done work I think with like Iceberg, Hadoop, Hive, and a few other things where he's contributed and kind of works on those types of projects. So it also just depends on the type of work you want to do. So yeah. Well, I don't see any more questions really. I feel like on Monte Carlo, unless I missed one. But yeah, no, I appreciate all of your time. Do you guys have anything else? Any final questions before we kind of move on?
Feel free to reach out to us. We have the emails in the slides, and
yes,
welcome any questions.
Awesome, that's awesome. Well. Yeah, I can kind of I think go to the next section. I'm gonna upload some slides, and we can kind of go over the rest of the talk for everyone else. And then yeah, I appreciate your times, and yeah, I'll probably see you guys around.
Thank you.
Thank you. Bye bye.
Thank you. Bye. And I see that our next speaker is here. I won't pull you up just yet. I'll kind of do a quick just catch up here. So all right. Thanks everyone who's been here. We've done 2 talks already, so let me just kind of put here the schedule up again, just in case you've just joined. So we've just finished building field level lineage. We now have implementing self-service analytics coming up by Surisha, followed by several other talks you can kind of see. So just want to kind of put up this agenda. It's also below in the description, so feel free to look through that, just so you can kind of see where things are. This is all in Mountain Time. It is currently, it looks like it should be 10:47 a.m. Mountain Time. So if you're wondering where we're at, that's kind of where we're tracking. So I've also been doing giveaways. Our next speaker actually wrote one of these books. So Suresha wrote one of these books, so Data Storytelling with Google Looker Studio. And then I also did one earlier as well with the fundamentals of data engineering. We'll kind of do those probably again coming later on. I'm just doing it based off of people's Eventbrite sign-ins. So there's IDs, and I'm just kind of using those IDs so that I don't have to put emails somewhere and some scraper gets to steal all your emails. So I'm just using the random IDs that they've generated. So we'll do this here probably later on again. So we've already done a few. Again, we have two great sponsors that have been very kind in sponsoring this whole conference. For anyone who hasn't watched the DataStack show, I've actually been on it. It was a lot of fun. I had a lot of leads come from it as well. So for me, it was very beneficial. And I also listened to it just because, if you want to hear practitioners talking about what they do, about the problems that they're solving, I think it's a great place to kind of go and talk about that stuff. Also, a very special thanks to SelectStar, which, if you're not sure what that is basically a fully automated data discovery platform that helps everyone find and understand basically your company's data. So it helps you basically understand everything from table level to column level relationships, as well as providing everything from data lineage to a fully decked out data catalog. Kind of reminds me a lot of the Facebook data catalog that I used to use. So I think it's a solid solution, and then basically you can implement that and get a fully automated data catalog day one. And I have a link below, and you can get started for free. So feel free to jump on that. Okay, I'm going to re-review the state of data survey just really quickly because I know not everyone has seen it. I'm sure there's people who've gone in and out of this conference. Just as again a quick reminder. I've kind of run the survey. We have over 400 people who've kind of given me insights into what their data infrastructure looks like, what best practices they're following, just about everything in that kind of vein. So I referenced earlier, there's a lot I learned from doing this in terms of how you should ask questions. I definitely will probably repeat this next year, but I'll probably kind of improve some of the questions because I think there was a lot of ways you can answer things and ask things to just get better information. I'll kind of review some of these quick results just so, again, you can kind of get what we're talking about here. So again, here's kind of the high level of who responded. We had people from finance, software, healthcare, mostly data engineers, which makes sense. My audience is probably mostly data engineers. But there are data analysts and BI analysts and managers and so on here as well. So it was pretty full. It was pretty great to see everyone. I did fix this slide from earlier. Let me go to the next one. So here is the company sizes. Earlier it was accidentally a duplicate slide. So here's the actual company sizes of people who filled out this information. Mostly you can see in that 100 to 500 range. But there was definitely some people that were also, in that enterprise level companies filling out this survey. So it was a good mix, and I think that's great because I'm going to do a ton of analytics in the future about, what types of sizes of companies do what. Someone asked earlier, where people were from that filled out this survey. Here's kind of the breakdown. Again, mostly North America, some Europe, Asia, then South America, Australia, and Africa, kind of filling in those last few sections. So it's I still think it's a good mix of everything. Thank you for everyone who took the time to fill this out. So the interesting results. I'm going to skip over the problems because I went over this earlier, so you can probably watch that again. But the other thing I wanted to cover, just because this was funny to me, and this could be some selection bias. My audience is probably decently focused on Airflow because I have a few Airflow videos, so I'm sure that could possibly skew this. this is a great example of why not to use a pie chart, but I think it still tells the funny story to me, which is Airflow is such a massive part of this. I assume custom built solutions is Python scripts and cron tab situations, because that tends to be a big thing. And then everything else is kind of left after that. And none is number 2, which is kind of funny. This is somewhere else where maybe I could have had something like custom scripts and not just custom built solution as a better answer. Just some people pointed that out, that could have been clearer in terms of solution. So yeah, I thought this was interesting. It'll be more interesting next year when we see, like, is there a change, right? Like, do I get more Dagster or Prefect or Mage? Do those start, picking up? So it'll be really interesting to see kind of over time where this goes. Just a little more of a cleaner breakdown of like the top 5 orchestrators, except removing none. So it's mostly Airflow, custom built solutions, Prefect, Dagster, and Azure Data Factory. I think Azure Data Factory should be higher, but I'd have to maybe make sure I was getting maybe a broader data set. So yeah, no, I thank you again, everyone who's filled this out. This was, again, super helpful for me just to understand where people are, what people are doing, what tools people are using. We also did some analysis in terms of like what data warehouses people are using and a couple other solutions. I brought up earlier, actually, data quality solutions. Actually, I'll go back to that just because it was interesting. I think it's like 34% of people don't have a data quality solution. So that was just referencing earlier. It is still a pretty decent gap, and most people besides that have custom built solutions again, which makes sense. When I built a lot of these solutions, I've often kind of had to build some sort of data quality solution in place. So that's kind of where we're at. Luigi didn't make the list. Someone just brought up Luigi didn't make the list. Well, the fun thing with Luigi is Spotify is no longer supporting development of that. I think they switched to Flight this year. So that was kind of a sad reality. Luigi might have lost that, but we now have, again, we have Prefect, we have Dagster, we have Mage. We have a few new options coming in, so that will hopefully continue things. Someone asked, was there a section on the types of data warehouses? Not yet. I am going to probably try to add that in between the next few talks. And then if there's more time to kind of fill that in, I'll put that in. But that's kind of where we're at. Will these slides or data on responses be available at a link? Yeah, I can totally put these slides somewhere. As far as the data goes, I probably will not be, I assume, making that public. But yeah. What's this? Sorry, I'm just curious. They need Java pipelines, so they didn't choose Airflow. Maybe it's because of pride, though. Maybe. Cool. Well, I see that our next speaker is here and waiting. You want to give you a thumbs up, Suresha, if you feel like jumping on now or waiting, or if you're comfortable? Do you want to just give me like a thumbs up? Or yeah. Just because I can't hear you. All right, I'll bring you up and we'll get ready for our next talk. Hey, how's it going? I'll remove this question.
Going great, Ben.
Perfect. That's good to hear. Hopefully your whole day has been exciting thus far.
Yeah, definitely.
Nice, perfect. Well, for anyone who doesn't know, Suresha, you want to give a quick background on kind of what you do right now and what you're going to be talking about? And you can bring up the slides whenever as well.
Yeah, sure. Hello, everyone. This is Sirisha. I currently work for Google and I lead the business intelligence function within the Google Search org. So my background has been in the data analytics for the past 15 years or so. Like I did data engineering, I did front-end business analytics, reporting, and also manage databases, build data warehouses and data platforms. So the whole stack. I'm really passionate about data engineering and analytics. And today I'm going to talk to you all about how to implement a self-service analytics program. Just a moment while I bring up the slides here.
Yeah, of course.
Okay. Is it on?
Oh, here. There we go.
Okay. Awesome. Okay, so to get everyone onto the same page, I'll start with defining what self-service analytics means and why it is needed. I'll then talk about the appeal of self-service analytics and also some of its downsides, especially when it goes out of control. And I'll then provide a framework that helps guide the leaders to approach launching and managing a self-service analytics or self-service BI program in a balanced approach. Note that I'll be using the terms analytics and business intelligence or BI interchangeably throughout this talk, as for our purpose, they mean the same thing. Finally, I'll talk about the main challenges and a few ways to address them. So let's get going. Okay, what is self-service analytics? Gartner defines it as a form of business intelligence where line of business professionals are enabled and encouraged to perform queries and generate reports on their own with nominal IT support. Please note here that it doesn't say anything about any particular tool. That means you can't just buy a tool and expect, or even a set of tools, and expect that the goal of self-service analytics has been achieved. So we'll get to the components of self-service analytics later in this presentation. So first, I would like to touch upon why it is needed in the first place. The traditional way of creating business intelligence in an organization is that there will be a central BI team to which business users from multiple teams and functions make requests for reports and dashboards. So that central BI team then maintains a backlog of these requests and works on them based on priority or some other approach such as first in, first out, just like a queue. The biggest problem with this situation, like any centralized model, is the speed at which the user needs can be met. So the BI team can act as a bottleneck if they cannot deliver at the same rate as they get requests for, leaving behind frustrated clients. It also results in inefficiencies as much time is spent by the BI team on fine-tuning the deliverables for each request, which requires a lot of coordination effort with the business, and also performing a lot of ad hoc and one-off analysis that keep continuously coming BI team's way. So then came the self-service BI. I just want to make sure that I have the latest version of these slides. Maybe how can I update the slides?
Yeah. If you need to change different slides, you can upload a different one and we can replace it.
Yeah, looks like it didn't take the latest link. Okay. Just a moment.
Of course. Yeah, we're just gonna replace a slide. Okay, cool. Does this look like the new one, the right one?
Yep.
Perfect. There we go. Let's get back onto it.
Okay. So these are kind of drawbacks in the traditional system of business intelligence, mainly BI team being a bottleneck, and also inefficiencies due to redundant work or a lot of coordination effort that is needed to do to get to the last mile or to get to the finer details implemented. So the self-service analytics addresses this problem by enabling and empowering business users to address their analytical and BI needs by themselves. So a wave of new generation tools such as Tableau, Power BI, Looker, and more made this possible by reducing the friction needed to create analytics for everyone. So compare these tools with older tools such as Cognos, Business Objects, or even SQL Server reporting services, if you can recall that. So they're very capable tools, and robust tools, but usually need specialized training and skills to use them, and are not really approachable by the business teams. So in the BI world, a number of self-service users in business teams can easily, with a little learning curve, can effectively use these new tools to cater to their BI needs. All they need is access to the data. So more people creating analytics implies faster time to market. So there is no more waiting in the queue for a BI team to address their needs. The data and analytics are at your fingertips. So through self-service, business users achieve faster analytics, flexibility in terms of how they can shape the output and make desired adjustments on their own easily. This promotes the data-driven culture in an organization where more people outside of IT can speak the language of data and analytics. So this results into data democratization. Data democratization is where data is directly accessible by anyone in the organization who needs it to perform their work. So does that mean introducing self-service analytics imply that organizations don't need business or BI teams anymore, and that they have become obsolete? Not at all. For one thing, a successful self-service analytics program needs the BI team. We'll see in a moment how. The BI team also benefits from self-service analytics in a few important ways. As a BI engineer or developer, you can work on more complex and high-value tasks, serve more business use cases, and basically act as an enabler in addition to just being an implementer or doer. So it looks like self-service analytics makes both business and IT happy, right? But can they live happily ever after? Maybe, maybe not. So especially if the self-service program is not handled properly. So over time, some problems might arise when there are a lot of people in the organization creating their own metrics and reports. These problems include first report proliferation. That means a large number of reports get created that no one can keep track of. Which reports serve which use cases, who manages them, is the data up to date, can we trust those numbers? These kind of questions come up often. It also leads to inconsistency in metric numbers. A metric can be calculated using different logic by different users, which happens more often than you think. Say, average daily sales is calculated by someone by including weekends and holidays into the logic, whereas someone else in another report considers only weekdays while calculating it. Obviously, the numbers won't match, and there will be a lot of discussions and why, and trying to understand what went into it, and so on. So inaccuracies and inefficiencies in the way data is queried, prepared, and reported may also arise due to inadequate skills of the self-service users. They may not always get the table joins right, or maybe not use the right visualization design, for example, and which can then lead to misinterpretation of the data and so on. So what to do? That's why it is important to think of self-service analytics as not just a tool, but a combination of people, process, and technology. So people can represent the types of self-service users based on their analytical efficacy, data literacy levels, and even goals. Process refers to things like support and engagement model, change management, and so on. Technology refers to the tools and platforms that support and enable various capabilities of the self-service analytics. You will see how these components are intertwined within the self-service implementation framework, which I'll be sharing with you all in a moment. Before that, let's take a quick look at the people aspect. So in traditional BI, it is simple. There are just two groups of people, right? BI teams who create the reports. They are the producers of the content. And end users who are the consumers. They use those content generated by the BI team. In the self-service world, we have a new group called self-service users who can be both creators and consumers, right? So in this diagram, you can see two distinct types of self-service users. power users and super users. It is convenient for me to categorize the self-service users into these two groups. So power users are those who can build reports and perform simple analytical tasks. That means with little to no data manipulation. So they just take the available data and metrics and analyze them using spreadsheet or visualization tools to answer their business questions. So basically, power users have a limited set of analytical and data skills. Super users, on the other hand, are the advanced users who are more skilled at working with the data and can perform relatively complex tasks independently. Typically, this would mean they can write their own queries to extract the data, or manipulate or transform data as needed, and even use some advanced analytical or statistical techniques and apply them to their business problems. So technical skills wise, if you can look at this pyramid, so BI team are the experts, right? So they are the ones who do this type of work day in, day out, and they are the SMEs. And then super users come next. Then power users, and last end users. So I'm not saying that end users don't have these skills, but this is a group that basically is not interested in creating any content. It just wants to consume the content. So irrespective of their actual abilities, so end users, we see them as pure consumers of the analytical content. So with that, let's see how to implement a self-service analytics program to make sure that you leverage all its advantages and be prepared for its downsides. So this is a simple framework I found useful to think about when establishing a self-service program. So it rests on 3 pillars: data, tools, and support, and needs the foundation of governance. So you might have heard about data governance, but the BI or analytical governance is not exactly the same. The governance here pertains to only the business intelligence, artifacts and processes, and so on. So we'll talk about each of these elements of the framework. Now, first, let's talk about data. So what kind of data and in which form is needed to enable self-service analytics? So data needs to be modeled to facilitate analytics by combining data from multiple sources, standardizing, cleansing, and transforming it. So the most common way to model analytical data is to use dimensional modeling, where you define a set of fact tables, dimensional tables, and you can then query these tables by joining them simply and easily, straight simple joins together, and to serve a broad range of use cases. And this is what we call usually a data warehouse if it includes a lot of data from different domains, or it just could be a simple data mart as well. The next thing is the semantic models. These models incorporate relationships between these facts and dimensional tables and enable creation of aggregated metrics as well. So which takes away the need to write any queries at all by the users. You just need to select, pick and choose which metrics you want to see and which attributes you want to slice and dice by very easily, and you can just download, or you can visualize the data. So there are several tools in the market right now that allow us to create such semantic models. And Google's Looker is one such tool. There are several others. So in this model, you don't have to write any queries at all. And the last one is pure flat tables. That means it just combines all the data fields needed for a particular use case or a set of use cases into a single table. This is also very popular. In fact, the most popular because this is the simplest, right, to use and understand by the end users. However, they lack flexibility. So because you cannot really incorporate the metric definitions within the flat tables. So BI team needs to continuously update and manage these data models and assets so that self-service users can build analytics on top of them. So without these analytical data models and data sets, self-service cannot be successful, as most users struggle to find and get the right data and likely do not want to undergo this effort by themselves, even if they have the skills. So, you all know, data engineering sometimes can be tedious, and it's a specialized skill. Another key reason why these analytical models need to exist is to provide a single source of truth for data. And everyone uses the same set of curated data for analytics and reporting. So this kind of addresses the inconsistency downside of self-service analytics to some extent. Okay, next we'll talk about tools. What kind of tools need to be provided to the self-service users? So I can think of 4 major categories. The first is the data exploration tools. Users want to explore the data in an intuitive way to understand how different data points are related and how they look, general trends and patterns, just to answer any ad hoc questions very easily. Right? Another set of tools is for reporting purposes. That means to create beautiful and effective reports and dashboards that you can, consume on a regular basis. So many BI and visualization tools allow both capabilities. For example, Looker has an exploration interface and a dashboarding interface. Likewise, Google's Looker Studio also has 2 different interfaces. And other such tools, even Tableau, Power BI, also enable both quick explorations as well as robust dashboard building. Spreadsheets are another flexible tool that are inevitably used in any organization to do a wide range of activities, right? From data augmentation to data manipulation to exploration, visualization, and analysis. It's completely versatile. So last but not least, a self-service program also should provide tools or platforms where users can build and run their own SQL queries. The exact number of tools is not important. It could be just one platform rolled into one, maybe all except spreadsheet. Spreadsheet is its own application, right? Or you can have more than one for each capability. As long as users have the capabilities to perform various analytical tasks and have some choice, things work out well. Because it's very important to give a user's choice as well. It's not uncommon for an organization to make available multiple exploration and visualization tools, right? So you just need to balance between the overhead of managing multiple tools with providing flexibility and choice to a wide range of self-service users. If in case your user base is so small, just stick to one exploration tool, one exploration and reporting tool, and maybe one spreadsheet application, which you'll be using Google Sheets or Excel. So spreadsheets are here to stay. So people are going to use them for data analysis, whether you like it or not. So, let's not try that. So the next pillar we're going to talk about is the support. Supporting self-service users comes in 3 different forms: training and learning, consultation, and creating a community. So thinking about and providing these forms of support is critical to successful adoption of self-service analytics. Support should be as important as data and tools and should not be treated as an afterthought. So conduct trainings and provide learning avenues where users can pick up analytical skills like general concepts such as metrics and visualization principles or SQL and so on. And training the users on the data models and the data sets that you have created. Allow them to understand what is available and how to interpret and use all those data assets that you have created. So also make sure that you train the users on the chosen self-service tools. So exploration, reporting, querying. So don't just assume the user efficacy in these aspects. So please get inputs and tailor the training to their needs. The next type of support is consultation, where you make yourself available when you say you like the BI team, available for them one-on-one or in small groups to answer their specific questions and help them out while they carry on building their reports or analytics, right? So regular office hours are one such way to provide that forum. Finally, create and manage an internal community for the self-service users, where success stories can be shared and challenges discussed. An active and vibrant community helps with generating and sustaining momentum. So with that, we talked about the 3 pillars: data, tools, and support. And these should be supported by the foundation of governance. The way I see governance, especially the AI governance, is it establishes guidelines and standards for development of reports and analytics. Like as I said, like these are just guidelines. We are not enforcing anything, but it helps with the standardization and making sure that the content is created with quality, right? And also maybe guidelines on the security frameworks and recommendations on how you should think about security with sharing this content. Just do not make it accessible throughout the organization, understand the data classification and so on. It also defines processes that help with proper analytics lifecycle management, such as operationalization or productionalization, because many self-service users are interested in just solving their problems. They may not have the right skills or intention to scale it or to make it more robust or have an on-call support or something. So BI team can jump in wherever the content is so important and is garnered a lot of user base. So BI team can help the self-service users with that process as well. And also assessing and certifying the content generator, right, based on the quality or adherence to guidelines and best practices. So, and also tracking the usage of the reports generated, because we talked about it, like, with self-service, you will see a proliferation of reports, like there will be a huge number of reports created. So you will have to track the usage, because I think the reports become obsolete as quickly as they get generated in some cases. So, it helps, like in BI, helps with this tracking mechanism of usage, and also initiates deprecations of older reports so that no one will go and make incorrect decisions based on stale data or inaccurate data or whatever. So this kind of life cycle things BI team can help through the governance framework. Analytics portal is a useful platform, so that provides a one-stop shop of all created and curated content, which makes finding the content easier for everyone. So it can be a simple web portal, custom built for your purpose, or something from you can get from off the shelf. I haven't seen many BI portal tools out in the market, but I know there are definitely some. A portal should include content from multiple. So if you use multiple tools to generate the content, it should be able to surface the content from all the relevant tools and different kinds of content. It could be SQL queries, it could be a reported dashboard, or it could be a particular analysis done in spreadsheet, or any other related analytical content that can be used broadly by more number of end users. So coming to the portal, as I said, it can be a simple web portal, or it can be like a wiki of links to the content. Basically, you're building a repository, right? Repository of reports and analytical content. So you can also build or have sophisticated implementations that can include a better UI, or ability to mark content as favorites, or search for the content by keywords or natural language. And you can have a centralized alert systems for the users, and ability to view content and request access if they don't already have access to it, and also even recommend content to the user based on their domain and the past reports seen and so on. So you can go all the way. So that's about analytical portal. And one of the major function of governance is to facilitate the creation of a business glossary and manage it. A business glossary defines all the metrics and data points used for analytics. Having such a glossary enables consistent application and interpretation of metrics. It can include business metadata such as definitions, business owners, data sensitivity, and so on, and technical metadata such as calculation logic, or data owner, and data sources. The audience of business glossary are the end users and the self-service users, so mostly from the business teams. So the information provided in it is tailored for that purpose. Business glossary is similar to a data catalog, while data catalog is a broader system where you create and manage metadata at the data level, that is tables and fields for the entire data ecosystem in your organization. On the other hand, business glossary is oriented towards enabling data analytics and aims to provide a common language or terminology across different business teams. So, with that, I just want us all to revisit the framework diagram for a moment here. So, have a plan for each of these elements: data, tools, support, and governance when implementing self service analytics in your organization. Okay. So, lastly, I want to mention the key challenges that can be faced in this program. There are only two major challenges: either there is too little adoption or too much adoption. Okay. So, if people are not jumping onto the self service wagon once you introduce the tools, maybe created the data assets, and just you opened your shop and no one is coming in. So, there are a few things you need to check for and address. So maybe not many people know about these awesome platforms, artifacts, and resources that you have created, right? So evangelize. Increase the awareness of what is available, how self-service analytics can benefit them, and what is the art of the possible. Like what can the users do by themselves and get empowered. So enlist champions and early adopters to share their success stories and learnings. The other reason could be that the users do not have enough skills. They are not comfortable working with the data. So, in that case, educate them, make them more data and analytic literate. Finally, be approachable. Provide multiple options of support, like one-on-one office hours. There could be online or offline Q&A forums, or create a knowledge base. Organize some group consultations, like whatever the users need. On the flip side, if the program has been so successful and you see huge adoption, can that be a good thing? Like it's a good thing, right? It's not a problem at all. But it can be a problem only if you're not prepared for the scale and the growth. That's where a robust governance model becomes a lifesaver. The defined processes and tools help you manage the volume and the growth in adoption by providing guidance and oversight to the self service users, enabling common understanding of data. As the usage increases, you need to make sure the support model can scale. So, meet the users where they are, provide the right level support. It could be reviewing a finished product and certifying it, or unblocking technical issues, or providing solution design, or some other help that the users need. And leverage champion self-service users to scale the support needed widely for the community of self-service users. So these are a few things that you can do to address these two scenarios. If you notice, you can see how the framework proposed earlier incorporates all these aspects, right? So if you have done things right, you are completely prepared when these challenges come up, and you have all the right tools along with you and processes. You're equipped with the right set of tools and processes to go through these challenges, address them, and make the program successful. So thinking along these key pillars and foundation has helped me in my self-service implementations. Hope it helps you too. Thank you for listening.
Thank you so much for sharing. There's a lot to take from there. I think one thing I really liked is you talked about this, like the problem of being successful, right? Like it's like, yes, now you're successful. Now you have to deal with a whole other problem, which is all the requests that are going to come your way, or not requests, but like all the data that's going to be getting pulled, and like, can your infrastructure handle it? Can, everything handle it? So that definitely becomes a problem very, very quickly. So no, I think that's funny. Also, I just thought this was funny because someone posted this earlier, and there, Sarah was like, "This section is speaking directly to me." So you're definitely connecting with some people who are really feeling, the struggles. of self-service analytics and so forth. So thank you. That we do have a few questions that have kind of come through. Let me see. Here's one. So how are schema changes communicated in a self-service analytics model? Field being phased out, or et cetera, things like that.
Great question, Daniel. So yeah, this should be part of your support model, right? So that way you should have like continuous engagement with your self-service users, providing trainings. Part of the trainings that you would be giving to them is about the data itself. So it's a cycle. You expand the data models and data assets, reacting to the request coming from the business. But then again, you have to educate to the entire group of the self-service users to tell them like when those updates are ready and how they can use them. So it's like it never stops. The training part is a continuous thing. It doesn't stop like when you just introduce the program or launch the program. You have to do it on a regular basis because change is constant.
Yeah. I think you brought that up earlier, right? Like by the time you finish your current dashboards, people already want things different. And same thing with tables, right? By the time you've deployed your current tables, the software engineering team is like, oh, we actually want to do things completely differently now. We're going to add new fields, change fields, whatever, break everything that you've built. So
it's always a catch-up game then, yeah.
Someone asked, where should someone start when developing a self-service analytics process? Someone being Ben, someone, not me.
I hope I provided a basic framework to help you think about when launching a self-service program, right? So first of all, you need to understand your users and the need. Like, do you see those bottlenecks in your current model where there is no self-service analytics, right? So once you feel the need, that means you have to get it. But what are the things that you need to do? So you need tools, you need data models, you need to take time to build those foundations so that you're not reacting to each and every need of the users. You're just giving them well-modeled data that the users can take and use it for their own purposes. And again, as I said, like support, like you should view yourself as partners with the self-service community, and so you're becoming an enabler. So there will be more work for BI team in the self-service environment because no one is taking away anything from the BI team with a self-service program. So I would encourage you to think about those three pillars: the data, tools, support, and also the governance, which is a collection of guidelines, processes that help scale the program and also manage the quality and centralization and ensures that there is consistency in the way self-service use this data and analyze it.
Yeah, I think one thing you also brought up was like support, and that made me think of like at Facebook whenever I was like launching a new like data model, so to speak. Like I do like brown bag lunch kind of things 2 or 3 times where I'd be like, hey, I'm gonna, we're relaunching some data, or we're gonna whatever. Let's have conversations with the analyst. Anyone that's using this data or wants to use this data, like come please. Almost like this kind of a situation where we just like, let's just talk through it. I'll tell you what my thoughts are. I'll tell you what the tables are. If you have questions, you can answer it. But like you said, it's a little bit of everything. Sometimes you still have to do like some one-on-ones occasionally, but it helps at least scale out supporting everyone. So
exactly.
Also, someone's asking a hard-hitting question here. It's very, very hard-hitting. Do folks use Excel at Google?
I don't think so. I haven't seen it myself.
That makes me think. So I used to one of my first jobs out of college, or while I was still kind of in college, was teaching kids to program, and I was in Seattle, and then I was on the Redmond side, so right by Microsoft, and the school districts in that area couldn't access Google, or it didn't work. Like you could you could use Microsoft Bing, and a kid came up to me and asked, like, should I Bing something? Like, should I Bing it? I was like, what? Just like a funny little poke in both directions. It's like, yeah. You know,
Yeah.
everyone. I'm sure you guys don't use Excel or try to avoid it. Or, Google Sheets is good, and same thing with that.
Yeah, I
so.
can't speak for the organization, but as I said, like I haven't seen it myself.
Yeah, that's what it is. No, it's just funny. Let's see, where was it? What's the best way to implement? Here. Let's do this one. So metrics definitions. What's the best way to implement change management for like metrics definitions?
I know that's one of the problems that I'm dealing right now. It's not easy. You just have to plow through, right?
Mhm.
So one thing that I'm trying to do is have a cadence of reviews and updates to the glossary. So you have to, like, maybe once a quarter. You can decide the cadence, like it's once a month or once a quarter or once in 6 months. But at a regular cadence, you revisit the glossary and have the business owners. That's why you need to identify the business owners and the technical owners for each metric, and have them review if has anything changed. The technical metadata could change, maybe because there is change in the source systems or in the data lineage or whatever. So the field names change or whatever. That is the technical metadata changes, but also the business might want to measure a certain metric in slightly different way because the business itself changed, the process changed. So just have a regular cadence and establish that ownerships. Identifying owners is really, really important because they drive the accuracy. Like they make sure that it's up to date, and they certify or approve that these are the definitions that we align on and agree on.
Yeah. I think ownership, like that's always the big gap in general. I think in the data space, just like who owns what data. Even when you have data engineers, like I remember, just again going back to Facebook, there'd be times like I'd look through our data catalog, find a table, be like, oh, this table looks perfect. There's an owner on it. Let me go ping them, and they'll be like, I haven't worked on this for 6 months. I'm on a different team now, but like no one else took it. And so that was always like a big thing. Whenever anyone left our team, the first thing we did was like, all right, all those tables, make sure they go to someone else, because it just creates so much chaos when people don't know who owns what. But yeah, it's ownership's important, and especially metrics as well. The other thing you brought up, the portal.
Yeah.
I think every like large company, so Facebook, and I worked at a hospital, has always tried to build their own. So I always find that interesting. They always end up trying to build something where it's like you have your Tableau kind of and Looker kind of portals, right? But because you brought up earlier, everyone has every BI solution, right? Like every company has like Tableau, Power BI, Looker somewhere. What ends up happening is you end up having to build a portal just because you just need to link what's the actual important dashboards and like make it easy to search 30 different places. I think there are solutions. SelectStar, I think, does it as well, where you can do all your BI tools. But yeah, it's definitely something I'm seeing more and more. People just build themselves because they're like, oh, we just need to have some concentration of this knowledge. So it's definitely a big thing.
Yeah, we need more tools in that domain.
Yeah. How is it like? So I like, with your work with Looker, are you guys finding, I don't know, people can find everything easily? Like, I'm just curious on your background there.
So yeah, if we use Looker, then all the content that you can see is within Looker. Of course, you can search, you can organize. I think pretty much any BI tool provides you with that capabilities to navigate their tool and find content easily. But the challenge becomes when you want to combine different types of content. So in the absence of a choice of tools, or you can't get anything off the shelf, then just start with kind of a wiki kind of thing, bare minimal, like maybe just a Google site, like you list everything so that at least you have a repository, and slowly build functionality if needed.
Yeah. Okay, so Ryan Boyd, which I don't know, do you know Ryan Boyd by chance? Do you know DuckDB by chance?
Yeah.
So okay, so he's just connected with them. Well, Mother Duck technically, but his answer here, to find out whether Google uses Excel, talk to the finance team. I'm like, yeah, that's where it would be used. That's exactly where it would be used. So he also then pointed out, one fact, he used Outlook for email when he started in 2006. So
Yeah, so
But that was before Gmail, I assume. So it's like, yes, technically, but also Gmail probably didn't exist. I remember hearing the story, like how that like happened. Like the guy like started with like one thing. He just like, I just wanted to like centralize my email somewhere. So he built something that just did that and slowly built out Gmail.
Yes.
If anyone wants to hear an interesting story or like a great idea of how you like MVP something into a actual product, that story is really, really interesting. So it's really funny. Was it thinking? Yeah, I think at Facebook there's a few things like we fought really hard to not use like Google Drive and Google Sheets, and then eventually people were like, we're not going to use. I don't know what we were using before, but we're like, we're done with this. we want actual, the real thing, the real Google Drive kind of solution. So it was very funny. But we were using something else before because I think they just were being stubborn. So it was very, very funny.
Yeah, tools can be sticky sometimes. Yeah,
they can be sticky, and everyone's like has opinions. How do you recommend people like pick tools when? Because I assume doing self-service analytics, there's a lot of options. Do you have any recommendations?
Yeah, you can choose your own tools. As I said, like from the data exploration and the visualization perspective, there is a good choice of tools. So I've used Tableau in my experience, and Power BI and Looker. These are the three main tools that I've used, and of course the Microsoft tools before Power BI as well. So all are equally good. I think you just have to see what you want to do, and because most of the times these tools also come with broader capabilities, like they have some basic ML, they have some data preparation capabilities, and Looker has semantic models. So you just have to look at what problems that you're trying to solve, and also your user base, like what they're already comfortable with. If there is a history of some type of tools or technology, it could be easier to introduce that as well. And as I said, you need not just use one. The most modern tools are web-based and cloud-based, so they're easy to bring in and train. And also, if it doesn't work out, you can change, because the BI tool at the end of the spectrum, the whole BI architecture is lightweight in a sense, like unless you create hundreds of reports that you want to migrate. So usually you don't always want to migrate all the reports, because reports get obsolete.
Yeah.
Yeah.
Does Google have anything to like manage some of that? Like with tables at Facebook, it was easy. They would like, if no one's used this table for like 90 days, you'd get a message and say like, we're going to drop this table in like 15 days, like the person who owned it, and then eventually they delete it. Do you guys do that with reports or anything to kind of try to like clear all the clutter of forever, like the dashboard kind of graveyard?
For the reports, I don't know. Definitely there's data. There is more capabilities and features to understand what is happening, and have accountability and so on. Reports, I'm trying to implement that for my team.
Yeah. Do you guys do fixathons? Like that was one way we try to approach it. Was like, all right, we'll just do a week where you get points if you can delete a dashboard, right? Like if you can delete a dashboard, you get points.
Yeah. I mean, we usually do that for software projects, right? Software engineering projects. I haven't thought about it yet. Maybe I should try it. Like, maybe we have this 100 different dashboards, and no one has seen this 300 dashboards in the last 1 year or so.
Yeah, it's like it's all just tech debt waiting to get fixed. So yeah. For the data, it was different for the data team than for the software team. For the data team, it's usually like, were you able to drop tables?
Mm-hmm.
Did you get rid of pipelines? Did you delete
Yep.
whatever? Did you standardize something? Like there was a lot of things that like we went through a lot of migrations, like between Python 2 and Python 3, and so there was a lot of like little things that we had to remove during that whole process. So yeah, there was a lot of ways. My manager always had some sort of cheat code where he's like, oh yeah, I just did this thing with a code mod, which is just our ability to like automate like 1,000 changes all at once. So he's like, I got 10,000 points, and he won like 3 or 4 of the fixathons in a row. I'm just like, okay. So it was always fun.
Yeah, definitely. We need to clean up from time to time, right?
Yeah.
Not only our houses, but also our data and reporting.
Yeah. Let's see. Here's another possible question. For the semantic layer, did you see any major advantages using cubes? Whether that's Apache, Kylin, or maybe just in general, some pre-aggregations or aggregated tables. Do you guys rely on them?
In my experience, they're just more flexible.
Mm-hmm.
So you still create those predefined metric definitions because some of the technologies, it's not always easy to create them, right? The one who creates the semantic models needs some skills and so on. But it's very easy for the end users to actually leverage those multidimensional models or tabular models, the semantic models. So just you can address a wide range of use cases with a well-built semantic model.
Nice. Makes sense. And then maybe I think we're actually. Let me see. Are we out of questions? How are schema changes? We did that one. Did this one? Okay, so this is less. I just like to hear your thoughts. This has nothing to do with self-service analytics. Well, actually, maybe it's more this one. How will ChatGPT affect the future of data analysis? Any thoughts? Any thoughts there?
Got me off guard completely, right? Because I haven't got a chance to experiment with it myself, and I was thinking that okay, this weekend I should do something about it. Okay, yeah, just if I take a moment without really understanding the limits of ChatGPT, maybe like interpretations or summarizations that generating insights with, right? With reporting, that is not the end of anything, right? Reports or data, everything is a means to take an action, and that means you have to generate insights out of all those reports and analysis that you do. So if ChatGPT can help with that insight generation, I think it would be a great thing.
Yeah, I've definitely poked around with it. It's interesting what it can do with like SQL requests. I think that's definitely like some people are like playing around with like giving it like, if I have this rows of data with these column names and so on, can you write me a query to do something? And it's not terrible. It definitely, I think in the future we'll finally maybe get to that human text to SQL generation. I've seen it. I've seen those companies exist for like a decade, and they've never fully caught on. So maybe this will finally be that layer that's required. But it's always hard. It's a hard thing to do.
Yeah, that's interesting when you say SQL generation, right? And you mentioned there are SQL builders tools that enable. So what it basically needs is a good model. If your data is modeled in a dimensional form, for example, then it's easy to create queries.
Yeah.
Right? But if you have like very haphazard set of tables, then your query becomes so complex, and without any keys or primary keys or foreign key relationships or something, and it is complex. Then you have to write subqueries and have like a multi-layered SQL queries. So interesting to see if ChatGPT can solve that problem.
Yeah, and then like can you the user provide, like especially for the complex things, right? Like when it's like give me the average sales for whatever regions or something. That should be an easy query for anyone to write. And yeah, let's get rid of those. But yeah, when you have those complex queries where there's like, they showed them earlier, right, with the Monte Carlo talk, where it's like 9 CTEs.
Yeah.
Can it do it? Like, and can you describe it fully? Yeah. Or is it harder to think of the description of how you would generate that than it would be to do it? So
as I mentioned, like in addition to the SQL generation, I'm more interested in if it can help with the insight generation and help the analytical process point as well.
That's okay. Now I see what you're saying. That would be interesting. Yeah, if you can like actually like, based on this data, what should we be thinking about? Not just like, here's the query. I think the other thing I like to point out with that is you still always end up with the model. It's not necessarily easy, but the model is done. The hard part is the good data sets. So finding those good data sets, those solid data sets to put models on top of, that's always going to be the hard work that no one wants to do. That's why data engineers exist. also just because someone said this. So Quip was the solution we used at Facebook prior to Google Sheets. I remember now. So,
Oh, wow.
so Vitor must have worked at Facebook because we used it. We were trying. I think they were also like an ex-Facebook person, and so we were trying to support that. And eventually, we gave in. One more thing. So on this presentation, I have your book. So sorry, I didn't use the exact slide you gave me, but hopefully that's okay. Yeah, I mean, like I'd love to just, before we kind of, the next speaker will be here in the next 14 minutes or so. Love to know a little bit about your book, kind of why you put together, and kind of just a little background on it.
Sure. This book is about building good data stories, dashboards, and reports with Google Looker Studio, but it's structured in a way that you get enough foundations of data visualization and data storytelling to get started.
Mm-hmm.
And also, I give a structured approach of how you should think about when building a dashboard or a report. So don't jump into developing the report right away. So take time to first determine the objectives of the dashboard that you're building, the target audience, their goals, and what are they trying to achieve and are expecting, and what are the key data sets or data domains that would help answer those business questions. So spend time, take time in that determine phase. Like when I say that determine, design, and develop, this is a structured approach. And then once you determine all these, then you basically design the layout, the right visualizations, the metrics, and all the things that you want to be part of your dashboard. So basically at the end of it, you will have a clean wireframe as well. And only then you just start developing. So that will make you keep your focus always on the objective and also the right design principles, so that at the end of it, you would need fewer iterations. It's always an iterative process. It doesn't mean that you can't go back and change the design or adjust the requirements as you go along, but it will allow you to not miss any of the best practices or design principles that you need to apply that can make your dashboards and reports much more effective. So I think that part 3, that book is divided into 3 parts. The first part gives you the basic concepts of data storytelling, visualization, the pitfalls you need to follow. And the part 2 talks about the Looker Studio tool itself, like all the features from basic to the more advanced features like data blending, parameters, and so on. And part 3 here of data stories, like where I take an example data sets and walk you through this 3D approach of determine, design, and develop. So, and my intention is to give you the thought process also, not just, like I already made up my mind that, I want to do this, so I'm just telling you how to do it. It's not that way. Like, how do you define or decide like what to do, and what are the things that you would be thinking about during this structured approach? So I hope that would be helpful to any, aspiring data analysts or even experienced data analysts or business professionals for that matter, to benefit from this book. So Looker Studio is a free tool. So even if you don't use it today, I think you can easily get to use that tool. You just need a Google account and start away.
Yeah, I think one thing that resonated with me was when I first started out at my first job. I had gotten released to the wild on Tableau, and like my brain was like, cool, I'm just going to build a ton of dashboards. And I think probably within like a week or two, I probably built like a dozen dashboards just because, you're just like, oh, this is what you do. You gotta pump out things. And then you slowly realize a few things. One, you have to maintain those dashboards, which is much harder than just building them. And then 2, it's like, why did you build them, right? Like you never asked why. You're just like, someone wants to know some things about these numbers. I'll just build a dashboard. Mm-hmm. So yeah, I definitely think having a process around building dashboards is really important, and it's something that doesn't, it's already not covered in schools, and so I imagine it's very helpful to kind of pick up. We did a few raffles for it earlier, so we've got at least a few people that will be getting a book. Yeah, we can maybe do a few more now. If you want to, I have a random generator. Where to go? It's somewhere here. I have a random picker. Here, random name picker. I will just share my screen, and we can do a few more. Let me remove this. Present. Share screen. Let's go here. All right, so we're gonna do a few more kind of raffles, so to speak, for Shiras's book, and then hopefully the next speaker will be here shortly. So let me just run this. I'm just doing it over the numbers of the Eventbrite IDs because, again, I didn't want to put your guys' emails in some sort of text box. That would just get who knows where it goes. All right, I didn't hit pick random, so I'll hit pick random. So it will, let's see. And the ID. All right, I'll figure out who this is right now. This is, he connects to Sharara Khan. So I will put that down in my little notes that I'm holding for this. And maybe we'll do one more, and then we can kind of probably go into some Q&A about more data engineering. Let's see. And then, let's see, this is Prajwal. I'm not going to try that last name. That's going to kill me. Prajwal. I'll email you guys all to see how I can get you these books. I think with your book, right, we're doing it through Pact, so they can do a digital copy, correct?
Yes.
Perfect. Let me remove this. Yeah. Well, thank you so much. Do you have any questions for me before you head off?
No, this is great. I look forward to watching all the other sessions as well. This is great. Happy to talk to you all.
Perfect.
And good luck for the rest of the day.
Awesome. Thank you so much.
Bye-bye.
Bye. All right. The next speaker is here, but let me answer a few questions that people asked really fast. Let's see. Okay, someone asked, which certification is recommended for data engineering? It really is going to depend on your overall goal. If your goal is to get a job, I wouldn't focus too heavily on certifications. Like they're great. I feel like certifications are more useful for people who maybe are already in the field. But if you do need a certification, I think either the IBM data engineering cert, besides the fact that they use older tools, does a better job introing what data engineering is. But if you want to get an intro, you can also look at the book, Fundamentals to Data Engineering, but they do a better job. If you want what I consider almost a slightly more useful or practical one, I'd pick any of the modern cloud data engineering certificates, whether that's Microsoft's or GCP or AWS. They're all going to be valuable at some point. I always recommend people don't heavily index on certificates because they're more useful after you get a job than they are trying to get a job. Usually to try to get a job, I'd say projects are usually better, or at least balancing some projects with certifications, because certifications can only get you so far, especially if you don't apply it somewhere. Okay, let's see. This is ChatGPT, 2 ChatGPT questions. Did this one. Let me see what other questions, if I'm missing any, trying to get through. Oh, and Nilesh has said, yeah, open source contributions help too. If anyone wants to know more about open source contributions, you should ask Nilesh. He's contributed to a handful of projects, including Iceberg and Hive and a few others. So he's definitely got experience putting that together. Let's see. Someone's asking about the current market conditions for DEs. Yeah, it's definitely a little more tumultuous. It's hard to deny that. It doesn't mean that there aren't roles. Does it mean maybe the tech companies that were paying a little more might have a few less roles? Probably. But there are plenty of other companies, insurance providers, healthcare providers, banks, etc., that are likely hiring in these roles as well. So data engineers will always be needed. People will always have questions. It's the kind of work that is ambiguous and kind of hard to kind of capture unless you're experienced in the space. So it's harder. It's always hard to break in, especially as a new DE. I'd say maybe try to go into the data analyst or software engineering route and then go a little more lateral into that position. But I wouldn't maybe get too stuck on becoming a DE straight out of college, just because it's a balance. You'll eventually get there. You don't have to rush too fast. Hold on. I'm trying to think if there's any other questions here. Looker plus BigQuery. Someone likes Looker plus BigQuery. Let's see if there's anything else. Oh, yeah. And then someone asked about the online recommendations for courses. And I have a few videos on that, so you can look those up. There's also like a data engineering roadmap that I have. So all of that is on the YouTube channel, and you guys can totally dig into that. All right, so we're about to get ready for our next speaker. So I'll kind of give a few seconds here just so he realizes I'm talking about him. But I'll bring him up here on stage here. Let me get rid of this question, and then let me add him to the stream. Hey there, Stefan. How are you doing?
Good. Hey, Ben. How's my audio?
Your audio is good. Your audio is
Awesome.
good. Let's see if it's
Sweet.
tracking. I think, yeah, perfect. Yep, it's good. How's your day going?
Yeah, not too bad. Not too bad. Nice day in California here today. Not much rain as opposed to the last couple of weeks, but yeah.
Yes. So I was there. I'm still confused by people. Like, I did see some pictures of flooded roads, so I don't want to say it's nothing. And there's definitely mudslides. But when I was in SF, all I could think of is like, this is just Seattle weather. Like y'all are just complaining because you aren't prepared for it.
Yeah, I mean, yeah, that's true. That's true. I mean, for those who don't know, it doesn't rain quite that much or often in San Francisco or in California in general. So the last couple of weeks have been pretty wet.
They've been pretty wet. And another fun fact when I lived in SF is I found that, well, technically in Menlo Park, but I found that water would just sit places because there's like terrible drainage. Like there's no city planning for drainage. So that's one of the major problems that I've noticed. So it's like, yes, you're flooding, but you also have like not great planning on how to get rid of the water. So
yeah, I mean, like in San Francisco, someone spun up a website to adopt drains because part of the problem was drains would be blocked with like leaves and other debris, and so they were trying to get like people in the community to adopt drains so that they could clear them out, so that when the rain came again, it didn't actually flood because it actually could go down the drains.
Yeah. So yep, it was fun, but I enjoyed. Oh, I have it on. Okay, cool. It was fun. All right. Well, I think we can probably get started with your talk. I'd love to kind of hear from you. So feel free to kind of bring up your presentation and we can kind of go from there.
Yeah, let's do that. Let's share screen.
I can add this.
Awesome. Cool. Yeah, so let me start my timer and stuff so I know how long I've been talking. So I'm excited today to talk about Hamilton, which is a little kind of Python micro framework that I open source at Stitch Fix. Part of the things that I'm excited about is that I think it kind of natively brings software engineering best practices to Python data transforms without you having to really think about it. In terms of my background and kind of how it came about, so I was at Stitch Fix for the last 6 years, essentially being engineering for data science, trying to build the MLOps machine learning kind of platform stack for data scientists to be self-service. So we wanted to enable them to prototype, productionize, and then be on call for what they did. And so I was kind of have been thinking about how do things integrate? How do you make things simpler and easier? In which case, Hamilton was just one of the things we built in open source. Otherwise, at past lives, I was early at Nextdoor and early at and at LinkedIn. So have kind of been around the block, but otherwise just recently I started a company called DAGworks, DAG for Directed Acyclic Graph. And so we're currently in YC's current batch. Otherwise, in terms of questions, Ben, happy for you to interject or interrupt, else I'll just be kind of monitoring the Discord channel afterwards.
Perfect. Yeah, and they'll also there'll probably be more questions coming from the YouTube side. I was hoping people would be more in the Discord as well, but
Sure.
No, YouTube works great. It
Yeah,
puts everything in one place.
Awesome. Okay, don't listen to me. YouTube works. And so with that, I'll get going. At a high level, the TLDR is that, if you're doing any data transform work in Python, then I actually think, Hamilton should be something in your back pocket that you should know about and have, and because it could help potentially structure your code base and make your life a little easier and simpler. It is Python based, so pip install SF Hamilton to kind of get started. It's really has a small dependency footprint, and the hello world should take you less than 15 minutes to kind of get up and running. And we have a bunch of docs here as linked. So in terms of the agenda, I want to kind of first motivate the story of the data scientist pain. So like why Hamilton came about, and why I think things were challenging for this kind of data science team to write Python transforms and maintain it. Then talk about Hamilton itself, Hamilton at Stitch Fix, some general to give an overview of like general usage of it, and then kind of dive into a little bit more detail as to how Hamilton kind of helps bring these kind of native software engineering best practices kind of naturally. And then to finish, summarize, and then talk a bit about kind of the open source roadmap that we have for Hamilton.
Awesome.
So the backstory is at Stitch Fix, it was a really old model. It's one of the oldest teams, and it was basically modeling the business and providing forecasts for it so that the business could make operational decisions on. And so their kind of pipeline workflow looks something like the following. So they got this team got business actuals, they spend, marketing spend, signups, etc. They then had to create a featureized data frame. So you can think of it. So I'm going to use data frame and table here interchangeably. Same with feature and column. So if you do get confused, I mean kind of a table with columns. That was fed as input to fit a time series kind of model, or to fit a bunch of them. These models predicted the future, and then that team basically gave the business forecast that they could make decisions on. As I've highlighted here, the biggest problem in terms of this workflow and delivering for the business was actually in kind of creating and managing this featureized data frame. And so this is the genesis of why Hamilton was created and what it helped solve. So just to give you visually an idea, so why was this data frame creation, a complex or a problem for this team? Well, it's very easy for time series forecasting to create better models. You need to create more inputs. And one way to create more inputs is to derive it from other inputs. So say if you want to create kind of an indicator, kind of a flag or variable for input, you will be, say, deriving it from year and week. And so in a nutshell, columns are functions of other columns. And so then this can, so if you want to create a new feature, you'll grab some other subset or set of columns, transform it, and then then you can successively use those outputs as inputs to other features, etc. And so this kind of chaining occurs. And so managing, I guess, the number and this kind of complexity of how things chain together was really what the team was kind of struggling with from a software engineering perspective. To be concrete, the task, say, was to create a training table to fit a model. The script kind of looks something like the following. So at the top of the script, we're like, load data. So get the amount of spend, marketing spend, get the number of signups, right? And then maybe the script had some configuration passed in, and then there was some conditional logic as to like, oh, okay, if this is running for the UK or the US, then we should have some different logic used. Then there's a bunch of you could say features or columns kind of created using inline transformations, and then maybe there were some functions that would be delegated to. These functions maybe would take the entire data frame, maybe they would mutate it, or maybe they'll just return a single column or use subsets of it, and then at the end this data frame would be saved. And then used for fitting a model, right? Now, I want to say this code looks pretty innocuous. You might be wondering, like, what's the problem with kind of maintaining this code? But I want to say if you scale this to like thousands of columns, so the script gets super long, and then a growing team, so a lot of people touching the same code for like many years, you're not going to like the state that you're in. Specifically, like if you write code this way, there isn't a good unit testing or integration testing story, right? If you have these inline kind of function or inline transformations, there isn't really a place to unit test them. Similarly, for integration testing, you generally want to, say, test one particular path. But here, if you've written things in this kind of script form, you have to test everything just to test one thing. And so then integration testing becomes more costly as things, evolve and kind of progress over time. And then from a data quality perspective, you got to then figure out how to connect, the outputs of, this final data frame with the computational logic that kind of happens within the script. Needless to say, that's, easier said than done. Then from a code readability and documentation perspective, if you want to understand, why average 3 weeks spent is a feature, not average 6 weeks spent, well, maybe there should be some doc string. But if you write things in this kind of script form, like there isn't a natural place for documentation. Sure, you could use some sort of annotation, but then, there isn't any kind of, standardized or structured way to kind of to do so, or anything that kind of entices people to write documentation, right? And then, as I said, there's this kind of chaining that kind of happens of inputs being columns being inputs to other kind of columns. You then have to, as the script grows or code even, is pushed to other functions and things, it's very hard for you to keep in your head like how things relate to each other, because it's not obvious as to what's what's required to compute something, or even to know like what's downstream of it, such that if you were to change something, what do you need to know? What things do you need to test or check to ensure that you haven't kind of broken into things? And so there's a bunch of so they suffered from this problem. And then say you wanted to create a new TL or a new pipeline, but you wanted to reuse a bunch of features or transforms or logic. The option was one, append to the script, or cut and paste and pull it out into another place. Cutting and pasting, sure, is very easy, but then you kind of duplicate the problem of code maintenance, having multiple definitions, multiple same blocks of code in the same place that just make it much harder to maintain or understand which one's used where. And then this directly impacts kind of onboarding. So if you wanted to start on the team, it took you a couple of months to get productive just because of the size of the code base and the script and things you're dealing with, right? And this directly translates to kind of debugging issues, since you have to intricately understand and have walked through the code many times to be able to kind of make heads or tails of like, oh, how do I figure out what's wrong with this output? Since the only way to do that is to kind of go through this kind of spaghetti mess of code to kind of understand it, which is challenging. So given that that was the state that the team was in, what happens now, just to give you a bit of a sense, like, when Stitch Fix pivoted to a new region, they actually had a lot of work to kind of change or modify that kind of script to kind of make it expand and support new regions, right? When management came and go, oh, if we did some marketing spend that added X amount of features or users or whatever, they would have to go model it, but that's not a simple task in this kind of code base where it's very unclear about dependencies or what you need to add. So they might think they're tweaking some part of the code base, but in fact, they're actually kind of breaking something without kind of realizing it. And then being under the gun and kind of trying to debug things was kind of not fun. I want to say this experience likely isn't unique to just Stitch Fix, or even time series forecasting, or even pandas. But and so, which case, Hamilton, I think, was what we threw up with to kind of help with these problems. So specifically, the aha moment with Hamilton was that kind of the idea was, for every output in this kind of final data frame, what if we could make it correspond to exactly one Python function? And then what if we could actually then, we could also determine the dependencies required to compute that transform from the way the function is written. So in Hamilton, the paradigm, and I say paradigm because it is a different way of thinking, kind of doing things. The idea is that the output that you want, say a column, is determined by the name of the function, and the dependencies that are required to compute that kind of transform are determined by the input parameters. So specifically, rather than writing code in this old way, so say assigning column C from some in column A and column B, assigning column D from some transform of column C, you instead, and in Hamilton, write two functions, C and D, that then declare the input arguments. Now, unlike this code, which if you run kind of actually creates the columns, here you've written some functions that you don't directly execute. So you need some driver code, which I haven't shown here, which I'll show I guess in a little bit. But this is kind of Hamilton at a high level. The one thing to note, which I'll kind of, I guess, repeat throughout the kind of talk, is that, the examples I have are pandas focused, but Hamilton isn't beholden to just pandas. It works for kind of any Python object type. So just to keep that in mind. So to hammer home the paradigm, so if you the outputs that you want, map to a function name, and the function input arguments kind of map to what's required to kind of compute the transform. You then have a documentation string if you need it, and then the logic very clearly is encapsulated in a single in the function body. So a full hello world, as I said. Before you need some driver code, so you have your feature transform logic or curated into kind of Python modules, and then you then need to write some driver code to kind of stitch things together. So specifically, you're going to import some Hamilton driver. You're going to import the logic, the module where your logic lives. You're going to instantiate what we call like a driver, maybe pass it some configuration or some static or invariant input. You're going to pass it the modules. So then Hamilton will crawl things to kind of create kind of a DAG, and then you will then ask Hamilton to, hey, compute me the things that I want, and Hamilton will only walk this the paths required for you to kind of compute the output. So in short, any place you have kind of equality assignment, you're essentially going to be writing a function in Hamilton. Those functions together through naming are going to declare a DAG or a directed acyclic graph. And then Hamilton's going to handle DAG execution. So again, you write your logic that creates this kind of defines this DAG. Then you kind of tell Hamilton about it, and then Hamilton will go ahead and kind of execute it. Now, some of you might be thinking, doesn't Hamilton make my code more verbose? Everything's going to be functions now, right? And I want to say yes, but that's not always a bad thing. I'll dive into a few of these, I guess, later on in the talk, but we do have some kind of syntactic sugar that enables which we call kind of decorators that you can kind of annotate functions with that give you extra kind of functionality. So just to name a couple, you can attach metadata. So, who owns it? Does this thing have PII? We have an ability to kind of parameterize things. So if you do have a for loop or need to carry and repeat something, we have some abstraction there. We also have a skipping to check output. We have a lightweight data validation kind of annotation, and we also have this kind of config when annotation to make it really easy to separate different paths of logic very easily and clearly. More in the documentation, and we also have developing new ones kind of as time progresses. And then with Hamilton, I guess the other thing to kind of call out is that you get visualization for free. So there is on the driver object, there is this kind of visualize execution method, which will kind of the things that you have defined in your transforms actually give you, hey, we'll tell you what will be computed. And so, this then makes, for those who are visual, an easy way to kind of understand and grok, what you're doing with Hamilton. So Hamilton at Stitch Fix. Well, it's been running in production for over 3 years at Stitch Fix. So the initial team that was using Hamilton now manages over 4,000 kind of feature transform definitions. So I think when we started and got them onto Hamilton, it was something like 1,500. And so they've close to tripled the amount of features with it, and I want to say done so without impacting kind of team velocity. And in fact, Hamilton actually helped their team move faster. So they had a monthly time series feature engineering and model fitting task. They used to take someone on the order of 8 hours. Now it takes them less than 2, and that was just by changing the way they wrote code. So Hamilton just made it that much clearer, and they could be more surgical with what they needed to update to get something out and kind of build a new model. They found it was easier to onboard new team members. So as I showed before with the visualization, you kind of get lineage and this kind of, and as Hamilton has a good documentation story, more on that in a bit. They also found as a byproduct, code reviews are much simpler just because everything's in functions is very clearly in these declarative functions, very easy to understand what's being changed and what's being impacted. They finally can add unit tests for those things that are important. And then they also connected the things with Sphinx documentation. So Sphinx documentation, for you if you don't know, if you have Python functions with doc strings, you can actually have something that then publishes a web page that kind of exposes that documentation. So they paired that with what they did with Hamilton to kind of expose some of these 4,000 feature definitions. Cool. All right. So general usage of Hamilton. So what's Hamilton good for? So anyone having to deal with a lot of transforms is basically a pretty natural fit for Hamilton. So Hamilton does come from time series feature engineering, so obviously a pretty good fit there. But in general, if you have a lot of kind of feature transforms or things that are chained together, Hamilton's a pretty good fit. If you're tired of having monolithic pandas scripts, for example, I want to say Hamilton will help you manage those scripts more effectively and efficiently. If you're if you like your code to be very uniform and look very structured, Hamilton has a nice aesthetic appeal there. And in particular, if you like software engineering best practices, so like testing and things. So the point of this talk, I'm pretty sure you'll enjoy Hamilton. But otherwise, Hamilton is as I said, it's not just for pandas. I want to say it's a bit of a Swiss Army knife in terms of the things that you can kind of model, since you can logically model a bunch of problems, and so and then later on decide like how it should be materialized. So still scratching the surface here as to what else could you do with Hamilton? Where could you apply it to? So for example, we have even people scratching the surface of using Hamilton to orchestrate the logic within their web services, for example. So what is Hamilton not good for? So I want to say there's at least one case I definitely know it's something definitely not a fit, and that's if you have this kind of a dynamic DAG. So if you wanted to define a data flow or a flow of computation where the next step or next thing to be executed is dependent on the output of the prior step, I want to say with Hamilton, that's how we think. And so if that's a requirement, Hamilton's not a fit for you. But I do want to, I guess, say that if it is a requirement, I'd be curious to chat with you, because my assumption is that in most cases you can probably rewrite things in a way so that it isn't. So how to use Hamilton? So again, just hammering home the usage. So you're going to write functions that turn up into Python modules, and then you're going to create these kind of drivers to drive execution of these functions, and then you're actually going to call the driver script to obviously materialize a result. So again, Hamilton works for any Python object creation, so you can use it for machine learning workflows too. You can use Hamilton within kind of batch context, so you can use Hamilton with anywhere that runs Python. So Airflow, you can use it within Airflow. You can use it within your Jupyter notebook, etc. You can also embed it into things that run in an online setting. So if you have a Python streaming system that runs Python, you can run Hamilton there. Similarly, Hamilton works within Flask or Fast API for Python web services. So in the context of say we need to create a feature table for input into our model. How do you do that with Hamilton? So one, you would kind of define your data loading and feature code and say features.py. You then say define a run.py that will, you'll provide a pointer to features.py. Hamilton will kind of build this kind of DAG. You'll request what you want computed from it, and Hamilton then go ahead and kind of, create the data frame. And then in run.py, you would then, either pass it to training or save it for later use. So again, you need to write, so getting a little lower, so the code that needs to be written, so you need to write functions that load data. So one of the things in terms of using Hamilton, the part of the patterns is when you load data, we're trying to force you to actually normalize or create a common index on things such that your features and things can kind of be joined together pretty easily. You then write your feature functions, so your logic to load is separate from your logic to transform. And optionally, you can kind of model machine learning, model fitting predictions as well. And then you're going to drivers for your particular context to help materialize your data. And with Hamilton, the idea is you logically add to one DAG, and so Hamilton therefore only walks the subset of what's needed to kind of execute a result. So pictorially, you're going to have some source tables somewhere that live in some database, potentially with some flat files. You're going to write some functions that load them. These functions are then going to be used as input into downstream transform functions. You're then going to write some driver code that will then, depending on what you want executed, warp the DAG for only that subset to materialize what you need. Cool. All right, 2 minutes. All right. So, so now in this section, I'm going to dive a little bit deeper. So basically, try to talk a bit about the native software engineering practices that Hamilton brings about and the things that it helps solve. So when I think about problems with path and transforms code that relate to kind of software engineering, I think they fall into kind of 2 sections, right? So I think there's this kind of human and team aspect, which is how people write code, how that relates to the team. Can they reuse it? Are people afraid if someone leaves? Can other people pick up other people's work? How did this relate to actually running and functioning of the business? Is it easy to kind of debug and decouple? So in the case of Stitch Fix's problem and the reason why Hamilton exists, the code was highly coupled in this giant monolithic script. It was hard to kind of understand and reuse work. And then when things were broken in production, it was actually hard to debug and relate to changes and things that were kind of happening in that script. The other side, the problems are kind of machine related. So you have your feature transforms, but now your data is too big to fit in memory. What do? How do you scale out? Similarly, Python is single process. Parallelization is easy. So how can you write or structure things in a way that make parallelization of computation a possibility? So Hamilton was designed to kind of help with the human team aspect of things pretty deliberately, but as a nice byproduct of how things are structured in Hamilton, we actually have some pretty, I think, reasonable integrations to help you kind of scale things should you need to if you're using Hamilton. And these all, I think, relate to software engineering best practices. So specifically to give you, I guess, a concrete example or a bit of more of a flavor, here's a function you probably haven't seen before. I want to say, take 10, 15 seconds to try to read it and understand it. And top to bottom, right? I want to say, you probably have a reasonable idea of what it does, even though you didn't write this code. And part of the design philosophy with Hamilton is that you read code more often than you write it, and so it should be pretty easy for someone else to come in and pick up and kind of understand what's going on. So specifically, from a software engineering best practices standpoint, because you write things in functions, unit testing is always possible, right? You haven't coupled it with context, so it's very easy then to kind of write a unit test if you wanted to make this function or to test this function, right? And with Hamilton, unit testing is always possible. Documentation. So similarly, you probably read the tag annotation and went, oh, I understand. The owner of the team. There's no PII, right? As I showed before, these functions, we can stitch them together to show visualization. And they also have the function doc. So, the documentation, Hamilton, you have many hooks here, as I'll kind of dive into in another slide to kind of help you with this kind of, code readability, maintainability perspective. From a reuse, modular and reuse perspective, because you're writing things in functions that you curate into modules, right? That is decoupled from context. This is, a general best practices of, decoupling concerns. And then with kind of decorators and things and some of the driver extensions we have, it's pretty easy to also add on and extend Hamilton as needed. One of the byproducts of Hamilton that kind of was something, it wasn't a design goal, but something that kind of naturally occurred was that at Stitch Fix, the teams who use it, they essentially build up this kind of central definition store of all these transforms in code. And so, and part of the reason why it works and is, that you have to come up with some sort of naming convention or some sort of standardized way of naming things. So then things are easy to find. You have to curate things into modules. Usually what ends up happening is you thematically end up curating things into modules. So it's very easy to kind of update and kind of find things. And then because everything's in code and assuming you're using Git or some versioning system, you actually have a very nice kind of versioning story as well. So from a software engineering best practice, you commit code that's pretty clear. It's very easy to change things or go back in time and diff things to understand, what was structurally different or how was my computation different between 2 points in time. You kind of naturally and easily get that with Hamilton. And then I probably didn't have to tell you, but you probably understood that this check output annotation is a kind of a data quality check, right? And so the way that works in Hamilton is that this is run at runtime. By default, it only logs the warning, but you can actually make it fail fast, and in which case it's very easy and lightweight way to kind of add some expectations on your code and have it run and kind of break exactly at the code that which is having kind of the issue. So diving into a bit more of this, right? So I want to say one of the issues with writing code is like you really want to kind of encapsulate logic, and you don't want to like muddle it too much, because then that makes things hard to maintain. So specifically in the script, kind of the code example I showed at the beginning, if you have configuration in different code paths or different branches, right? That's kind of different context or logic that you kind of need to maintain. Before Hamilton, this was up to you to keep in your head how to maintain things separately. If you didn't put the branch in the right place, right, you could be in a world of trouble. With Hamilton, it's we have this kind of at config annotation, which enables you to actually specifically encapsulate the logic for different kind of scenarios into different functions. So then the unit tests here is, you can have 2 different unit tests for 2 different scenarios. They can take in 2 different dependencies, so it's very clear to see and understand. Oh, look, okay, they have different requirements, but they fulfill the same kind of logical role. And so with Hamilton, the encapsulation of logic is actually, you don't have to think about it. You're kind of forced to do it by writing functions. To dig in on the documentation side, as I mentioned, if you're given this kind of a large kind of script, and say you're a new person, or maybe you want to add a new feature and you're not sure, what exists, right? You need to kind of understand and go through this kind of script to, it will take some time for you to kind of do it and figure it out. So if you, and then if you are trying to figure out, how to debug or find some sort of feature, or who to talk to, who owns things, this kind of wall of text without a good documentation story is kind of hard. And as I mentioned before, if there's an issue with an output, finding the place in the code that creates it, is a non-trivial task when you kind of don't write things in a nice way. So with Hamilton, you don't really have these pains, right? As I mentioned, you're forced to curate things into functions, into modules. Those modules can be thematically named. So if there's some place you need to where should I look for client features? If there's, where should I look for things related to the client? Oh, look, I see a module client features. Okay, that's a nice logical place to kind of think and map things, right? You can add extra annotations with this kind of tags or check output kind of decorators. The function and parameter names, actually, you're forced to name them something meaningful. Actually, a lot of functions in the Stitch Fix code base for the teams that use it actually don't have a doc string, because they get all the information they basically need from the naming of things, since it's pretty clear what it is, and then it's pretty easy to read the logic that happens, right? You can similarly, if you do have doc strings, or for things that are more complex, right, you can kind of export them to Sphinx docs. And then from a debugging or how do I find things or getting started perspective, there's, with Hamilton, we explicitly have this one-to-one output to function mapping. So if there's an issue with an output, it's pretty easy to find the place in the code that kind of it corresponds to. So from a data quality side, it's a good best practice to kind of add this, these days, in terms of ensuring that your data kind of meets expectations. Before Hamilton, the general way, say you're integrating, say, great expectations or something, is that you're executing code that creates some data. You then have to, run that data either at the end of, you have to add this at the end of your ETL step, at the end of your task step, or maybe it's a brand new task in your kind of, ETL workflow. Is that you take this data and you have to run it through tests. And then if there's an error, then you have to go back to the code or find the upstream kind of issues, right? There's a sequence of steps that needs to happen. So it's not sometimes the worst thing in the world, but sometimes that happens is that things over time, expectations need to change and be updated. So if you change some code, in my experience, it's not uncommon to also forget to update the data tests, so in which case this slows your development loop, or getting to production kind of step. It's like, oh, look, you changed something, you forgot to change the tests, right? But with Hamilton, I want to say we kind of shift left to the extreme. The nice thing about putting the expectation on the function is that everything's together with logic. And so it's very clear and easy to kind of understand, okay, this test, this output, this mapping, right, is very clear and kind of together with Hamilton. And then on the update side and longevity, right, if there's a change in the function that changed the expectation, right, you won't forget to change it because, you know, the annotation for the output is with the function. And so you can review both in the same pull request, which I kind of think is pretty cool. Right, and so from a code base implication, right? So one of the things you have to think about when you're writing, writing code is like, how do you structure your code base? With Hamilton, structurally thinking, you write functions always in modules, and then so your logic gets created into modules, right? So your repository is forced to be kind of thematically structured, and then you're going to write these kind of driver scripts, which then which are decoupled from these functions, which couple together the actual execution for, you know, what should happen, right? So with Hamilton, you get code reviews from day one, and I want to say you also have low maintenance to kind of support many different kind of driver scripts. And so to dig in on that, before when you're writing code in this kind of single script form, you know, it's easy to couple where data comes from, the logic to process it, and then potentially different concerns, so different kind of, you know, configs or different kind of concerns, because it's easy to from a you know, couple things together from a from a code inertia perspective. So you either, you know, just append to the script and pull the things that you want, right? What this basically means is that when you write these scripts, it's hard to reuse logic because everything's kind of coupled together, right? But after in Hamilton, you're forced to kind of, to run Hamilton, you're forced to separate things. So you have to write these, you know, your function logic and curate it into modules. And then it's very easy to have different scripts that tie together different contexts. So it's very easy from, say, to have a US driver that just has the logic or the things required to couple together the right context to run things for the US, similarly for the UK. And so in Hamilton, it's very hard to actually write code that couples things together in a way that makes it really hard to reuse or maintain. And so the flip side of that is, say if the business changes and we want to expand to a new region, right? You don't have to, you shouldn't be touching these driver scripts. It should be pretty easy to add a third driver script for that particular context or region. And so then it's, you know, easy to throw away or maintain or prototype something without, say, impacting production kind of usage of these kind of, say, US or UK drivers, right? Yeah, and so that's all I had from the you know, diving into, I guess, more of the software engineering best practices that come naturally with Hamilton from you know, the human side of things. From the kind of scaling side of things, just to mention the features Hamilton has. You know, Hamilton has, you know, out of the box integration with Ray, Dask, and kind of Pandas on Spark. So with Ray, it's very easy to go from single process to multi-process or to a cluster. Similarly with Dask. With Pandas on Spark, we kind of have a cute hook to kind of enable you to kind of reuse most of your Pandas logic and just change a few things to kind of make Hamilton run on Spark, or delegate to Spark to run, rather. And the cool thing about it is that most of these, the only thing that really needs to change is driver code. I will mention, you know, Pandas on Spark, you also have to change, you know, maybe how data is loaded, but otherwise, this is kind of cool. And I think the reason why this is enabled is because we've, you know, done a software engineering best practice of decoupling, you know, logic from actual execution, right? And so with Hamilton, you don't have to think about this as an afterthought. Like usually, if you're, you know, trying to build for these systems, you actually, you know, coupling the concern of where it runs very tightly, and so in which case, you know, it means that you're, you know, locked into that particular system without a rewrite, right? So what I mean by it's only a driver change. So here I have a vanilla Hamilton driver script that shows imports Hamilton, kind of the driver module, imports, you know, where our particular function logs is defined, instantiates a driver, which instantiates the DAG, and then kind of, you know, executes the result and saves something to a table. If you want to, you know, make this run on Ray, for example, then all we got to do is change this driver script or create a new one, right? And import a few more things. So one is we got to, you know, import the right things, connect to the Ray cluster, or instantiate a Ray graph adapter. So in Hamilton, we have this concept of graph adapters, which you know, augment how the DAG is kind of warped. So a little bit more about that in a bit. We then pass that to the driver. And then the cool thing is, well, nothing else should have to change. And then, obviously shut down array when you're done. Similarly with Dask, very similar kind of process. You need to kind of import a few more things, connect to the cluster, create it, right? And then instantiate this kind of Dask graph adapter that will then kind of tell Hamilton how to walk things and, what result to kind of return. Shouldn't have to change your feature transform logic, right? And then for Spark, as I mentioned, you have to change the driver, but you also have to change how data is loaded. But the cool thing here with Hamilton, if you've written things in a modular way, so you just have to swap out that one transform module for your specific Spark kind of case. And so very minimal work to kind of, go from running on your laptop to say running on Spark. So how does this work conceptually? Well, as I mentioned, like you write your functions that are, encapsulate the logic that define a DAG, right? The driver then stitches together the context. So the driver is decoupled from your functions, but stitches together things required to create things that are needed to run. This kind of, instantiates a DAG, and given what you want to execute, given what you request to execute, Hamilton will only walk the DAG for what's required to be computed. When we walk the DAG, because everything is encapsulated in functions, it's pretty easy to say to just wrap that function and delegate to Ray or to Dask to kind of compute something, right? And we can do that as we're walking the graph. And to get Hamilton to kind of, to work with pandas on Spark, right? The only thing that really needs to change is that we're using that that Python isn't statically typed. And so what we can kind of do is, assuming you're using the subset of the pandas API that Spark kind of supports, all you need to do is kind of change the object that's loaded, and then Hamilton, as it's walking and kind of executing the code, will invariably delegate to Spark, and boom, you have some things running on top of Spark. There are some caveats here, so just to mention them. One is serialization. So we don't expose right now in Hamilton any kind of custom serialization methodology. I want to say, because of that, you need to, if you have fast functions and small data, you might not actually get a speed up by using any of these frameworks, just because there's a serialization to deserialization overhead. So it works better if you have bigger data or things that take a while to compute. From a memory perspective, we don't also expose anything to kind of fine tune that on a function basis. The defaults should just work. And then Python dependencies, our expectation or kind of assumption is that your whole Hamilton DAG only needs one set of Python dependencies. Now, that if you run, you can substitute. That's not necessarily true, but that's a general assumption. And so it's up to you to kind of manage your Python dependencies and ensure that the systems that you run on have them. These APIs, you could say, they're still in experimental status. We would love more feedback and kind of someone to help kind of bake them a little bit more. We are looking for contributors here to extend support. So if there's something that's missing, or if you do try it and you would love something, we'd love input. Otherwise, the other way that you can scale Hamilton onto bigger things is actually use, if you're using pandas in particular, is to use a little library called Modin. So you wouldn't have to change your driver code or anything. You just have to swap out importing pandas for Modin, which is another way you can kind of scale. So in short, how Hamilton helps from a functionality perspective, right, to bring software engineering best practices. The number one way, the reason why Hamilton enables it is because it gets you to write all your transforms into individual Python functions. And so unit testing is pretty simple and easy, just because your functions are decoupled from the context they run in. Naturally, you have documentation, a good documentation story, so the naming of things, the doc string, the ability to create visualizations. Modularity is achieved as a best practice, right? Because you're forced to chunk things into functions and curate them into modules, right? And then you have this natural catalog, which is a nice byproduct of how things are structured. And so it's very easy to create this kind of definition store with Hamilton. And then debugging gives you a very prescriptive, methodical way, since it's very easy to find the function that maps to an output, very easy to debug that function, and then very easy to understand what was passed in as input. So then it's just a matter of walking the DAG and figuring out where a bug lives. we have a much better testing story. So along with unit testing and integration testing, we have, runtime data quality checks without you having to add, another system to do so. I didn't dive into it here, but did mention it that we do have more decorators that you can annotate functions with that provide kind of higher order operations. But otherwise, because your logic is decoupled from context, we have driver code that couples things that's much easier to maintain, since you can write small driver scripts that are particular relate to a particular execution or context. So to kind of summarize things. I think Hamilton natively brings software engineering best practices because it's a declarative paradigm. We declaratively describe the output and input requirements for feature/data transformations. Hamilton is embeddable anywhere that runs Python. It grew out of the need to tame a transform or feature engineering code base. Go ahead, try it. I'm sure it will make yours better too. And then Hamilton, the paradigm, I want to say, actually helps teams scale not only themselves, but also kind of the data through software engineering best practices that kind of come naturally. And so I want to say, if you pair Hamilton with a system such as Mode and Array, it enables you to not only scale the team side, but also the data and compute side. So in this last section, just a couple of minutes. So open source. So Hamilton has been open source for just over a year, and I want to say we're still pretty early in the community. But there are people who are using Hamilton outside of Stitch Fix in production. So UK Government Digital Services is kind of one. They're using it for a feedback pipeline. We have the British cycling team using it to help their Olympic team model and kind of transform data they get from telemetry there. Small startups to national labs are kind of looking at Hamilton for time series modeling or problems. And of course, Stitch Fix has been using it in production for over 3 years. We're over 800 stars on GitHub, but as I said, community is still forming. Would love contributors or bug hunters or in general kind of feedback on usage, right? Our high level vision for Hamilton is like, can we be the connecting layer that makes it easy to connect with different parts of the data ecosystem? So for example, Hamilton is a micro framework, it's embeddable. Can we make it connect or easier to integrate or run with these larger macro workflow orchestration systems? Can we make it easier for you to integrate or plug in, say data quality vendors? I guess Great Expectations isn't here, but it's conceivable that we could have a plugin to match, the check output annotation with a mapping of a test that you have in Great Expectations, for example. And then can we actually bridge the gap towards more SQL or where your data lives? So can we provide integrations or an easier means for you to go from your data warehouse and see kind of the lineage and logic that you have with your Python transforms. And so just to give you a flavor of things we're thinking about, so polars has been hot. So can we provide better integration or support for polars? So one thing of note is polars doesn't have an index column like pandas does, so you can still use it with Hamilton, but maybe there's some different patterns and things we need to work on to make that even comparable to how easy Hamilton is to use with pandas, for example. There's a lot of people who still use PySpark and don't want to use the pandas API. Maybe there's a better way that we can help people structure a PySpark UDFs, for example. We're also working on more decorators. So can we reuse subsets of logic to make it easy for you to compute different grains of things without you having to write much code? Can we better integrate with SQL or databases? So for example, DBT now has more Python functionality. Maybe there's some way for us to integrate and use things and integrate better with DBT. And then from an execution kind of perspective, since things are nicely encapsulated and you kind of run them, can we add some easy features for you to profile? Like how long did something take? Maybe if you change something, give you an ability to say, you change some logic and look, we know why things are taking longer, right? And then from the other side, in some contexts, when you're running a set of transforms, maybe upstream data hasn't changed. And so if we could intelligently cache, you wouldn't have to recompute those things. So things could even execute and run faster. But otherwise, we're open to suggestions. So would love input here. And so as I said, Hamilton's open source. Pip install SF Hamilton to get started. Would love a star on GitHub. Create and vote issues, and we're also curating a community on Slack. So do join and say hi. And lastly, just from what I'm working on right now at kind of DagWorks related to Hamilton, I'd love to kind of talk to more users or to more people who are interested in enabling more self-service. Specifically, can we, if you still want people to write code, how can we reduce the software engineering bar so that they can do so, right? Also, if you think the human and pain and cost of managing your machine learning ETLs is kind of significant, or you're trying to reduce it, we'd love to chat to you. Send me an email, stefan@dagworks.io, or reach out to me on LinkedIn or Twitter, or even in Ben's Discord to chat. We'd love to kind of talk to you if you have these problems and want help solving them. Otherwise, thanks for the talk. Thanks for listening. Happy to take questions.
I'm on mute. All right. Yeah, no, that was great. I think there was a ton of information there. I really appreciated how you put this all together. Starting with what your code looked like before, kind of where it went. I think Roy's got a good point here where he said, columns equal functions is kind of a powerful abstraction. Yeah, it was something I was like, oh yeah, that does make sense, right? Like very mathematical, a function of a function of a function to create something. So, yeah, I think that makes sense. Also, you have someone else who says Hamilton's package is neat AF, by the way.
Thanks, Federico, man. Lots of love. Thanks.
Yes. Let's see. What's some questions? Another Roy point is incremental updates is your idea here. So there's a free idea from Roy.
I'll write that down. Yeah, in Hamilton you can actually the other way to scale things. You can actually put if you can chunk the data that you want to work over, you can put the execute function within a for loop, and there's an ability to provide inputs to the execute function. So that's one way that you could do incremental updates, or at least one way to get around it. If you manage what data changed, there's a way to integrate Hamilton there out of the box. But otherwise, that's a good point. Thanks.
Yeah, but he's got a few questions, and I don't know how many others. But how does Stitch Fix run Hamilton, Ray, Dask, or Spark?
So the majority of them actually, there's large enough machines on AWS where you don't have to deal with distributed problems. So I want to say vertical scaling is the general methodology that I suggest first, and that's where the majority of uses of Hamilton are. But internally, we have a Spark cluster, or at least when I was still there, it was Spark. And so, if anything, if people were using Ray or Dask, it'll just be for the multi-processing component on locally or on a machine. So, but yeah, majority of it was vanilla Hamilton.
Nice. Yeah. It's kind of cool how you put this together. And now I've lost. Okay, there we go. Yeah. I'm trying to find if there's more questions. Roy had it, Roy had a few, but I want to see if there's someone else, so I don't completely. ChatGPT. There's a lot of ChatGPT questions today, of course. So I'm just trying to see.
You mean ChatGPT generated questions, or?
Oh, no. Maybe, who knows? But just a lot of people referencing it. Yeah, ChatGPT making questions about ChatGPT. I think this one is kind of the same. Do you actually use Pandas instead of Spark to run in this, or is it just for simplicity? So I feel like that was kind of
no. So I want to say most machine learning models, right? A lot of people potentially use Spark or something to join, filter, sort the set that they want, and then they pull that into memory. Mm-hmm. And so then all the featurization, all the transform logic for machine learning takes place in memory. is a pretty common pattern, since there are only a few teams that needed distributed model training, and so in which case they did things kind of pretty differently, and they were dealing with GPUs and things. But I want to say from my experience, operational simplicity wins in the long run, and so so if you don't have to deal with Spark, don't deal with Spark.
Oof. Yeah. That is sobering to hear, I think, for many people. So if you don't have to, don't. If you do, find a good solution. Yeah. Someone's asking, could you speak more about the data sources that you guys are supporting?
because Hamilton's written in Python, we actually support anything that Python you can load from. And so what I mean specifically by that is just providing maybe some more API or like, out of the box integration, so you don't have to write things yourself. So for example, right now, you can have a function that connects to a SQL database and say runs a query, but we haven't provided an abstraction for you to like, abstract out what that database is. You have to provide the connection object. Maybe we could provide some SQL glot integration. So, it will translate SQL for whatever database destination of choice. So that way you don't have to like, change things. And so we're looking from an ergonomics perspective, but otherwise, if you can, run it in Python, you can already use it with Hamilton. It's just, coming up with, easier and better patterns for maintenance.
Yeah. And so I was thinking about this as you were kind of going through. Is this used because like while you were talking through this, is this used more for like core data model or more? It's more the data science side, right? Like, go ahead.
I mean, so well, I want to say that's where things started, right? So yeah, things started differently from at Stitchfix. The data science teams are pretty autonomous, right? So they're responsible for maintaining and building kind of the ETLs for their models. And so in which case, I was part of the team was trying to help them. So that's where kind of things came from. But yeah, I mean, I think getting at your question, you could use this to kind of, model core data, like if you're thinking data engineering perspective of creating, features are analogous to like metrics or things in a table. You could, think about using Hamilton that way. I think that's partly, we've actually had some data engineers, pick out Hamilton from that perspective if it, it fits their use case, right? But yeah, like part of the question is, do you want to write SQL or Python? Is probably more of the question.
Yeah. Because while you were talking, I was like, oh, this is almost like an interesting semantic layer type thing you could create, right? The way you're kind of defining functions could just be metrics. And I think you basically had picked a metric, like something on the holiday. So that's why I was like, oh,
yeah. I mean, some people say Hamilton has a, it's like the DBT for Python transforms in a way, because it's an opinionated way. It gets you to write things with a nice testing and documentation story. Has lineage kind of out of the gate. So there is some analogy there as well in terms of I think with Hamilton. But yeah, you could. Conceivably use the Python transforms to define metrics. And then what data type you use, whether it's pandas or Spark, really depends on how big your data is. But otherwise, I want to say, feature transform, feature definition store, pretty close to metric store.
No, that makes sense. That's perfect. Let's see. I don't know. Talk about data sources. I don't see any. Too many more questions here. Don't know. Did you have anything for me maybe before we kind of maybe start tailing off here?
I mean, I was going to say I think one of your blog posts you were reading saying that some of your time was spent 30% of your income was spent like rewriting other people's code, and so I want to say part of the problem that Hamilton is trying to solve is maybe so consultants like you don't have to come in and rewrite people's code since it's in a particular way. Or at least that was my the ironic connection with some of your kind of content stuff. But I mean, actually, in your experience, are you also rewriting Python, or is it all largely kind of SQL?
I mean, it goes a little broader than that, right? Like it's not just like it's tooling in general. Like I had a company I was working with that had a solution that they were working on called EasyMorph, and I had never even heard of this thing. It's like a open source kind of SSIS sort of solution. And they were kind of forced to use it because they had to find a cheap option, and but then the flip side, whenever you do that, is like, well, if no one else uses this and if no one else knows what it is, you're gonna have to call someone to fix it and make it work. So that's sometimes it's code, sometimes it is code, but sometimes it's also just like the solutions people pick, maybe the data model. One other company, like they started to build a data vault, and it was like a team of like 4 people, and then they left, and nothing was really working. So they just needed something that was even like super lightweight that they could maintain, because their team went from 4 people to 0, and then they hired someone, and then they kind of repurpose and reuse and do what they could. So it's a little bit of everything. It's like it's the type of problems we run into in the data world.
Yep. Yeah, I mean, too many tools, too many options. Yeah.
Too many options, too many tools, too many ideas. I mean, the more I do things, the more I'm just like, can we do this with one tool? Well, I don't mean like all in one tool.
Yeah,
It's more just
no.
like, earlier they referenced the fact that like, people use Power BI, Tableau, Looker all at one company. And the more I'm like, how do we avoid that? I know that like to some degree it's hard to avoid because sometimes it's just like teams. Like it's like, well, this team knows Tableau, so is it cheaper to have them, learn Power BI so everyone's consistent, or is it cheaper to just let them use Tableau and go forward with that? So it's
I mean, I want to say like, that's this, similar to, or in my experience of, SQL versus Python debate. And then it's also, do you use Ray? Do you use Dask? Do you use Spark? Or do you use Pandas? Now with polars, it's like, do you allow people just to, I think, being consistent, I think, part of the ethos with Hamilton is at least like, consistency does matter and does help kind of team structurally, grok and chunk things and think about it. But I want to say, because there is so many patterns, so many ways of doing things, and some of the projects take so long, I want to say the learning cycle takes a while to kind of figure out. And so, like for me, the learning from Hamilton was like, actually, some people really like an opinionated platform, and like, no, they don't need to upskill and learn, object-oriented programming to write code well, for example, right? And so, but happy to be challenged on that. But that's part of, I guess, my thesis that like, hey, if we can simplify some of the tooling and not expect people to be, software engineers, then people can move faster and get more value out of kind of the things that they create, and and then because individuals build things, but teams end up owning them over time, right? And the kind of the practices you need to make a team successful aren't necessarily the same to like aren't necessarily the same that make an individual productive or get an individual from A to B. So
no, I think I definitely feel that it's I like that line, and definitely have to like quote that at some point. Individuals build things, teams maintain them. Because like it's generally like one person's initiative, like, I want to like whatever build the next Airflow. Cool. I mean, that's probably what you did. We want to build Hamilton, and then you started building it, and then people are like, "Oh, this is great," and then like, "Okay, what's the long-term plan?" You're like, "What do you mean? Like, how is this being maintained? How are we managing it? This is now business critical. Like, it needs to be maintained."
I mean, like the cynic says, tech debt takes a while for people to kind of, to come up, and so in which case, it's easier to get the feature out, get the promotion. Tech debt's someone else's problem.
That for anyone who hasn't worked like on big tech companies, that is the method. You make something, you then leave, you get your promotion, you then switch teams, and it is no longer your problem. It's someone else's problem now. There was a few things at Facebook like that where it was like, this is something that's really useful, but no one's maintaining it, so it's just deprecating over time. So it's never great, but it's. And then no one wants to like pick it up because it's like, picking it up and maintaining it doesn't feel like, doing new things, so to speak. So it's kind of how that works. So awesome. Well,
cool.
Thanks
for having me, Ben.
Yeah. I appreciate this. I appreciate your time. Hopefully everyone had learned a lot here. We'll have our next speakers come up here in a second, but and then my LinkedIn live finally went down, but I knew it was going to go to because there's a 4-hour limit on LinkedIn. So I can't even speak to you guys, but come to YouTube. But thank you, and I'll see you around.
Thanks everyone.
Bye. All right, we're gonna have our next speakers come up here shortly. I see at least. I'll bring them here. I'll give them a minute. I'll let you guys all take a breath because it's been 4 hours and 41 minutes. And then I'll bring up the speakers. Cool. I think I see they're both here, so I will bring them in and stream. Hopefully, I didn't scare you guys. Hey, Kostas. Hey, Brian.
Hey, how are you?
Doing great. How goes your guys' day so far?
Good. It's a sunny day here in the city, which is always good. How is Seattle? Are you Seattle, by the way, or you just use the name? Like,
Just-
you are not there.
Is this a joke? I feel like everyone. You're okay. I was like, I feel like you must know. I'm in Denver. There is snow. I'm caught. Like I keep having to. I'm thinking. So there's supposed to be a happy hour today. After this event, and I'm just like, I don't know. I don't like everyone's most likely not making it. So I feel bad because there's a few people who flew out of town. So I'm a little bummed about that. So and Joe Reese was supposed to make it too, but he like texted me yesterday like and it's like, yeah, the storms basically keeping us from coming. Yeah, he was supposed to come to dinner. Oh no, he wasn't supposed to come to the dinner, but he was supposed to come. And the storm was apparently really bad. So
all right. Well, at least here in California, the weather is good. So
you guys had a while there where it was not.
Yeah, it was not. That's true. Yeah. Hey, Brian.
Yeah. Anyways, if you guys want to give you guys a quick background on kind of who you guys are, what you guys are doing, and then you can bring up your talk.
Sure. Brian, do you want to go first? I think, Brian, we cannot hear you, but...
Oh, yeah, Brian, you're either... Yep, your audio is...
I think
is it working now?
Yes.
Yeah.
Great. Good thing we had a mic check.
So sorry about that. No.
Yeah, Brian, do you want to go first? Like, make a quick introduction, and then
Sure.
I can go next.
Yeah. Cool. I'm Brian. Cos and I work together at Starburst Data building Trino, which is sometimes better known as Presto. And recently, I just started as an investor at Charles River Ventures.
Yeah, thanks. You betrayed us. You decided to go from actually building things to just be. No, I shouldn't say just being an investor, to investing.
Speaking as an angel investor.
Hey.
All right, should I go next?
Go, Kostas. Yeah.
Okay. So hi everyone, I'm Kostas. As Brian said, we used to work together at Starburst Data. I'm still there. I didn't turn into VC yet, at least. I still build stuff. I'm doing product there at Starburst Data. My focus is more on the Trino side of things. As Brian again said, like Trino, probably most well known as Presto, is the foundation of our product lines that we have. So there's a lot of interesting work that is getting done there on the query engine. Before that, I was the head of product of another company. The name of the company is RudderStack. Maybe some of you have heard of it. And before that, I started my own company back in 2014. I was co-founder and CEO there. The company was named Blendo. And we were building a cloud ELT product, like similar to Fivetran and Sys Data. We pretty much also started at the same time. I'm also the co-host of a very interesting. I'm allowed to do a little bit of advertisement here, right?
Sure.
Right?
I mean, you guys are technically sponsoring that part, so go ahead.
Yeah, so I'm also the co-host of the Data Stack Show, which is a podcast where we get people to talk about technology in general, but primarily focused on data infrastructure. If you haven't checked it, check it. If you are interested in coming and having a conversation with us and record the podcast, please reach out. I'll be more than happy to do that. And that's pretty much about me.
Nice. Perfect. Great. Awesome. So what will you guys be talking about today?
So I think we should also bring the presentation, right?
Sure.
So let's do this.
Yeah. If you upload the... Oh, go ahead.
Apologies to our...
do you want me to share it, Kostas?
Oh, there we go.
No, I think it's...
it is here. That's a good title.
Yeah. So, I hope the title is provocative enough. When the dam breaks. For anyone who doesn't know it, it's also it appears to be also a song. So go out there and Google it. It's I try to find a title that's a good allegory for the romantic and interesting relationship that data lakes have with streaming data. And that's what we are going to be talking about today, actually. We're talking about data lakes, streaming data, why they are important, why they work well together, or why, let's say, they pretty much coexist, but also why there are like many issues. It's not like the easiest source of data to work with. It's far from being, let's say, a solved problem. And that's where like Brian from the VC point of view can also like emphasize the opportunities there, right? Like both in solving like a problem, but also like if anyone is interested, like to build a company maybe and a product. And Brian is eager to write checks, so keep that in mind, right? So that's what we are going to be talking about today. Brian, is there anything that you would like to add?
No. Let's dive right in.
All right. So let's go very quickly through the agenda because pretty much like made the introduction already. Two main points that we would like the audience to take from this presentation today. One is why streaming data and data lakes are important to each other. And the second is why streaming data into the data lake is still an unsolved problem, right? And as we said, also like a potential startup opportunity. More on that later from Brian. I'll do the boring stuff, right? Like I'll talk more about like the tech and the use cases. So we start with, let's dive in a little bit, give like a few definitions, right? Let's start with what streaming data is, first of all, and like what are like the use cases around them. So the most common, there are many different use cases actually of streaming data, but we'll focus on like two of, let's say, the most commonly found. And I would suspect that like most people here, one way or another, they have faced these use cases. The first one is like anything that has to do with customer event data, right? And what we usually call like customer analytics. There are a couple of different things that happen with this data, right? Like we have like a very common use case with like product analytics, right? Like anything that has to do with like trying to understand how our users are behaving with our product ends up in like a stream of events that are generated by our users. Then we have anything that has to do with marketing, right? You probably have heard like terms like customer 360, customer journey, like how to recreate the customer journey. CDPs, like it's a common category of products that like we hear like many times. Audience creation, like the favorite activity of marketeers, right? How we can create like better and more well-defined audiences that then we can target better our users, like, and all that stuff. Personalization, and even like more sophisticated use cases that again they fall under like the customer analytics, but usually involve also some kind of like ML behind the scenes. Recommendations, recommenders require streams of event data that are coming from the users and from detection. Now, these events are by nature, like this data is by nature streaming, right? Like it's not something that, you know, we will go access a database, pull a bunch of data, push it into like the data lake or our data warehouse and do analytics. Like we cannot do that. We don't really know like when the users are going like to generate events. These events need to be captured and then they need like to be routed into a system. And the other thing is that like usually this data is like pretty large, right? I've seen customers at Starburst that they generate like on a daily basis, I don't know, 200 to 250 million events, right? And that's just for one day, right? So there's a lot of data that are being created that need to be ingested and be accessed on time, right? Like, so we can go and like do our analytics. How do I go to the next slide? Oh, sorry, yeah. And then the second category, which I find it very fascinating, is the application of like change data capture, right? And when we say change data capture, we are talking about having some kind of transactional database as the source, an OLTP system that we use to drive, for example, like our product. Our users obviously like interact with this database. We have updates, we have inserts, deletes, blah, 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 like all the standard stuff that we see like in a database system. And we want to ETL this data to a data warehouse, right? And perform our analytics. Now, it appears that there are many different benefits when we actually, instead of like executing queries on the database, on the source database, and export the data and push this data into a data warehouse or a data lake, instead of doing that, we actually attach to the replication log of the database, of the source database, and listen for changes that happen on the database, and collect these and push them into the data warehouse, right? So actually what happens here is that we turn the database from a system, let's say that its responsibility is to maintain a consistent final state at any point, right, into a log of changes. Now, why get into like this trouble of doing that, right? Like there are like some very important benefits here. One is, first of all, it's probably like the best way to ETL data from a source database to a data warehouse or a data lake, in terms of like the, let's say, the impact that our ETL jobs are going, like our pipelines are going to have like on the source, right? We don't really put any pressure on the production database, which is important. Now, many people can say, yeah, but we can have a replica, read from the replica, blah, 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 like all that stuff. Sure, but like the replica also can be, let's say, get pressure from like the queries that we run, left behind on the replication log, blah, 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 like all these things. Even if we have a replica, it's still like much, much better to rely on the replication, on reading the log and consuming CDC feeds to go into the ETL, right? So that's like the most obvious and probably like one of the first use cases. Now, there are like other things that also are important. One is that by, let's say, replicating the whole change feed of the database, we can pretty much go and implement something like time travel, right? Like we can go back in time and recreate any state that you want from our system, right? This is, by the way, becoming like very, very interesting, especially if we combine it with the time travel capabilities that like modern table formats for data lakes like Iceberg and Hoodie and Delta provide. But this feature, let's say, is really, really important, especially like for organizations that they, because of regulations, need to have like access to every possible state of like the data that they are working with, like especially like in the financial sector and biotech and some others. So we have like these extra, let's say, functionalities that we have. There are other things that's okay, like it's a very good way to build reverse ETL on top, right? Like having these changes there and like triggering actually actions based on the changes that you can detect. Create very, let's say, elaborated and detailed like audit trails if you need auditing and all these things. In any case, there are like plenty of different use cases that someone can build on top of CDC. But the thing with CDC is that we suddenly end up like with a lot of data, right? Now that we have like a table, we have the rows, and for each one of these rows that we have there, we have potentially like, I don't know, like maybe like an infinite number of like events that can be associated with this row. Okay, obviously, like until this row gets deleted, right? And something else that's quite important with CDC, we can also implement deletes on ETL, which is like notoriously difficult to do when you are going and let's say you have like a batch approach where you go like and query the database in specific intervals, export data, and copy the data like on the analytical infrastructure that you want to use. So these are like the two, let's say, most important, I would say, types of data that are by nature streaming, and they are really important, and they play really, really well with data lakes, right? And let's get now into like, let's say, the current solutions and like how things look in terms of like the available solutions that we have to work with streaming data, right? And before we do that, I would like to say a few things about like streaming data. First of all, streaming data, although in many cases you will see them like in architectures to be yet another source of data for a data warehouse or a data lake, actually are different, okay? And the reason that they are different is that streaming data are data in motion, right? They are not like stored in a system that is responsible to maintain the state of this data for a long time, right? And actually, when we are interacting with a system like Kinesis or message queue or Kafka, right, what we are actually doing is that we are interacting with this data while they're still in motion. They are in a topic, right? But someone needs to take the data from there and put them somewhere where we can maintain them and like store them like for the long term, right? So that's like very important, like to keep in mind. Like the first thing that we do with streaming data is actually to land the data, right? It's not to ETL the data. We haven't point yet. First, we have to land them, and that's like what actually streaming data ingestion is about. The other thing is that when we are talking about streaming data, doesn't mean that we are necessarily talking about real-time analytics, right? Like the latency of our analytics is, let's say, not necessarily related to the type of the data that we are working with. Like just because we are like working with streaming data or real-time data, it doesn't mean that like our use case necessarily has to be also real-time, right? Like in many cases, we are getting these user events, for example, or the CTC changes. The SLAs that we have are not in the milliseconds level, right? Like it's not like we want to have the data ready, like the analytics ready to be performed like in milliseconds from the point that we actually like read the topic, right? It might be hours, it might be minutes, it might be days. Like each one has like their own SLAs and use cases. And the streaming, let's say the nature of the data does not dictate, let's say, the type of analytics that we want to do then. I would like to make this clear because it's very, very easy. And I think it's very common for people like to almost consider like streaming data like as exactly the same thing as like real-time analytics. It's not. It has more to do with like how the data are generated and how we interact with them, right? So, as we said, Kafka is not a database system. That's what we need like to keep in mind. Kafka is an amazing technology. It gives us like the opportunity to have very, very well-defined delivery semantics for the data that we are dealing with, especially when they come like from streaming sources. Obviously, like you can have a lot of storage on these topics and store like a lot of data. And in the past, I would say that like Confluent, okay, trying to make the case of Kafka, let's say, like being like a different flavor of a database. But at the end, it's not like the place where we can go and manage state and recreate state of data and perform like analytics in the way that we need to in order to drive all the different use cases that the company has, right? So the data gets into Kafka, but then we have to consume the data, store them somewhere else, and then do the analytics there, right? So that's like important to keep in mind, like specifically about Kafka. Now, why don't we use real-time database systems, right? There's Pinot, ClickHouse, Star Tree, amazing technologies. Druid, the thing here is that like these technologies like ClickHouse are built and designed for performing analytics that are very, let's say, well-defined beforehand, and they can manage like really, really high like throughputs through ingestion, right? So they're like they are doing like an amazing job of like consuming the data from a topic, for example, and provide a narrow set of like analytics to the user, but with very, very low latencies, right? A very good example of that is like, and I think that comes like from Pinot. It's like how like Apache Pinot is used inside LinkedIn. So whenever you go like on LinkedIn and you want to see the performance of a post that you had, right? All these metrics that you see in there, like the geography and like the different professions of like people who interacted, is actually served from Pinot, right? But you will notice something there, and that's that these analytics are like very static, right? Like it's not something like, it's not like you can go there and do like ad hoc analytics and perform like an arbitrary SQL query, right? Like you cannot do that with these systems. And a very like a signal to that is also like to go and check how well these systems support joins, right? Either they don't have support for joins at all, or if they have, it's like actually like pretty limited. That's why it's like very, very common to see that when you to see architectures where you have a data lake where all the data is like pushed in there, like the event data. You do your roll-ups and like the pre-aggregate and most importantly pre-join your data from all the different, let's say, tables and sources you might have like on your data lake. Use something like Trino or Starburst or Spark to do that. And then ClickHouse or Pinot will go pick the data from the data lake, right, that have been like pre-aggregated and actually serve that with very, very high concurrency, which is important when you are doing like customer-facing analytics, low latency, and overall like a very good experience. But again, it's going to be a very, let's say, limited set of analytics that someone can perform. And that's, let's say, the types of like trade-offs that someone has to do when dealing with all these different systems, right? So if we want to do ad hoc analytics, it's going to be like super, super hard with like the CDC data that we have, for example, or like the customer data, to do it like with systems like Apache Pinot. So having said all these things, let's move forward and talk a little bit now about like data lakes specifically. Why data lakes work well with the type of data, with streaming data that we're talking about. Actually, I would argue that one of, let's say, the reasons that data lakes became the thing that they are together is exactly because we have to deal with with streaming data. And the current solutions that we had that were like the cloud data warehouses or even like the on-prem data warehouse solutions couldn't deal with that like efficiently, right? And when I say efficiently, it's not just like a matter of how well they scale. It's also like a matter of like the cost that is associated with like running these huge queries on like terabytes and even like petabytes of data on a daily basis on your data warehouse. So the data lake actually like addresses these unique characteristics that like streaming data have, right? Like we have a very cheap medium, which is a block storage solution like S3. We can store the data there. We can actually store whatever data we want, right? Like it's not necessarily that it needs to be like tabular data or let's say something that can be queried like directly through like a SQL query engine. We can even put like our images, our free text, like whatever we need in general, like around like data, right? But when it comes like to event data, we can put like all our event data there. And then from there, we can run both ad hoc analytics, like interactive analytics, regardless of how much data we have, right? Like Starburst, we literally have like cases where people are running ad hoc analytics on petabytes of event data. At the same time, these data are accessible to the ML teams and the data scientists that they can use like their own, let's say, frameworks and systems, like either to work like on their own data or the pre-aggregated and data that comes like through like a SQL query engine. And data lake gives like this amazing, let's say, both like elasticity in terms of like dealing with the volumes of data that we have and the processing that we need to do, but also in terms of like the different use cases and the tools that we want to consume the data, right? So how does ingestion happens of real time and like streaming data on data lake? And here, like I'm going to get to give like an example from something that we talked a lot at Starburst about, specifically for Trino. And this is like the part where we will start like seeing why ingesting the data on the data lake is far from being, let's say, an easy to solve problem or like a solved problem in general, right? So as we said, we have our data lake on the Kafka topic. And when we are talking about the data lake, what we need to do is like, first we need to land the data on something like S3, right? And from the Kafka topic, let's say we have, if we use like Kafka Connect, for example, right? We can store the data as JSON files, Parquet files. I think Kafka Connect, like on S3, also supports Parquet or Avro files, right? But storing this data on the block storage, it doesn't mean that the data is ready to be queried by a query engine, right? And that's not like a limitation of Trino, like anything that you are going like to use, like for that is available, like Spark or Athena or whatever. It requires like some further processing of the data. And there are like two things that need to happen there, right? One is somehow to register this data on a catalog, like Glue, for example. So a query engine can figure out that this data is available and how to access it and where, right? Or a Hive metastore. And if you don't want like to, and either like move it into a format like Parquet if it's not already in a Parquet format, right? And okay, if you want to be more serious about like building a data lake, also you want like to ingest this data into a table format that is optimized and built for data lake specifically, right? This is going to be like either like Iceberg or Delta or Hoodie or Hive, right? Hopefully not Hive if you're starting now, but you might also have Hive. Now, this process, the way that one of the ways that you can do it, right, if you want to maintain low latency in the ingestion process, is by using this architecture that you see here, where you actually use Flink. Flink is going to consume the Kafka topic and the events from there. We'll take this data, store them in the appropriate serialization, which is going to be like Parquet on S3, import the data like Iceberg. So now you have like all the nice things around like a table format like Iceberg with stuff like transactions, asset guarantees, and being able like to do like time travel and all that stuff. And at the same time, we'll go like to Glue, update Glue. So the catalog will have all the necessary information for a query engine to go and like query the data, right? Now, as you can see here, in order like to just like to get to the point, right, where something like Trino or any other like query engine be able like to see the data, right? You need to make like to pretty much like introduce yet another cluster of quite complicated infrastructure, which is Flink, right? Because it needs like to maintain the state in order like to do all the necessary operations there. And that's without even like touching how you can optimize the data that are going to be stored there, right? So for example, yeah, we store the data. How do we compact the data, right? It's not just like writing in the right serialization and making sure that the right metadata has been created. Then you have like other things of like, how do I partition the data to make it like more performant, or how do I compact the data when I have to do that? There are like a lot of data management operations that need to happen there that are not straightforward, and this needs to happen like through pretty complicated infrastructure, and that's without even like considering like the cost of that, right? And then you have like other things that are super important and can cause like a lot of problems and are not easy like to deal with one of the most important one being schema conflicts. So let's say something changes in the input data. How do we propagate that change? And should we propagate this change to the table that we maintain on Iceberg? I don't know, like maybe yes, maybe not. Maybe it should be like a policy that the team has predefined on how to deal with that. In some cases, we don't care if we lose data, for example, so we can just throw away like the problematic data. In some cases, we would like to create like some kind of like bed letter queue and like put the data in there, right? And being able like to go and investigate the data and act appropriately. In some other cases, we would like to just automate the process and have some kind of like rules on how to update automatically the table whenever we can, right? But in any case, they're like operating such an infrastructure at the end. It's like takes like a lot of effort, and I would say probably it's one of like the main reasons for like people being on call and actually having to get called to go on like and solve problems like at very inconvenient times, right? So obviously there are solutions. We can talk about like more solutions that are like people are like using out there, and we can do that like during our Q&A if you want. Even like specifically for like how Spark does it or like how Snowflake does it. But I would like to give now the microphone to Brian, and he will continue the presentation, starting from giving a few examples about Hoodie and how Hoodie works with streaming data. Brian, all yours.
Yeah. Cool. Yeah, so just to put a technical caveat up front, technically, Hoodie will enable. Hoodie is one of the data lake formats that will support the streaming ingestion that we were talking about. And the really nice thing about Hoodie is that it supports these features out of the box. Now, Iceberg is the other table format that can technically support streaming ingestion on specific database engines that have built the features necessary. So for example, the Trino Iceberg connector is one that we've spent a couple months to make sure that it supports all the Iceberg like file compaction, file indexing features so that streaming ingestion can work with Trino Iceberg. But if you try to do like Iceberg with a different database engine like PrestoDB that doesn't support the key features, then it will not work. So Hoodie is definitely the one that we think is the easiest to use out of the box in general. Now to deep dive into just like how Hoodie all makes this work, I think that we really saw a big revolution happen over the past couple of years when it comes to data storage. We used to go with Parquet and org files, which is like how everyone stored their data. And that was really revolutionary back in the day, because suddenly it meant that like, hey, you can store big data for at a cost-effective price. And there is an option of even cheaper Glacier storage of data in cold storage, which is even lower prices. And that really jump-started the big data revolution. But something that the data engineering community, like that we just did not have was support for like the rich analytical capabilities. And so I think that really ushered in the next file storage format revolution, where the new players like Hudi, Iceberg, really came on in and enabled analytics to be a lot easier. Now, the big innovation that Hudi was really the first to introduce, to give him credit, was the incremental data processing stack, which is essentially a serverless transaction layer, which works over the general purpose Hadoop file system abstraction over the cloud storage. And now the important features in Hudi that enable streaming ingest are more scalable readers and writers, file compaction, and snapshot expiration. So just to dive a little bit more on how this technically works behind the scenes. In terms of file compaction, the real-time streaming ingestion tends to flush out data frequently to minimize the data query latency. And so this typically results in many small files on the underlying storage system. And small files increase the I/O of scanning the data and dramatically reduces the overall query efficiency. And so what Hudi and Iceberg formats bring is transparent asynchronous compactions, which, to put it in more simple terms, is rewriting the many small files into fewer larger ones. And these compactions must happen periodically in order to retain healthy analytical query performance. And the second really important feature is snapshot expiration. The Hudi storage format really just creates a new snapshot or table version for each write to the table. And these snapshots get retained indefinitely and they accumulate over time. So to prevent this from becoming like a big slog and slowing down your queries, in order to limit the size of the system metadata, you need to just turn on the periodic snapshot expirations to remove old snapshots that are not in use anymore. Now, in terms of how to technically turn on all these features, they come out of the box with Hudi. And if you're already using Iceberg, then just click on the link in the previous slide, and we have a tutorial on how to do streaming ingest for Iceberg as well. Now, with that said, Kostas, can you go to the next slide? This is really just step one of the journey. The journey is like literally only 1% complete. Now, you see a big revolution that's happened. We started off all using Kafka as a topic transport system and hacking together analysis of streaming data. Then you see the real-time database management systems, Apache Pinot and Startree being the biggest ones, enabling true like real-time analytics. And I think really just over the past year, we start seeing customers doing streaming ingest into the data lake, which makes real-time data much easier to access. Now you don't even have to go set up and learn a different database system. But that said, there's tons of limitations that exist today. A lot of the rich analytical capabilities that you expect from a Trino, a Spark, just don't really exist for streaming ingest yet. Things like incremental materialization, the merge syntax support, deduplication. And so really there's still a lot of things to be done in order to really support rich analytics on streaming data in the data lake. Next slide. And in parallel, when Kostas and I at Starburst chatted across the Trino user base, we'd see a lot of users really just struggling with the ease of moving between batch processing and streaming. People literally have to like rewrite the SQL that they do and like set up a completely different system. And the building cost optimized streaming pipelines was another big challenge because people don't really have the expertise. And so these are actually in the venture capital world, problems that startups I'm seeing are tackling. So if you're interested in an open source solution that solves these problems, please do get in touch. And if you're interested in building like a better solution to really revolutionize the real-time world, please do get in touch. Next slide. One thing I wanted to leave the presentation on is Redpoint Ventures did a really good analysis, a survey of data leaders. And where the data landscape it really is today is people are spending a lot of money on data lake analytics and data transformation tools like dbt. But what the expected change that all the data leaders are expecting is that real-time data is about to get a lot more important, because we have just gone through that revolution where analytical data is in the data lake. And as people are able to analyze historical data, people are really thinking about like, hey, what more can I do with my data? And really trying to build like much more critical use cases, which tend to be real time. And that is really going to usher in just much greater usage of real-time data. Now, of course, if true real-time is needed, there's great solutions out there. But as Kostas and I have been like really pushing in this presentation, most of the customers we talk to don't really need precise real-time data. They're good with near real-time data, and that's where the data lake is really exciting. And as you can tell, the solutions in this space are just very nascent. And so there is just so much exciting startup opportunities to be had in this domain. And with that in mind, next slide.
There's no next slide. That's the last one,
okay.
Brian.
Yeah, and with that in mind, please do feel free to get in touch with Kostas and myself. Our contact info is in the next slide, I think.
In the non-existent next slide.
Next slide.
Okay.
Yeah.
Oh no. Well,
yeah, sorry. There was actually what happened here. We had some last moment changes, and apparently when you upload something on StreamYard, it doesn't reflect the changes on Drive. So that's what happened. But anyway, yeah, you can reach out to me and Brian like on Twitter. Obviously, it's quite easy like to find us. And
yes.
Yeah. Brian, I don't know if you want to give any other like contact details from like the VC or something.
Yeah, just search me up on LinkedIn or Twitter. It's like BrianJan1.
You know, luckily, it's the nice thing about having unique names. Yeah, my first name is not unique, but my last name makes me very easy to find. Thankfully, I mean, I'll find you guys though. I'll put you guys in the chat if you guys.
Awesome.
Please do.
Yeah. The only comment I want to make is you said back in the day, and I was just like, back in what day? 4 years ago? Over here making us all feel old. Back in the day, people used to do it this way. I'm like, people would. Oh man. Let's see. Trying to see if there's any specific questions. Does anyone have any specific questions? Link to study data cloud on. I don't know what that's going to do. Anyone have any questions specifically on data lake streaming, near real time? Anyone have any arguments to make about real time? What was I thinking? How like Brian, just since you have made this recent switch, how has the switch been? I know it's only like week. How long have you been now at VC?
It's already week 3 now.
Week three.
Honestly, it's really exciting. Just meeting lots of people, just really trying to rethink how things happen. And that's what really excites me. People just radically rethinking a domain and building a strong technical moat that just really transforms the experience that users have.
Yeah, that makes sense. It's got to be. Do you feel like it's different than when you were working more on product, or where do you see kind of similarities and differences?
I think with product, you really focus on building one thing. And when you're in venture capital, you're just meeting like at least 3 founders a day and really thinking through like just a lot more ideas than focusing on one single thing. Yeah. It's a very different experience.
Yeah, I imagine. So are you mostly like thinking about like the broad ecosystem versus like, what does my product do? It's like, what is this giant ecosystem?
Yeah.
So thoughts on GPT? No, I'm asking that's a question. Sorry, I should have posed that better.
I think that with GPT, I think the really interesting technical innovation there was asynchronous machine learning through through reinforcement learning has just made AI a lot more powerful.
Mm.
And I think that that's what ChatGPT was really the first model to take advantage of, like this reinforcement learning data, to build much more powerful machine learning models. And the most exciting things that you're really starting to see out of this is people are just applying AI to just build tooling that is many times better. So for example, like one of the recent announcements of companies like Seek.ai, you can just describe your query and then it generates your SQL for you. Or like another guy who I met just last week, Austin Hughes, he just announced it, is he's applying AI and just like building sales marketing tooling that's literally like 10 times better than what exists out there. So I think AI is really just going to make us as humans 10 times more productive, but we really are in the early days of it.
Yeah. It really is early. What was I say? So someone was asking, so for that, the previous slide with Redpoint, do you have a link for that?
I think it's cloudinfrastructure.substack.com. It's the source is in the slide itself.
Wait, let me see if I can find this cloud infrastructure. Oh yeah, I've seen this guy. Or person.
Redpoint, they do really amazing just surveys of like where people are actually spending money. So
that's interesting. I thought you were gonna say they do really interesting TikToks.
That I have yet to see.
Wait, you haven't seen like any of their? They've got one person that does really good ones, and I don't know who it is, but then every once it's like they'll do like two really good ones, and then they'll do one that's clearly trying to market, and then it doesn't do well. But it's how the algorithm works. It's not based off your followers. It's based off of the actual content itself. It's agnostic. Do you have any good examples of real-time versus real-time and what tools that can be leveraged?
I think real-time, probably one of the best systems is really just Apache Pinot and ClickHouse.
Okay.
There's lots of real-time tools, but I have a strong personal belief that database engines have to be open source, because you really need that cloud. Really need that optionality. Like for example, us at Starburst, we're using Datadog, and suddenly Datadog just ups the price by 2x out of nowhere. And that's the kind of thing that happens over and over again if you choose a proprietary database engine. And so with real-time data, honestly, like what we're seeing at Starburst with all of our customers is people are choosing Pinot and Startree just because it's a really good technological solution and there's that optionality. Now, in terms of real-time versus near real-time, like examples of use cases, I'd say with real-time, probably classic example is fraud detection, right? Like that kind of stuff, like our banking customers, they need to detect that in real time. And now with near real-time, I actually think that's where the bulk of use cases actually lie. So one of our like cloud IT platform customers, they had lots of near real-time use cases. For example, inventory management was extremely common, or like kind of how do you allocate inventory management, network management, a lot of including at Facebook, a lot of our fraud detection systems. For that kind of thing, like it's okay if you are late by like 10 seconds. And things will be fine. So you don't really need to like re-architect the system to really support the real-time guarantees of like, hey, you get data within 1 second and you can have 1,000 users on it like in an instant and things will not fall over. Many of the use cases will survive in near real-time just fine. And the beauty of that is that you just don't have to re-architect your system. It's just stream near real-time data into your data lake. And you can use your existing analytical database like Trino, Presto, Spark to just go query that data. And in terms of the tools to leverage, I'd say it's really just like using an Iceberg or Hudi data lake so that the real-time aspect is supported.
Yeah, makes sense. Speaking of Iceberg and Hudi, Roy was asking, so in terms of like performance for streaming data, do you have a point of view in terms of like apparently one being worse than the other?
So the thing that annoys me about the performance debate is like a lot of times, like including when we talk to customers at Starburst, people really want performance data. But the reality is that we see customers that have like literally 10x difference in the performance that they see from different systems, between Iceberg and Hudi, between Trino and Snowflake. And so I think it really depends on the use case.
Yeah.
Now, of course, like I think if you see like a 10x Iceberg is 10x worse than Hudi, then probably it's because you didn't turn on the file compaction or the snapshot exploration, and that's creating the small files and like file overload problem. But in general, Iceberg and Hudi within a 3x range, that is generally pretty common. And when someone says Iceberg is faster than Hudi or Hudi is faster than Iceberg, I think it really tends to just be like the shape of their workload, but there isn't like a hard rule about Iceberg is more performant or Hudi is more performant.
Yeah, I feel like that's like the case with a lot of solutions. It's like there's a combination of like, okay, performance, what are we really referring to? And then obviously it's like the whole Snowflake versus Databricks, like that one back and forth between like pricing and performance and like being like, okay, what's the difference? It's like, well, there's a lot more to just calculate besides performance. But obviously once you're getting this granular, it does make sense.
On that note, actually, the really ridiculous thing about like this Iceberg and like the Snowflake and Databricks debate is like they're literally debating, okay, like who is faster on a couple select from where queries that are on 100 gigabytes of data.
Yeah, which is nothing.
Like, and who's querying like 100 gigabytes of data? You don't even need a database system for that. Just use Excel files.
I don't know if you can do Excel files like 100 gigabytes, but
yeah, but
maybe with like Power Query, but
yeah, it's just like a contrived example.
Yeah. No, I guess it's more hyperbolic. But yeah, I get what you're saying, right? Like, it's that whole joke that was going around with DuckDB where it was like, what would you use to query like 100 gigabytes of data or a gigabyte of data quickly locally? And it's like, oh, this is a funny joke. But yeah, no, I think that makes sense. And no one ever publishes. Exactly. No one ever publishes a bench. It's like scientific research papers. They're like, oh, this doesn't prove the thing I want. Skip, right? Like it's like we're gonna keep testing this until we find a way that makes us look good. And so that's why it's always hard. It's like like you said earlier. Look at your use case. Say like, hey, what do I need? And almost any solution today can be probably fine-tuned to hit whatever performance you need. I always give the example of when we worked at Facebook, it's like they're on MySQL. That's their backend. Like there's a limitation somewhere and they're like, nah, we're going to forget that. We figured out how to go get around whatever limitations you think exist. We're going to use a relational database model to manage all of this. And then everyone else like, oh, we need to go to NoSQL. It's like, well, you can, but you can also just have a bunch of engineers design something that somehow works, you know. Yeah, so cool. Any other questions for anyone to ask Brian in terms of Iceberg streaming, how he feels like betraying the product side? No, I'm just kidding. As he mentioned, I do occasionally angel invest, but it's different, that's different. No, it's good. I love it.
Don't go
what?
Don't go down a rabbit hole of trying to argue angel investing is different.
Oh no. Well, that just makes me think of like VC brags, which is like the guys like, oh, Lord, give me the strength to put angel, like write $1,000 check and then put angel investor in my like profile.
Yeah, but I honestly think like what makes like you like stand out compared to other angel investors is like the platform that you provide people it's bigger than honestly like what any other angel investor I know provides.
Well, that's too kind. I think Swix has a pretty good platform. I don't know if he's still angel investing as much, but he's got, and it's broader because he's on the software side. The hard thing, like what's great about data is it's super niche. So it means like everyone I talk to is very much like in line, I think, with what I'm thinking. What's bad about data is it's super niche. So it's, Not a huge thing. Data infrastructure in particular. Data science is huge. Data engineering is. I always use the Reddit example of like you look at data engineering Reddit versus data science Reddit. I think the data science Reddit's like 800,000 people. The data engineering one's like 60 or 70,000. So it's like a 10x difference. And obviously it's not 100% accurate, but I think it's a good example of popularity.
Yeah.
But anything DBT versus Spark? Any thoughts there? I mean, to me, it's like maybe something like one DBT runs on Spark. I mean, runs on Spark in terms of like you could run on Databricks. That's the line there. Yeah.
Yeah. I think in terms of DBT, I think the really unique thing about DBT to me was it was really the first developer productivity tool that was out there in the open source.
Yeah.
Now that all that said, for example, like the unified programming model at Facebook had like lots of really cool features as well on top of what DBT provided, which is actually in the process of getting open source as well.
Oh yeah.
I think DBT they had a great start. Like it was definitely first mover advantage, but I'm also just personally really excited about things like unified programming model getting out into open source.
Yeah.
Because I think there's just so much more that can be done in the developer productivity side.
Yeah.
I'll refrain from commenting on Spark because you guys know I'm biased.
Well, I also was gonna say, like, again, like to a weird degree, like once it's like DBT is not a data processing engine, so to speak, right? Like it is merely a template. So it's like that is it's like, and like it does more than that. I shouldn't say that. It's more than a template. They'd get mad at me if I said that. But like the baseline version of it, right? Like it's like that's kind of where it started. It's like, what if we added software practices to SQL data modeling and transformation modeling, more specifically, not data modeling, transform modeling. They've added more since then, but it's a very different thing than like Spark, right? Like you just outline your thing and then it either runs on Spark. If you do it on Databricks, it runs on Snowflake. If you run it on Snowflake, wherever other engine you pick to run it on. So I don't think it's really a versus thing. They're very like probably meshing. And obviously right now they're really trying to rush towards doing Python transformations because probably for that very reason, so that they can offer Python transformations to people that do things like Databricks. So.
Yeah. It is crazy how like overnight they went from like SQL is like the world to suddenly like let's delete every single mention of that. And now we're SQL and Python.
Exactly. But it makes sense. It's hard to just do SQL, and in a world that's like demanding Python as well, you got to figure it out. We'll see.
Even in Trino, we've been doing that. Like we started working on Python.
Oh, nice. Yeah. How close? How far?
Still years out. I mean, I think the thing about this is like supporting Python is like building another database engine.
Yeah.
So it's something that we've been thinking a lot through. How do we avoid the pitfalls of like what made PySpark slow?
Yeah.
And really just trying to like re-architect something that's like really learning from the lessons and just like taking advantage of the latest advancements in database engines.
Yeah. No, that it is, and you're going the harder direction. I feel like with the other Spark going. I mean, it wasn't necessarily Python to SQL, but like it feels more like that, like from code probably more to SQL versus SQL to code. Just feels like a harder jump. Cool. Any other thoughts? Anything else?
On that note, I think the other thing that like I personally think is exciting is like there is some movement of trying to open source FGF at Facebook.
Oh yeah.
Which is now at Roblox. And I think if that thing gets open sourced, it's gonna just mean a lot for data engineers. Like instead of like having to choose between like SQL or Python, it's just here's a few configs and generate code that's like faster than what I would write.
Yeah, I feel like people stopped supporting that though. If I recall, I remember like suddenly it was just like in the ether, like whoever was supporting it left. FGF, trying to remember what it stands for, something framework.
Fixed granularity framework.
Fixed granularity framework. Thank you. Yes. So it wasn't necessarily a metrics layer, but it kind of gave you this ability to just config, your metrics. You create like date lists for you and all of this other stuff. It basically made you feel like you didn't have to know anything to create metrics. You're just like, I just put in this data in a certain format and out came a gajillion metrics for me. And now it just gets created every day. So
yeah,
it's helpful. Awesome.
Cool.
Well, I appreciate this, Brian. Thank you so much. Thank you much for sharing. And yeah, we'll talk again soon.
Yeah, thanks for having us, man.
Thank you.
Cool.
Bye. All right, now I'm about to bring up the next speaker. I see he is here and ready to speak. Hopefully you guys learned a lot. Let's bring up this Ming Shang. I'm going to add you to stream. How are you doing?
Hi. Hello, Ben. Hi, everyone. Can you hear me okay?
We can hear you just great. And I'm putting your talk up here as well. You can go and click through it. But hopefully your day is going amazing. I'm excited to talk about FinOps and how people can hopefully start saving money in a time when everyone needs to start saving money.
Likewise, excited to be here. Thank you for the invite, Ben. And I'm really impressed with how you're running. I mean, you're running a really tight ship. We can start right on time.
I mean, it's going great. It's going smooth. So perfect.
That's awesome. Yeah, I was fortunate. I got a chance to dialing to some of the earlier conversation. So it's a really great event. Hopefully, we can keep that continuing.
Yeah.
So let me know.
No, go ahead. Feel free to kind of give everyone your background, kind of what you did before. I mean, you started thinking that people should care about cloud costs and where you're kind of going.
That sounds great. Let's get started here. So hello, everyone. Thank you for your time. I'm Ming Shen, co-founder CEO of Blue Sky. We started early last year. It's been about 1 year in. And before that, I spent 9 years at Google as an Eng lead, led a team to build the storage and querying backend for $100 billion search ads and for other businesses later as well. And then later moved on and drove the work to rebuild the TensorFlow backend as well. So fortunate to be in the ML and data space. And before that, I was in different database startups. So really excited to get back to the startup land. Mm-hmm. And let me tell you a bit about kind of our core mission, the data cloud cost efficiency. As you all know by now, this is the era of cloud, and data workloads also are moving to the cloud. And we are kind of partway along this journey. And one of the key blockers is actually cost efficiency. Some of the users we've talked to seem to not be having such a great experience in terms of the cost side. They really love the access to infinite cloud compute power. But we would half jokingly point out that with infinite cloud compute power, you might also get an infinite bill size. Would you like that?
Yes.
So that's the state. And it's really important in order to finish the transition of IT workloads, the data workloads to the cloud, we need to keep the cost efficiency high, especially in this economic environment. And so this is a typical cloud data user journey that we have seen. When they just get started, they are super happy with now being able to use the power of the cloud. Pay as you go, no need to start with hiring a DBA, set up your own cluster, buy expensive software license, and so on. So that's really awesome. And as time goes by, they start experiencing some performance issues. That's okay. They don't have to slow down, debug, and solve the problem anymore. They can just throw more money to adding more computer power. Let's say move the workloads from small warehouse to medium, then to the large, and to Excel and so on. So then just buy them time so they can focus on business development. That's awesome. Until a day when they, let's say, hit the, get $500,000 worth of bill for a year. And that's where they start wondering, should I keep throwing money at the cloud platform and start paying $1 million next year and $2 million next year, and so on. So that starts feeling uncomfortable. But then as they start looking into their workload, they find that actually sometimes there's lack of visibility to really help them understand where the cost breakdown, where the biggest spenders are, and they don't have enough in-house time or expertise to debug and then to improve the cost efficiency. So that's what we're seeing over the time as their data workloads keep increasing. they would have to basically involve heavier and heavier processes, including possibly, recruiting external experts as contractors, or even building in-house expertise. And this can slow down their business. And over the time, the gap between their state of the cloud efficiency versus what efficient cloud can look like, the gap keeps widening. So that's what we see as kind of a common phenomena among the data cloud users. So I will not spend too much time. By now, everybody probably have seen this kind of slides where, in general, with cloud, there can be a lot of waste. And in the past, with on-prem deployment, waste just translates to maybe wasting some electricity. You have paid that license anyway, and if users get slowed down a bit, they can context switch. But now, waste directly translates to paying more because of the consumption-based pricing model. And so cost efficiency and cost reduction becomes a primary business objective. So one horror story we have seen along this journey is, when we just started our journey last year, we were actively looking at our data cloud users' query history. And from one example, we see there's a recurring query. I believe it might be a pipeline, a data pipeline. And it just repeatedly times out after 2 hours. I think it's because on that warehouse, the statement timeout threshold is set to be 2 hours. And so based on the pricing, it basically takes 32 credits around, or about $100 around. You can argue for a large company, $100 is not a lot, but it doesn't feel good if every day this query runs and it produces 0 result because it times out, and it just burns $100 every time, right? For the same organization, I'm pretty sure if the employee goes and have a business lunch and it exceeds, let's say, $75, they need manager's approval. So that's the typical cost governance policy that's installed in corporate in companies, but not so for data cloud yet. So that's one indication of how early we are along this journey of data cloud, transitioning to the cloud, and there's still some missing guardrails from the product side and also missing best practices. So at Blue Sky, we believe that this problem could be solved as an analytics problem. So the way we tackle this is, and by the way, this is also the way how many customers, many data cloud users tackle in-house without using any third-party tools. Start by gathering metrics, gaining visibility. So that's the measure layer we refer to. Try to understand how the cost is broken down across different users, different warehouses, and so on. So this is important before we, some engineers, some of us, we get excited jumping into a slow query and spending a couple of days or even weeks tuning it, and then making it 10 times, 100 times faster. It's very intellectually satisfying, but at the same time, it may not be the key kind of bottleneck in terms of the global spend. So once we get the measurement, it's also important to then start making some decisions regarding where things are worth us paying attention. So that's what we call the analyze layer. Where are the abnormal events? And so this in turn requires that we define what normal means. And there are a couple important sources of defining what normal means. We can compare the current behavior with our past historical behavior, for example. Like, for example, if the number of queries we run today is similar to yesterday, and yet the total cost increased by 20%, then something is suspicious. This is worth us paying attention to. Maybe the data volume has increased, and maybe there are some other causes. The shape of the query pattern has changed. So we basically provide not just the passive monitoring, give people a bunch of dashboards and ask them to look at the dashboard every day. We also give them active monitoring, the alerting, and tell them where it's worth paying attention to. And then what comes next is, in addition to presenting the problems, it would be awesome if the tool also presents solutions. So that's the optimization layer. We look at the the problems from the symptoms, and then figure out what the root causes are, and then how we can treat the root causes. So one example can be if the data cloud warehouse has too much idle time, means you keep the clouds up and running, but you are actually not running queries during that time window. So that's a clear definition of waste. And in that case, there were different ways of reducing the idle time. One way can be, let's try to bring down the warehouse sooner if nothing is running. But there we gotta be careful. You better be pretty sure no query will come to the warehouse very soon after you bring it down, because otherwise it might backfire. The cost of bringing it back up, replenish the cache, and then also if the user is waiting on the query to finish, then the user latency also suffers. So it takes some care and also historical workload analysis to then decide how to set these parameters regarding when to bring down the warehouse. You can also think about trying to stuff that kind of idling warehouse with more queries, maybe compact warehouses, move queries from other warehouses to this warehouse, or even just try to move this queries from this warehouse somewhere else and shut down this warehouse, like just decommission it. So different ways of solving the problem. And once we have gained enough success solving these problems as one-off, we can then think about automating the solution. So this can further reduce the kind of manual efforts needed in keeping an eye on the problems and then coming up with and applying the solutions. This is just like self-driving for your car. I can keep going, but I want to pause here and see, Ben, if there's any question from the audience, or happy to just go forward.
Let's see. I mean, I think that the one question I have here right now is, do you have any thoughts on self-managed open source data stacks? Would that kind of help organizations reduce their cloud costs?
This is very interesting. Thank you, John. So regarding open source data stack, yeah, it seems to be really kind of a really popular choice. My view is open standard is even more important than open source per se. Snowflake itself is not open source, but it's been really gaining strong traction, and giving a free tier for people to try out is important. Open standard in the sense of open data lake, where with Iceberg, Hoodie, data lake, it's open so you can have different query engines accessing the data. That is also awesome. It seems like that's where the world is moving to. Even Snowflake recently provides enhanced support on querying Iceberg. So that's great to see. Regarding self-managed, it's not yet clear to me what that means. I wonder if there are such self-managed solutions from the open source community. If so, I would love to learn and look into that. I feel overall solutions focused on reducing cloud cost has been really well developed in the public cloud layer, focused on AWS, GCP, Azure. But on the data cloud layer seems to be up and coming.
Yeah,
Blue Sky is one of the first ones. I am pretty confident there will be open source solutions coming up over time, and we'll be curious to follow them.
Yeah, makes sense. Cool.
Okay,
yeah.
Great.
Perfect.
Thanks. So let's keep going. So this is an example of one kind of UI design, one product design that can tackle the problem. So this is that's kind of how Blue Sky's user sees it today, but just as an example. So the user experience, the way I would explain that is to actually start with the middle section. This is the table of open findings. We grayed out the details, but I can give some examples of what these findings are. It's basically a continuously refreshed and ranked list of recommendation ideas for how to optimize things. You can think of it as like news feeds, but it's for optimization. We rank a recommendation high if it has high projected impact. In this case, it's about estimated cost saving. And it's also low effort for user to adopt. So one extreme case can be we detected some bad warehouse configuration. And we provide a alter warehouse SQL statement so that user can copy and paste to deploy that recommendation. And that takes no more than a couple minutes of time. And the estimate sometimes can be $2,000 or tens of thousands of dollars, depending on the size of the warehouse and how much room for optimization. So once people adopt our recommendation, since we continuously monitor users' workloads, then we also would get to see from the workload, the recommendation has been landed, and then it will get popped up at the bottom table called resolved. So that's where we can show, okay, this warehouse has been tuned, and here's the actual landed impact, how much savings we actually landed. And user can contrast that with the estimated saving. They tend to be pretty close, and that's an important step to bring the closure of the whole workflow. So that's the essence of the experience. Very simple. The key focus here is not to bring people the problems we find, but give them the solutions they can adopt. And this fulfills the user requirements where they just want to minimize the amount of in-house time and expertise needed to keep data cloud cost efficiency high. Now, one other interesting kind of UI widget we designed is at the top. We call it efficiency index. So this is a global index we have designed to give the users a kind of high-level sense of where they are along this cost efficiency journey. At a high level, if we detect some amount of waste or inefficiency, then that leads to a lower score. As people keep incorporating our recommendations, in theory, they can get to 100%, but we have never seen anybody achieve that so far. The cost could go up, as I mentioned, if user incorporate the suggestions. It could also go down if, first of all, if user introduce new workloads that contain new sources of waste. So that's pretty understandable. But also interestingly, since it's a SaaS product, if new features get incorporated, then more waste can be found. Then that also brings down the score. So the score could fluctuate. And our vision is in the future, we can further extend the score to incorporate possibly not just the cost saving, but also maybe the performance enhancement or the loss of performance, the lack of performance, maybe look at users' productivity and so on. So that's kind of our thinking about tying together different areas of optimization opportunities and compute a global score. So the last part is I will just go through a couple success stories to just share kind of a few general areas of optimization. The first area, as I mentioned earlier, is warehouse tuning. They tend to be low-hanging fruit. We observe how healthy the warehouse is running, how much idle time, if they have enough concurrency going on to increase the resource utilization. Then we suggest a few ways of tuning the warehouse, and these effects can be landed in a matter of hours or a day or two. So we can very quickly validate the landing impact. So that's on the warehouse tuning area. After that, whoever that does cost efficiency will tend to need to spend time looking more deeply into the query workloads. So that's what we would do as well. Looking at queries as white boxes, by the way, is also one of the key differentiator and strengths in the cost efficiency solution for data cloud. This is in contrast to the public cloud, where the EC2 jobs tend to be black boxes. Nobody kind of knows from outside in what they do. So then they tend to be only optimized around them, like putting the job into a smaller warehouse, a smaller EC2 instance, or shutting it down. But with SQL, it's white box. We can parse the SQL and understand known anti-patterns, for example, like, oh, you're using select star, but Snowflake is a column database. Most of the databases for analytics or columnar these days. So please don't by default select all the columns. Or, oh, you're having a missing join key. You join two large tables, but the join columns are not correct. So let's not do cross join. So in the future, maybe these patterns can be found a priori before the queries get executed. But for now, at least we can find from the query execution history and flag these bad patterns so people will know to kind of avoid submitting them in the future. So query workload tuning. And finally, tuning shouldn't be a one-time effort. We have seen in the past, including the past companies I worked at, workload optimization project can be like witch hunt, right? So a VP says, okay, let's all have all hands, let's push on optimizing workload. Okay, so then everybody drops their work and spend 2 weeks or 2 months and whatnot optimizing the workloads. Then, okay, declare victory, go back to the work, and then waste starts accumulating again. So how do we lock down the benefits? How do we kind of avoid regression? So this is where continuous monitoring and alerting is important. So there is one story we saw where after the initial success, we actually detected new waste, like emergent patterns that turns out to be very expensive, but are QA testing workload. So low value, but high cost workload. So we're able to catch very quickly and work with the user to reduce them. So that is kind of the power of having continuous monitoring and alerting. And so that's a slide just summarizing kind of the track record and some of the testimonials, but let's not spend too much time on that. And I want to just end this section with just sharing kind of our thinking of what the road forward could look like. And this is where I would love to get thoughts from Ben and from everyone. So the way we see the cost efficiency journey is in the dark ages in the past, cost efficiency tends to be a second-class citizen. People start developing and launching pipelines and BI reports, and then only when someone complains about the cost, they go and look into it. Sounds familiar, right? Especially in the last couple of years of good economic growth, it seems like cost efficiency isn't often a high priority. Now, fast forward to 2023. We are in a different economic environment, and the tooling, the best practices are also emerging. So in addition to passive monitoring, as I mentioned, building some observability dashboards where people need to eyeball it every day, we are also starting to see solutions, including Blue Sky, that provide active monitoring. So this way, people can kind of sit back and wait for their pages to get triggered, right, or Slack and whatnot. So wait for alerts. But even better is in the future, the monitoring can be smarter, where the thresholds can maybe be automatically configured, we think, thanks to the ML, the AI technology. So we can really customize the definition of what's anomaly based on users' workloads and continuously adjust that. And the last step, as I kind of hinted at earlier, is to make the whole thing automated. And this is analogous to a self-driving car. So I just wanted to share this and give everyone's thoughts. We think this is going to be a long journey, but it's going to be really exciting where one day we can finally make cost efficiency a first-class citizen. As people start developing new data pipelines and dashboards, cost efficiency will always be kept in mind and always be preserved, and not something that we only do as part of the production firefighting. I think that's it with the content we brought today. This is kind of a long, a slogan that inspires us, and we think, in general, there's a lot of work to do. This is an exciting area of data clouds, different data cloud platforms, and we want to one day rise above them and not worry about the cost and focus more on getting more work done and getting more business value out of them.
Yeah.
Thank you.
Yeah, that was great. Thank you. I should have a clap sound. Man. That was great. I think, I love that you had a few good examples. I actually just met Ross from NextBite yesterday.
Oh, great.
Yeah, he was at the dinner. We did like a dinner with a few other companies and data leaders. It was a lot of fun. So finally got to say hi to him. I've seen his picture on LinkedIn, but that was good. I can bring in a few questions. I think the first question, I am luckily currently not sponsored, so I can, if I felt like say whatever I wanted about Snowflake, I could. But any thoughts on how you feel about Snowflake? Is it expensive? Is it not expensive? Where do you feel like it kind of fits?
So from what we can see, Snowflake is actually a really good product. As many people know, the founders came from Oracle, really strong engineers. What we have seen when things get expensive, it tend to be, I don't want to put blames on any party, but Snowflake may not be properly used. When people use them, they don't have enough guardrails. And so costs can get exploded. That tends to be the case with other cloud data platforms as well. Remember, one of the key power of data cloud platform is they give you infinite compute power. No longer will you complain about sitting on some queue, waiting for some other department's query to finish, then it's your turn, right?
Yeah.
However, with that power comes with a cost. So you better be ready to pay the cost. Or otherwise, I think that, by the way, is Snowflake's official pitch. Be ready to pay the cost because you do get a benefit. And then what we at Blue Sky would say is, try to leverage some additional help from Blue Sky or whatnot to make sure you're consuming the really great power kind of in an efficient, responsible way.
Yeah, I think one of the things I often think about in this world is like, I always say that in the old days, I need to stop saying that. Before cloud, right? Like people used to literally care about, this column is 4 bytes. This column is 8 bytes. And we know that if we calculate how much space is on this rack, that means we'll run out of space in whatever. And that's your constraint. That's what you're working with. That's expensive and you have to pay for it in its own way. But it's more of like, okay, how do we avoid having to migrate in 6 months, basically? How do we keep it for 2 years? Now we've gotten rid of that problem. Like you said, that is not a problem. Go ham. Go storage, not a problem. Right? The trade-off is like storage is generally pretty cheap, but you have you can use infinite compute, and now we have to start thinking instead of in bits and bytes, we have to think about in terabytes, right? Like in petabytes. How much do you want to process at one time? Because that's where Snowflake's like, we'll charge you we'll charge you cheaply on storage, because the more data you store, and I mean, I don't think they think this way, but the more data you store, the more likely you're going to process it. The more likely you process it, the more money we make. So I think that tends to be its case. Again, I think it's about how you use it. If you only process what you need, and you don't have queries running that are charging you $100 a day just because, it's used well. And I think that's usually what I find too. It's like, look, Snowflake is good as long as it's used correctly. But if you've got it just using it for whatever and running whenever, it'll just kind of explode. So
yeah, indeed.
Let's see. Roy had a question here. Where was it? Oh, I think this is kind of you referenced this kind of on your automation. So I imagine this is kind of part of that process. Is there any way to kind of track certain types of queries? I think he's talking about here in production workloads versus experiments, but I imagine that's kind of part of the process. Are you guys kind of looking into that?
Yeah, indeed. Before any SaaS product solutions, this tends to be done manually by, a special type of people called DBAs. I don't know if anyone remember them. In the cloud data era, it seems the title of DBA isn't as often mentioned. But, I think regardless of their title, sometimes they may be called data infra engineer. They may be subject matter expert, like they can be solution architect from Snowflake or other, consulting companies, but they basically play the role of eyeballing the query profile, or also known as query plan, figuring out, this join is the bottleneck. Let's try to build an index or materialized view. In the case of Snowflake, let's try to maybe partition the table better, etc. Now this tends to be very expensive in terms of human time and expertise.
Yeah,
and so. In the past, I think what's done is DBAs have to proactively do this, because remember, for on-prem database, there's only limited resources. So if DBAs don't play the gatekeeping role, then the whole database is going to collapse.
Yeah.
But in the modern days, everybody provisions their own virtual warehouse as long as they provision the money. So that's why the initial job workload for DBA is actually reduced. But the problem is then it surfaces from another ugly front, right? It's not about, I'm waiting for too long. It's about, I'm spending too much. So yeah, someone still has to do it. And there are solutions, including the one from Blue Sky, that can automatically analyze the query profile. So one of the very strong product features from Snowflake, and very thankful for that, is called programmatic access to query profile. As many of you might know, in the past, query profiles are often displayed in the form of a graph, and it's consumed by human being. But now there's like a JSON form of the query profile that we can parse and then quickly figure out which is the bad join, or which operator is the culprit, and then provide some recommendations on what to do. Or as was suggested here, alert the user at least, hey, this query is really bad.
Yeah. Yeah, that makes sense. And like that's what is kind of that necessary next step, like you said, in order to get to automation. That's what it needs to be. It needs to be digestible information.
Yes.
That makes what I'm trying to remember what talk I was recently watching where they were like talking about tracking cloud costs. And they pointed out the fact that like Accenture's like cloud bill is like 10 million lines. It's like, can you imagine that your cloud bill is a borderline what people used to call big data, like just your cloud bill is like, so, there's no way you can like go through line by line and then whatever, drop down even between that and figure out, okay, what drove our costs without automation. Yeah.
Wow, that's amazing. That's funny. Even understanding that cloud bill becomes a big data.
you gotta spend money from your cloud bill on understanding your cloud bill. Just a weird.
Gotta go a few levels deeper. Yeah.
Are there any open source tools that kind of do this for specifically Snowflake? Do you know of any?
Open source tool for monitoring cloud spend, for building built-in query profiling, warehouse utilization. I remember I've run into some of them last year, but I unfortunately couldn't remember at the top of my head.
Yeah.
I'm sure more will pop up.
Yeah.
Will be interesting to follow this space.
Yeah, and I'm sure some people have probably even just built some DBT models, like for like maybe like not the same, but just like a dashboard that's just like, oh, here's like the basic metrics you could track. So I'm sure you can find. I think I've actually run into one somewhere where it's like track Snowflake costs, and you just kind of implement this DBT model on top of Snowflake. So they definitely exist somewhere. Well, okay, this is more interesting. Will accounting firms pick up on FinOps space? What's the history of FinOps? And I don't understand the last part, but accounting's interesting with cloud in general. So I don't know if you have any thoughts there.
This is really interesting. So my understanding is that FinOps, there's a really well-known organization. It might be associated with Linux. Maybe that's what this point is. And more companies are looking to join FinOps. My understanding is initially more companies associated with the public cloud space, but data cloud is now getting larger attention. So vendors like Blue Sky, others, I think we would have a very interesting active role to play on the FinOps side. Traditionally, I think FinOps is founded based on the observation that to solve the cost efficiency problem for cloud, we need a combination of technical people, engineers, and financially minded people. Because if you leave them alone, engineers may not always care about the cost. I don't know if anyone would agree here. And then financing people, they have the right top-down mindset, trying to understand the cost, but then they may not have the technical know-how to address things. So FinOps is like a cross-functional team that have a mixture of people from both backgrounds. And that seems like an awesome way of organize the work and tackle the cloud cost efficiency problem. So I'll be really excited, and hopefully Blue Sky can play an active role, kind of leveraging, but also expanding the existing FinOps best practices to also tackle the cost efficiency issues in the data cloud layer. Now, accounting firm, that's interesting. I imagine some consulting firms will do this, and this has to do with financing. So maybe that's where accounting might also be related, but I haven't looked into that.
Yeah, my only thought was like maybe it's like CapEx versus OpEx kind of thing.
Yes.
I'm like, maybe that's it. With cloud. It's like you said, like consulting wise, like it's almost like if there's a client that I'm working with that has Snowflake, I can almost, especially if they tell me they have Looker or Tableau dashboards that take 15 minutes, I'm almost like, I think I can reduce your cloud costs and speed up those queries at the same time.
So I'm curious, Ben, I know you work with various customers, various clients. From all of the requests you have seen, how often do you see the main goal is to make things run faster versus, I want to reduce the cost?
It will. I don't think I've had anyone directly ask me to reduce costs. I think it's usually make things faster, right? That's generally like, it's interesting. so I ran this whole survey about like trying to figure out state of data infra. And cost was one of the things that people brought up as one of the problems.
Yeah.
And I realized what I should have asked for cost was, have you done a cost reduction initiative, specifically not like reducing headcount, but like specifically for like your cloud in the last 6 or 12 months? That would have been a far more interesting question to have gotten answered, because it would actually state intent and not just like, oh, it feels like a thing we should do. Because I think people feel often like this is something we should do, but don't put, you know, like you said, like engineers are like, but this is just what it costs. Like, what this is what it costs. And it's like, but is it?
You know, that's a great point. I'd love to see in the next version of the survey. We'd love to learn more about that from our own kind of customer meetings, market research, especially the last 6 months. It seems the market has turned. More and more companies are starting to actively look for such cost reduction solution. And to your point, indeed, they seem to be more looking at the product, the SaaS solution, as opposed to looking for consultants, because if they want to save money, they may not want to bring, you know.
And I think if I recall, like there's a method, right? Like when they say like, I have a problem, you're a CEO, how do you solve it? Step 1, look for a solution. Step 2, find consultants that can either help you find the solution or can help you build the solution. And I think step 3 is hire someone to usually put it together is usually the process. Because it's like, that's kind of the expense route. It's like, look, if it exists and it's good enough, buy it. It'll generally be cheaper. If it doesn't, find someone that does it. It'll likely be cheaper. If that doesn't work, build it yourself. But that's generally the most expensive route. Because you have to get expertise, and building a solution is not easy. It was smart that you productionized it. Maybe someday I'll actually figure out how to productionize the consulting aspect, because it makes a lot of sense. One other thought that I had, like when you referenced like engineers not wanting to be constrained, I literally had an engineer like verbatim say that. Like I was like, oh yeah, like you could use Snowflake, and they're like, well, I don't want to feel constrained by cost. And I was like, it is the constraint. Welcome to the cloud. This is your new constraint. You're not limited to compute. You have unlimited compute. Whatever you pick is going to have a cost now, whether you're running something on, Iceberg and Trino, and that Trino is running on some, VM somewhere that's in the cloud. It's all going to have a cost. That is the constraint. It's one of many constraints, but it is a valid constraint that you should think about.
Yeah, indeed.
So no, that's good. Let's see. Any questions you have for me? We're kind of wrapping up here, close to time. We've got like 7 minutes till Zach Wilson will be jumping on to talk about his experience, kind of data engineering at the Hyperscale. So, that'll be interesting to hear, doing Airbnb, Netflix, Facebook, etc. But any other questions you have for me that I could help answer?
Let's see. So again, thanks for this great opportunity. Great to share with the audience about what we have seen. I'm curious, Ben, how you probably have seen among the different customers their different pain points over time. There is the adoption of kind of open data cloud versus different platforms. Where I'm curious where you see kind of the data platform architecture is heading. Do you see there's going to be a mixture of continue to use proprietary storage and query engine along with open data lake, or will one trend might tend to kind of dominate the other over time?
Yeah, I like from again the survey I did and then the experience that I have is everyone runs some crazy hybrid. Like very few people, like I've seen startups that have like Trino, Snowflake, and Databricks, and it's like a company of like 40 people. And I'm like, how do you have all 3 of these? Like, this must be so expensive to manage all 3 of these from a person standpoint and a headcount standpoint. So it's interesting. Like, and then you go to bigger companies and it's even more chaotic, right? Like they might have multiple instances of GCP that they're paying for, and some of that's due to the fact that companies start merging, and then they have to figure out how to get all that together. But some of it's just due to like departments don't communicate, or some engineer feels like they need one solution versus another solution. And so this was brought up earlier, the self-service analytics talk, where it's like, oh yeah, it's really normal for companies to have like Looker, Tableau, Power BI, and Mode. Right, like that is a normal situation for a large company to have. then it becomes even harder to manage costs, because it's like, where is all our costs going? It's like,
yeah, indeed, that's consistent with what we're seeing. It's really easy to onboard new SaaS products, including the cloud data platforms. But then productionizing them, keeping them cost efficient, and knowing which slice of the workload should be stored where or queried by which query engine seems like a continuous challenge. So I'll be curious to see how things play out there.
Yeah. And I think it's like what you referenced, workload. I don't know if people think about things in like that route enough. It's like, this is a workload where this could technically be run in a dozen different places. Where should it be run? It's just like, our team used Snowflake, so we just do that. But
yeah. And I've heard, there are different anecdotes, like platform A is better than B, faster, cheaper, or I've heard, B is better than A. So yeah, I will be curious to see how in the end, if the industry would converge to if there's some golden standard with, the benchmarking maybe, and understand the cost efficiency of the individual platforms.
Yeah. We shall see. All right. Thank you again. Yes. I will let you go. I really appreciate your time. And again, likewise. Everyone, I'll see you.
Okay. All right. Thank you, Ben.
Thank you. Bye.
See everyone.
All right. Thank you again, everyone. That was great. Zach should hopefully be jumping on here soon. He at least texted me. He sent me his presentation. I'm going to do one more, probably quick, just thanks to our sponsors, because I'm very thankful that they helped sponsor this and make this even more easy on me. So if you haven't gone to the DataStack show or listened to it, it's a great kind of podcast again that I happened to go. I think I was on like a year and a half ago. I should probably go on again or ask them to have me on again, because again, it was a great way for me to meet other data people. I think I got a good like 5 or 6 people that reached out to me post that show. And they talk about data and kind of some of the different stories that are occurring. So there's a lot to learn there. And I definitely enjoyed it. We had a speaker who technically is on it, Kostas. He originally was on it when he was at RudderStack, but he continued kind of being on it as he transferred over to Starburst Data. So he's still kind of playing a big role in that. The other company that I'm thankful that has sponsored us is SelectStar. So if you're looking for a data discovery solution, SelectStar is kind of a fully automated data discovery platform that helps everyone find and understand your company's data. Again, I referenced earlier, everyone seems to have multiple cloud platforms and analytics platforms. So if you have a solution that can help kind of manage all that and automatically just organize it so you can understand your data lineage as well as your different tables and have automated documentation, I think that is a great place to be in. So feel free to check out the links below. For SelectStar, I think you can try it out for free. And then DataStack Show is 100% free. You can just watch, listen, learn. And that's kind of, those are our 2 sponsors. While we're kind of sitting here waiting, we have about 3 minutes here until Zach's supposed to show up. I will kind of go through and see what questions we have. Let's see, this question's nope. If anyone has any specific questions on data engineering, feel free. I'm kind of try to see if I missed anything. Okay, with billions of records being processed daily, special scalability. Let's see. I feel like I answered this question already. What kind of projects? I'll answer this one. What kind of projects would have the highest value for students or new data folks to get into data engineering? So this is kind of an interesting question, because if you're just starting out in data engineering, you're just beginning your journey, right? So I think people focus really heavily on trying to use all the fancy tools and trying to show off that you have all these skills. When you first start out and you're first just trying to prove you're capable, like just deliver, right? Like I think that's always something that people miss. It's like, don't get too stuck with doing infrastructure for infrastructure's sake. So like being like, oh, I got to do Spark and Kafka because that's what I got to do. Really focus on those baseline skills and just deliver something. Because if you end up having too many tools, it can be kind of chaotic to try to manage. And I think it's a little disheartening when it's like, oh, I have to spin up 5 tools just to get started. So, really focus on building a project that will make you successful. So I gave an example recently. I did a video where I did a scraped data set where I used a tool to scrape the data. I stored it in S3. From S3, read it into Snowflake. From Snowflake, just push it to Tableau. Really, there was very little stuff I had to manage myself in that situation, right? Like Snowflake was managed. Tableau was essentially kind of a managed solution. Well, if I did it on the cloud, it would be, but it's a pretty easy solution. I could use Streamlit. Obviously, I could use D3.js, which is what I started to learn when I first started doing data visualization. I could have I could have done Beautiful Soup for scraping, and maybe done something crazy where I even managed to set up proxies and things like that. But you can kind of see how this project expands and expands. So I really say if you're trying to do a project, don't focus on trying to build this massive proof of technology that I don't know, that'll get you stuck just doing just behind doing infrastructure and all these little things. Because that's generally the disheartening thing I think with a lot of projects is they can be really taxing and take a lot of time. Hey, look at that. Perfect timing. Zach is here. So I'm going to add him here. Hold on. Remove my stuff. And then there's Zach.
What's up?
Hey, how are you doing? Are you
I'm
still
doing
over
great.
there in Utah?
Yeah, in Salt Lake right now. The Creator House is going great, dude.
It's Creator House 2.0. So
Yeah.
it's you, Tina, Ken.
And Ken, yeah.
Nice. So
And
you guys are
many more
moving there,
people
right?
coming, Yeah.
You have more coming?
Yeah. Oh, yeah. Like at some point, we're gonna have 6 in this house. It's gonna get kind of cramped,
gosh.
but it's gonna be great.
That's chaotic. So you got is Mickey coming over, or who else is coming over?
I think Shashank is coming.
Nice.
A couple other people. I can't remember. It's a list.
Perfect. No, that sounds great. It's gonna be Data Creator House. Is this 3.0 at this point?
Oh yeah, for real.
Nice. Are you guys snowed in?
No, the snow has not been too bad right now. Like it was bad like the last couple days, but yeah, today has been pretty nice. Yeah,
Nice.
I saw it in Denver. It's been wild.
Yeah. Like I was gonna do a happy hour tonight, but while everyone's doing their talks, I had to email and be like, let's reschedule.
Yeah, you're like, this is not gonna work. Like, there's a problem here.
I don't want people to drive and crash. So
yeah, for sure.
Cool. Well, feel free to start.
All right.
Do you want to upload your talk, or should I do it?
Yeah. If you can upload it, that's fine. Like,
let me see where you sent it to me. Let me find your talk. Here it is. I'm just gonna download here. All right, and then let's add your talk in. Slides. Upload your computer. Upload.
Boom.
Should be coming up here in a second. Just takes a quick. And then probably should have done it while we were catching up, but
yeah, it's all good. It's all good. Like, yeah, this this is structured to be kind of flexible in how long I talk about stuff. So
you're like, I can talk forever, or I can talk.
Yeah, you can give me 10 minutes or give me an hour. I can talk about this. All right.
Here you go, and you can click. You don't need me to click.
So if I click, it will.
Yeah. There's a little. If you put your mouse over, there's something that you should see. Next slide.
Next slide.
If you mouse to kind of the bottom middle.
Bottom. Okay, wait a minute. Okay, so in full screen, present. Next slide.
Is there full screen too?
I don't know. I'm trying. Okay, not so in full screen. It doesn't. Where is the? Okay, I don't see this next slide button, dude.
Sure. So if you mouse over to the middle.
Yeah.
Actually, if you just mouse over it, do you not see slide? Does it not say
I
slide?
don't see next slide. I think you have control there. I mean, wait. If I just present though, I think that works, right? Hold up. Okay. I'm gonna take it from you. I think.
All right.
Yeah, that works. I'll just present my screen and then I'll.
All right.
There we go. There we go. Okay, now it's all crazy. You guys can see my crazy desktop. Okay. Slideshow.
Perfect.
There we go. Awesome. Welcome everybody. So today we're going to be talking about data engineering at Hyperscale, right? And Hyperscale is kind of one of those words that is a little bit hype, right? It has hype in the name even, right? But what does Hyperscale mean? It's usually when you have a certain level of complexity that you need to tackle. And so, yeah, let's go into this a little bit. So before we get into it, I just want to talk a little about who I am. I've been doing big data for a while, worked at Facebook for a while, working in notifications. And we're going to talk a little bit there because one of the things about notifications and Hyperscale is Facebook sends sends billions of notifications every single day. So I definitely bumped into some scale problems there at Facebook. And then in data security at Netflix, I worked there. The main pipeline there that I bumped into scale is the network log pipeline. So I was a big contributor on the networking. So it's like it's the pipeline that processes every single network request that Netflix receives. That's the biggest scale pipeline I ever worked on in my whole career. And then more here at Airbnb, the main one that I bumped into a lot of scale at Airbnb is around the profitability pipeline that I work on. And that one is different. It's not scale in terms of like volume or velocity, but it's scale in terms of variety, because that pipeline is just so complicated. So yeah, some other things about me. I'm a creator on LinkedIn. That's my biggest platform. Talk about big data stuff every day. So if you want to follow me there, that'd be great. So yeah, let's hop into it. Okay, so big data and scale, right? There's a couple different things that you want to think about with scale. And like, I really like the paradigm of like the 3 V's of big data, where you have volume, you have velocity, and you have variety. And solving the scale problems for each one of those is somewhat different. And we're gonna, I bumped into some serious scale problems in each one of those buckets, and we're gonna be going over this today. So why is dealing with scale challenging? So let's just talk about that for a second. So for example, the pipeline that I worked on at Netflix, like that was is over 100 terabytes an hour of data. And so like, if that pipeline isn't optimized, it's going to cost millions of dollars, right? And if you can optimize it, you can save millions of dollars. So there's like one side of it that's challenging is just like the financial risk of the scale. Like mistakes or wins have like they're amplified when you're at hyperscale. Some other things that are interesting about scale that are challenging is like, for example, if you're processing 100 terabytes, right, then it's like that might take a while, right? There's like the kind of the dev cycles are usually a little bit longer. And so you have to be a little bit more careful and really think through how you're going to solve this problem. I definitely noticed that. I think another thing to think about with scale that a lot of people don't consider, and this is more from the kind of variety angle of scale, is dealing with scale when it's variety is also dealing with a lot of people, right? And managing all those relationships and understanding like how to get your upstreams to commit to becoming high quality so that you don't have to suffer as much. And so there's you can have a lot of like people problems actually at scale as well, which is different than like the standard things that when you think of like distributed compute, more computers, like more memory, or like how to kind of handle those other things, right? So yeah, those are the main challenges that we kind of talk about here with scale. And yeah, let's kind of dive into some maybe a little bit more like concrete examples here. Okay, so hyperscale, right? A couple slides back, I was talking, right? We have 3 main ways that scale can be you can bump into things, right? You have that volume, variety, and velocity. And those are the 3 ways that you can, as a data engineer, you can really land a lot of impact, right? Because if you optimize a high volume pipeline, you're going to save a lot of money, right? If you optimize a high variety pipeline, you're going to save a lot of time, right? Because a lot of times high variety pipelines have a lot of data quality problems, and they have a lot of like integrity problems or SLA problems because there's just so many sources and one of them is bound to be late, right? So if you can optimize a variety problem, then that is going to save a lot of engineer time, which is very precious. And that's like, if you can save time, that's one of the most important things. The cool thing about velocity problems that I think is interesting is that like, if you can solve a velocity problem in a very optimized way, it's more than just saving cost. You can also unlock new capabilities, right? So if you have a real-time pipeline and you're trying to detect like a security threat, if it's not in real time, if you do your security threat detection on a daily basis, it's worthless. But if you can do it in real time, then you can actually respond to a threat when it's detected, right? So you actually unlock new capabilities if you can handle the scale problems of the velocity side of big data. It's interesting though, because I think velocity is also one where there's this other side to it where people like data scientists and data analysts and people like that. They want their data as quickly as possible, right? And a lot of times that makes data engineers think that they need to go to streaming. But streaming can be complicated, and streaming, especially like if you already own a bunch of batch pipelines, if your team already owns a bunch of batch pipelines and you're trying to branch into streaming, one of the things I've noticed over my career is like teams should either focus on streaming or focus on batch. If you have a team that's split across streaming and batch, that can make on-call a lot more horrendous, because like the batch pipeline and a streaming pipeline, like troubleshooting those, very different, right? And they're very different paradigms. So like when a lot of your stakeholders are asking about velocity, you want to make sure that you understand what is the capability that is unlocked by having it be lower latency. And if the answer to that is that the data analysts can run their query faster on more up-to-date data, that's probably not a good enough reason. That's like, generally speaking, when that has been the ask, like I've always pushed back on that. It needs to usually be like, if like you have something processing in real time and it detects stuff in real time, and then it does an automated action in real time. And then that is the kind of amazing, like almost superpower that you can get from data engineering that you can't really get from the volume or variety buckets, but that like you get if you find the right problem. But those problems are actually pretty rare. Like I would say that those problems are like 5% of all data engineering problems. So I keep that in mind as we kind of go through the rest of this presentation. All right. I'm going to start here with volume. Volume is the one that, you know, when people think of big, they really think of like space, and they think of like terabytes and petabytes and exabytes and all that, right? All those numbers in the cloud, all those ones and zeros, right? And so, yeah, let's go into this a little bit. So really, when dealing with hyperscale, there's going to be two kind of like tenets, right? One is going to be like shuffle is your enemy. So if say you're processing 100 terabytes and you're trying to join it with some other data set that's pretty large, like a data set that's so large that it can't be broadcast, that's going to be a very, very, very expensive thing, because shuffling 100 terabytes of data is going to be essentially a showstopper. Like you can't do it. Like that's like, or if you do it, like Jeff Bezos is going to get very, very rich, and then like, and then your company's not going to make any money. So you want to avoid shuffle. And how do you avoid shuffle, right? So one way is if you're doing a join on the data set, that join needs to be small, right? That data set needs to be like under 10 gigs, right? So that you can broadcast it. Because with Spark, right, you can change the broadcast threshold, and you can actually broadcast bigger data sets. You have to allocate more memory to your executors and all that stuff to make it work. But you can actually do that, and that can remove shuffle, and that can make it so that the job runs a lot faster. Or another thing you can do is that like you can fix this at a different layer. So like maybe instead of doing a join, you like when the data is logged, you just log the field that you need, so that like every time you have a log, then the data is already there, and you don't need to do a join, and then you can just like do an aggregation or whatever that you need. And then that's going to be a lot better, because those especially shuffles that are caused by joins in big, when you have very high volume, that's going to be very painful and very expensive. Another thing to think about here is smaller batches may be your friend. So what I mean by why is there the word may there, right? So for example, like when I was working at Netflix and working on that pipeline that was 100 terabytes an hour, it's easier to solve that problem at the 100 terabytes an hour scale than it is at the 2 petabytes a day scale. Because imagine trying to write a pipeline that like you're just going to read in 2 petabytes, right? That's just like a lot of data, right? And like trying to solve the complexity when it's that high is like, it's not going to work, right? Your job's going to be really, really slow, or it's going to be very unreliable or whatever. And then, so you want to batch it up, right? And you want to like maybe think about things on the hourly scale. I generally don't recommend thinking about things like lower than that, like on like the sub hour, like the every 15 minutes or 30 minutes scale. Main reason for that is because Spark and these like big data processing tools, they have a startup cost, right? Because it's like when you run a Spark job, just to kick it off and get it to run, right? It takes like usually at least like 2 minutes just to get the job running, right? And so like if you're running the job every 15 minutes, that 2-minute startup cost starts to be a larger percentage of the window. And it makes it so that like the jobs can't finish in time. And so that's where an hour is usually nice. It's like a good middle ground. But it's the reason why it's smaller batches may be your friend is that there's a chance that you're not processing like fact data here. You're not processing logs. Maybe you're processing dimensions, right? And then in that case, you might not want to update all of your dimensions every hour because maybe only a small percentage of them changed. So in that case, a lot of times you want to work still at the daily level and just kind of figure out a way to get your dimensions to update once a day, because otherwise like updating them 24 times a day when most of them haven't changed, that is going to be very expensive and probably not going to solve your problem. But for fact data and log data and event data, smaller batches are always going to be your friend. And those are going to be really, really powerful. Okay, so now we're going to talk a little bit about this, like on like just a little bit more of a concrete example of something I worked on with a couple of my other coworkers at Netflix. You'll see there's a link here if you want to like check it out yourself as well, get a little bit more information. So essentially what we wanted to do here is we need to figure out, so when we get a network request, we need, so Netflix, right, they have a microservice architecture. So what that means is there's not just one app in Netflix, there's like thousands and thousands of apps. And so, but like when a network request comes into the VPC, we don't know which app it's associated with. And so what we need to do is take the IP addresses that map from IP to application. So then we can see like, okay, this request went to this app, and then maybe this app talked to this app. So then we can kind of see like how our microservices are talking to one another. And so a big thing that we want to do there is get this, and you'll see down here, this mouthful SQSQ, this Apache Spark step down here. That is where you're going to join the IP data. And that data was small enough, right, that we could get it down to being a broadcast join so that we don't shuffle. Because if you do shuffle here, that is going to make this a lot more challenging. One of the things that's interesting about this problem, though, is that like we found an interesting kind of breaking point with this design, is that like we were able to broadcast join IP data, but only if it's IPv4, right? Like the old IP address data, because that space is a lot smaller. IPv6 data is very, very large, very, very huge, right? And it would be impossible to broadcast the entire IPv6 data set into here. That would have to happen over shuffle. And we tried that, and obviously it doesn't work. Data's too big. So in order to solve the problem at a different layer there, right, what we did instead here is, going forward, what you do is you log the app. So when in this flow log file, you just, when the event is logged, we have this thing called a sidecar proxy. And the sidecar proxy enriches the request with the application name. And then we log it, right? And then that just removes the need for this join. You don't need it at all, right? And then this problem becomes dramatically simpler, and you don't have to you're essentially at that point, once it's logged, then your logs are already the data. You don't even have to do any processing on them, right? They're just ready to go. You just need to aggregate them to see like which apps are talking to which apps. But that's going to be a cheap aggregation, right? Because that's just a group by, and the cardinality there is only like a couple thousand. So that'll be a pretty cheap group by to do. So yeah, that I highly recommend reading up on this link here about this design on like how to handle this data set. This is like very large volume, as big a scale as you could imagine. It's freaking awesome. Cool. So that's kind of like what I want to talk about with volume. I think there's I guess there's a couple other things that I think are important to talk about here, where, okay, what if you're in a situation where you need to do a join, that join can't be broadcasted, and you can't log the data, like you can't put the data you need in the logs, right? Because that can happen too, right? That you can have a design where that is the situation. So in that situation, you are going to want to leverage bucketing. So you can do this thing called a bucket join. So where you bucket both tables on an ID, right? Whatever your join key is. So then when you join that, it still does shuffle, but it doesn't shuffle the entire data set. It only shuffles within each bucket, which can dramatically reduce the amount of shuffling that occurs. And that is obviously it's not free to put it into buckets, but it's usually pretty cheap to do that. And then that can be a way to help minimize shuffle if you have to join like a large data set to your like hyperscale data set. That's the way that you're going to want to do that. There's another one that's similar to that. It's called an SMB join, which is a sorted merge bucket join. That's very popular, especially in Hive. And you can do it in Spark as well. And that's another way to do these joins without, and if you do a sorted merge bucket join, then you actually have no shuffle at all. It just does everything on the map side and you don't have any reduced step at all. And so, but obviously like having to sort all the data is expensive, and that is a shuffle in and of itself, right? So that might not be the best case, right? Because you do have to pay that cost somewhere. Cool. So yeah, those are kind of all the ways that I've thought about dealing with volume. I've worked, I've solved these similar problems at Facebook, kind of like with those kind of techniques, the bucket join and sorted merge bucket join. And so those work pretty well as well. I personally like this kind of design that we did at Netflix, where like we got rid of the join completely. It felt like some magic, right? It felt like, wow, this problem just disappeared. Okay, cool. Let's go to the next slide here. All right, now let's talk about velocity. Velocity is a good one because this one is kind of more, like hype right now, and everyone's talking about like, oh, we need our real-time data. Real data engineers use real-time data or whatever, right? Cool. So let's just talk about the two. So each one of these topics, I have 2 points to talk about. So the first point with velocity is streaming works great when the window is smaller, and then microbatch works when the window is big, right? So what I mean by that is if you are doing a streaming pipeline that's doing like a join, right, or something like that, where you have logs and then you're adding more things to that log, but you're not aggregating it, you're not holding on to data, or if you're doing like small sessions, maybe you're doing like a 15-minute session per user, or like some sort of like smaller window for sessions, then you're probably going to be fine. And that's how you can kind of aggregate and dedupe in a smaller window. Streaming kind of falls apart if you're trying to dedupe across an entire day, because then you have to hold on to every record for the whole day, and you have to hold on to all that in memory. And then like the amount of memory that you have is insane. And then you're holding on to like terabytes and terabytes of data just to dedupe everything. So I've even noticed that like when I was working at Facebook, I tried to use the streaming pipelines to dedupe notifications, right? And like it just OOM'd, right? It would run for like 40 minutes, and then it would just OOM. And then like I like talked with the info team, and I'm like, I need more memory. And then they gave me 10 times more memory, right? And then it ran for 4 hours, and then it would OOM. And I was like, okay, I need more memory. And then like the infrastructure team was like, no, you don't. You need a different approach. You need to do something different. And so that's where the second bullet point is really awesome, where you have micro batch works when the window is big, right? So if you need to reduce the latency, not to real time, right? Because real time is like a lot. But like if you say you need to reduce your latency a lot, especially on dedupe pipelines, then microbatch can be a really, really wonderful approach to doing that. And we're going to talk more about that in this next slide. Okay, so when I was like deduping notification events at Facebook, right? Initially, what we had this one Hive job that just ran, and it deduped all the events like in one query, right? One big old Hive query. That query ran in 15 hours, right? And one of the problems with that was that like this deduped notification events was upstream of a lot of other critical pipelines at Facebook. And so since there was a 15-hour latency, that mean that all these other critical pipelines could only start after 15 hours, which was like very painful for them. They made it a lot harder for them to iterate quickly. And so what we did was like, we tried the streaming approach, where instead of doing one big query at the end of the day, we try to hold on to all of it in a stream. It doesn't work. Like, I mean, or it probably would have worked, but like the amount of like memory and like RAM that we would need would have been like prohibitively expensive. So what we did instead is we do hourly deduping, right? So you'll see in this diagram here, we have like a big tree, right? So there's going to be a total of like 24 hours that you need to dedupe, right? So you can imagine what we do here is like we have a wait for hour 1, and then within the hour, we do a group by of just that 1 hour of data. And then we do it again for hour 2. And then we merge those two and do another dedupe between hours 1 and 2. And that's how, and so here, once we're at this merge step, we have deduped stuff for the first 2 hours, right? And then the cool thing about this is this can run while the data is being collected, right? So hour 1 can run like immediately after 1 hour has passed, right? And so it can start running 23 hours sooner than if you wait till the end of the day, right? So that's really powerful. And so if you use this kind of tree merge concept, where like then after you merge hours 1 and 2, 3 and 4 like this, and then you merge those together, and then you merge those together, and you merge those together, and then finally you get this final merge here. And this step actually runs really quickly. So this final merge, this last step runs at the same time that the old query started at, but this step runs in like an hour instead of 15 hours, because all the deduping has mostly already happened, right? And we've already gotten rid of all the dupes from all these other steps. So so instead of taking 15 hours and waiting, then people were able to have all their deduped notification events in like an hour or 2 hours after the next day. So, and people are very happy with that, because then this job was a lot more reliable, and it really enhanced a lot of other people's downstream jobs, and they could run a lot sooner. I have a GitHub repo that you can check out. This link, there's an Airflow repository, or I have an Airflow example of like how to structure a DAG like this, because I'm sure one of the things you're looking at, you're like, this DAG has a lot of steps, right? This DAG has there's a lot going on here. So definitely check out that link to kind of dive a little bit deeper here than what I've done in this presentation. So the reason why this worked, right, is that we never really are dealing with a ton of data until the final merge down here. And at that point, it's already sorted, it's already deduped, and it's already really fast. So in that way, this micro batch solution was more robust than a streaming solution, and it solved the problem in a way that was good enough to solve what they were looking for. That being said, right, if you have streaming jobs that don't do dedupe, and all they're doing is like going to a fact table, or it's just like a simple read, and you're taking data from Kafka to Hive, or like it's like a simple transform, streaming is so good for that, because then you don't have to hold on to any records at all. And the memory that your streaming job needs is actually tiny. And so that's where streaming jobs can be very, very robust. But once you introduce like dedupe or group by or join can be okay as well if the join is like kind of small. But like especially dedupe and group by, those make streaming jobs need more memory. And at hyperscale, it just doesn't work, essentially. And so, and that's where you need to think about things in a different pattern. And this is like, I really like this pattern, because this micro batch pattern, because it's a nice middle ground between like running things daily versus running things in real time, right? And you can still get reduced latency, but without the penalty of like having to set up a streaming job when like you might not know streaming jobs. So definitely check this out for sure. Velocity stuff is really cool. All right. Now we're going to go to the third one. This is the section that like I've done this pattern a lot, and variety patterns are really sick. So what do I mean by variety here? So some data pipelines rely on a large number of sources, right? So for example, at Airbnb, we have this unit economics pipeline that computes whether or not a reservation was profitable. And you could think of like all the things there, like, did they use a coupon? Did they file a claim? Which credit card did they use? Was it Visa or Discover? Because those charge differently, right? And it's like, okay, what country were they in? Because the tax rate is different depending on the country, right? And so there's like tons and tons of things that go into that. And then you have to read all of those sources together, get them into one schema, just so you can get that final like profitability number, right? And I've done this pattern a couple times, this variety pattern. I've done this once at Netflix and once at Airbnb for products that were really, really powerful. So yeah, we're going to talk a little bit about a design here. So variety, right? There's going to be two things here. So you need to standardize the schema, the ETL, and the data quality. That is an important part. And the second part, which is more soft skill oriented, is you need to work with your upstream teams to reduce landing times. So your upstream data sets should be as optimized, or your upstream sources should be as optimized as possible. Sometimes it's easy because like your upstream source is like a REST API. And so you're just hitting live data. And so those guys don't need to do anything. But if your upstream source is like a data table, maybe that data table is like really terrible. Maybe that data table is created by some 1,700 line SQL query that makes your eyes bleed, and you don't want that, right? And so you need to go work with them and be like, hey, make your SQL better because it's bad, right? And having those conversations can be really helpful, and they'll really help reduce the pain that you'll experience. Because a lot of time, if you own these data sets, these downstream data sets that depend on 40 or 50 upstream sources, like almost once a week, someone's gonna be like, hey, your data's delayed. And then like, you're like, yep, it's delayed. And then you're like, okay, why is it delayed? And it's like, oh, it's that same stupid table that's always delayed. And then you have to go talk to those guys and be like, hey, unblock your table. And then they'll unblock their table. And then like, after you have that conversation once a week for a year, you're going to go insane. And then you just need to talk with people, right? And actually like get them to solve the problem in a more robust way so that you don't, just to protect your mental health and your own sanity, right? So yeah, let's go to the next slide here. So this pattern here I've created, it's an interesting one. And like I have a GitHub repo here. So this pattern I call the little book of pipelines. And this is essentially a way of handling an arbitrary amount of variety in a scalable way. So the way the little book of pipelines works is the first thing you need to do is you need to define your schema. And this is the schema that all of your sources and all of your upstream and all of your jobs, they need to push all of the data into this schema. In this case, we have identifier, which is what things are usually deduped on, type name, right? Like when I was working at Netflix, I built this, and it was a big pipeline to collect all of the different objects in the infrastructure. So in that case, it might be like an application or a database or a load balancer, right? And then properties, this is like a flexible map of like whatever other properties you want to put in this data set. And then group name is the partition key, right? So this is how you're going to partition your table for each one of these individual jobs. All right. So we'll go, make sure to look at this link though. A lot of this stuff is a lot more spelled out there. So the next step after you create this schema is you need to create these enums. So in this case, we have, and these enums are called an item group. So an item group is a collection of items, right? So in this case, we have group one. And so name group one. So this group one here is the same as the group name here. So that would be the partition key, is this name here. And then you have items. So this is the list of all the items that you were expecting from this group. Sometimes there's only gonna be one, or it could be n number of items. And then inside the item schema, right, you have an item name, right? In this case, that might be like application, load balancer, or like whatever other item name you want. It's very abstract, right? So it can kind of handle a lot of different cases. Then you have your data quality thresholds. So these things are going to be how you can standardize your data quality, and you put your data quality thresholds in Scala, and you don't put them in Python or in Airflow, right? Which is, I like that, because then like all your data code and all of the configuration and everything is just in one spot. And then the last thing is item level properties. So this is just things that are like constants that are connected to this item. I just put an empty map here. You could have a bunch of different things there depending on how your items, if they have any sort of constant fields that you want. I highly recommend checking out that stuff. So after you define your schema and you define your enum, then what you need to do is you need to define your base job. So your base job takes in two things, right? It takes in a group, right? So in this case, it could be like group 1, group 2, whatever, right? And then it takes in a source, right? And a source here is a function that takes in a Spark. So it takes in a Spark session and it returns a data set of intermediate data set. An intermediate data set, remember, that is this schema back here. So when you define this function, right? So this is our abstract job. So keep in mind, this job does not like actually run. We have to implement this job in various other forms, right? So then what you have, right, is you have this output data table. So this schema sum output table, everything's going to dump. That table, this sum output table should have the same schema as intermediate data set. They should have the same schema, right? And then how it works is it's pretty simple, right? You have Spark, you build your Spark session, and then you get your data frame by calling that source function. You pass Spark to the source function, and then you write the data frame out to the output data table. That's pretty much it. Pretty straightforward. So now I want to show you what a job looks like an actual implemented job. So now we're in the object case. So now this is a job that can actually be ran because this is a concrete implementation. So in this case, we have a job, right? And we specify the group. The group here is group 1. And then we have our source, which then creates a data frame that reads from an input table. And then it adds the identifier, type name, properties, and group name columns. And then it casts it as an intermediate data set. So then it's returning the right value. And then this job will run, right? And this job will, so then all you got to do is as you get more groups in your data pipeline, right? There might be 7 or 10 groups. You create more jobs like this. And then each job will output to that same intermediate data set schema. And then that is how you can kind of consolidate everything. And the cool thing is so the last kind of piece that you want to include here is if you go back to this item group enum, you should also have a job. And what the job does is it takes this enum and actually turns it into a data table, right? Where it's kind of a data table where it's like you have group 1 and then it flattens this list here of all the items. And then it has like group 1, item 1, and then all of this as like columns. It's a very small table. Usually it's like, depending on how many groups and items you have, it's probably going to have like 20 or 30 rows, right? And that little table is what this design is very powerful about, because then you have the data quality thresholds. You can access them in Airflow by joining, right? So you don't have to configure them in Airflow. You configure them in Scala, and then you access them from joining, right? And that's where the name comes from. The little book of pipelines is you have these groups that all define like a specific pipeline, and then those each group maps to a specific implementation job. And then that group then has its own data quality parameters. And that is how you can kind of have standardized data quality across all of these and a very concise API. So conclusions here, right? So volume, right? 2 things to remember: minimize shuffle with broadcast joins, maybe bucket joins. And the other thing is like if you're doing fact or log data, then use smaller batches, hourly windows, right? Velocity is the big thing there is like streaming for small windows, and then use microbatch to reduce latency otherwise if you are trying to do like a daily dedupe or something like that. And then variety, right? The 3 big things here: standardize your schemas, standardize your ETLs, standardize your data quality checks, and do this all with an enum, right? And then that enum can then be turned into a table. And that table can also be used in dashboards and all these other places. Like it's a very powerful little table that describes your whole data ingest. So yeah, that's pretty much it. I think I have a couple questions, a couple minutes for Q&A here.
Yeah, you do. And there's a few questions, but first off, thank you so much for all of that. Definitely a bunch of I love how in depth you went into the V's. I think that's what I was like, oh, this is very well broken out. I feel like everyone kind of just high levels it, but it's nice to like kind of go deep down into each.
Oh yeah, for sure. Go deep there. Yeah. So what kind of questions do we got?
Let's see. Book recommendations for engineering at the hyperscale. If they've already read Designing Data Intensive Applications, but want something practical. Any thoughts?
I mean, I like Joe's book, Joe Reese's book. Like that, like his book is like it doesn't have quite as much of the hyperscale stuff in there, but it like if you get these fundamentals, like a lot of that stuff, a lot of the stuff I talked about today, like is just an extension of fundamentals of data engineering anyways. So if you have a good grasp of distributed compute, the conclusions that I came to in this presentation are pretty straightforward. So definitely check out that book. I like that book a lot.
Yeah. I just missed the other question. Oh, here. What's the way to handle? I'm sorry, I'm covering your face. What's the way to handle operations? 100 gigs of like Spark data frame. It does have if it does have shuffling involved. Can't use broadcast.
Yeah, 100 gigs is usually going to be fine. Like, I mean, you're going to like that the scale, most of the stuff that I'm talking about here, you need to have another couple zeros there. Like, like I would say that like really you're going to really bump into a lot of problems here when you're at like 10. If you're at like 10 terabytes, that's when you're going to really have some problems here. Like 100 gigs should be fine. Like, yeah. I mean, if you're having a problem there, that might be something with like EMR where you're not getting enough resources or something like that. If it's really slow, it could be actually like a platform problem where you actually need to get more compute and more resources. It could be that, or like you could have like you might have like some join logic that's messed up. That's like doing like a cross join or like some other thing there that's making it slow.
Yeah.
But generally speaking, 100 gigs, like that should be, Spark should be able to crush that. So yeah.
This is I do think that should be very true in terms of like that size. I actually when you brought up network, I think I ended up interviewing for that team as well, like the infrastructure team for being a data engineer, and like a lot of their questions were around like no, but like how would you handle this like massive amount of data? It's like I remember there's like one thing about like analytics where it was like, okay, how would you store all of this? And like you have to like aggregate it, and then how would you like reverse find the average, because you don't want to store all of this data like as a single row. It's like, what if you just store it all as like a aggregated row instead? So it's very very different setting.
It's crazy how different data engineering roles can be and like what you have to focus on. Whereas like in these other roles, like you can have other data engineering roles that are like hyper focused on the business, right? But then you have these pipelines where you have to hyper focus on like the technicals because they're just so large and they just like slap you in the face, right? Yeah, for sure.
Yes, they do slap you in the face. No, I remember like I was like our quotas was like maybe in the terabyte, and then like you'd go over to like the ads team and it's like petabytes. Like we're dealing with petabytes here. This is very different scale. So just one question in terms of, I think maybe you're maybe data driven kind of design there in terms of the mapping. So maybe just why not put it in Scala? If that's, or maybe you run it through Scala. I imagine you're just running it through Scala.
We're talking about in the volume here, or like which design are we talking about here?
I'm assuming this is, so why put that into Scala instead of having that be data driven? You know what? I think
that's a great question. So, why put it in Scala instead of having it be like in the DAGs, right, with Python, right? Like, I think one of the reasons why I like to put it there is then all of your configuration is in one place. Because then like your data engineers, you can ramp them up on it a lot quicker because it's like it's just all in one spot. Right. As opposed to being like, oh, yeah, we do our things here. And like the other thing I don't like about the DAG place is like a lot of times like getting everything into that nice like enum structure, because then if you don't put it in Scala and you put it over there, what you have to do is essentially create a copy of the enum in Python, right? And but initially that's what I did. I created a copy of it into Python, and I was like, wait a minute, this is kind of dumb. Like, why are we duplicating this same thing? And then like whenever I added a new enum to the list there, I had to like then pop it over into Python and like add it there as well. And I'm like, I don't like, I like having all of it kind of one spot. Like there's, I have some other like thoughts on like how to take that design a little bit further. That would, I'm gonna make a video on it or something at some point. But like that, like there's that design has a lot of legs to it for sure.
Yeah, yeah. I guess he meant more about the quality checks. Why not store them in a table?
You store the thresholds in a table and you run the quality checks in Python, right? And the way you access the thresholds for like percent non-zero, percent non-null, and stuff like that, you access those with a join.
Yeah.
Right. It's a very easy, very lightweight join. That's an easy broadcast join. And so, yeah, you don't do the DQ in Spark, because like if you do the DQ in Spark, the problem is then you fail the job. And then like, what if it's a false positive, right? If it's you fail the job on a false positive, and then you're like, I have to like reprocess everything. And it's like, super big pain. Right. And so like, yeah, because the Spark doesn't putting the checks in Spark doesn't allow you that ability to be like, oh, it wasn't an issue, right? It was actually a false positive. So just skip this failure and go on. Right. So, and that's where it's better to have that be in like afterwards, like after, like when you do like write, audit, publish, right? So you write the data to like a staging table, and then audits. In that audit step, you should be using like probably like Presto or some other quick querying thing to then like check the staging data. And to get the thresholds, you join that staging data with this little book that I was talking about. And that's how you can get those thresholds that you're checking for, right? Like to make sure that everything passes. And so then, and then if those fail, then you can just, and it's a false positive, then you can just skip it, right? And it'll be fine. So yeah, that's like, yeah, it's definitely like one of the other parts about that design is that like, there's a lot of complexity in those pipelines, and no matter how you solve that problem, there is going to be complexity somewhere, and it's like annoying, right? Because the other option is you put those configurations and thresholds in the DAG, and then you just have this long list of configurations. And like I personally was like, that's ugly, and I don't like that. So
yeah, no, that makes sense. All right, we're up at 3:30. I don't want to take more time than you've already given. I really appreciate everything you've shared. So thank you so much, Zach, and hopefully we can talk again soon. Are you coming back to Denver? Just
at some point, yeah, for sure.
Perfect. All right, and see you then. Bye. All right, time to bring up the next speaker. So let me just bring them up. Another ex-Facebooker. We're running the gambit. Hey Chen, how are you doing?
Hey Ben, how's it going?
Doing great, doing great. I worked with Chen, or at least we worked pretty much close, same-ish teams, and then we both left almost at the same time-ish, sort of. Chen was the head of data engineering for AI at Facebook, and now he is head of data engineering at Discord. So yeah, thanks for coming to talk.
Excellent. Thanks for the intro, Ben. Super excited to be here.
Yeah,
it looks like we have slides up. Amazing.
Yeah, I just brought it up. So
perfect. Let's go ahead and get set up here. Audio and video all coming through, Ben?
Yep, they are.
Excellent. Well, good afternoon, good evening, everyone, and maybe good morning. It's the morning somewhere, right?
Exactly.
It's great being here. So again, as Ben alluded to, by way of introduction, I'm Chen, and I'm currently the head of data engineering at Discord. Here at Discord, we're a team that builds robust and scalable data foundations for the many product lines that we support. Anything from revenue, finance, growth, trust and safety, to messaging, marketing, and core ecosystems. We reside right in the middle of our data org and partner with upstream engineering teams in data platform, as well as data infrastructure. And our downstream stakeholders typically live in data science, product, and business teams. Also, as Ben alluded to, prior to Discord, I spent the past decade at Facebook and LinkedIn doing all things data, from product analytics to back-end data engineering. Today, I'll be covering the topic of building a data foundation from the ground up, the journey towards achieving a single source of truth. All right, well, let's start off by painting a picture of data in reality. We all know that data is always perfectly generated, super clean, and ready for consumption, right? Well, that's wishful thinking. The correct answer here is wrong. Credits to XKCD and Dilbert for portraying reality so well in the face of humor. If either of these comics resonate with you, well, you're definitely in the right place. We've all been there, managing shaky pipelines that could break on a moment's notice or having to deal with questionable data quality. The fortunate thing is many of these issues stem from a poorly established data foundation, and therefore this is actually a solvable problem. Next up, we'll dive into exactly what a data foundation is. So, what do we mean when we say data foundation? Well, I decided to introduce our generative AI buddy, ChatGPT, for a few responses. Let's be honest, it's 2023, and I'd be remiss to not take the opportunity to include output from an LLM in my presentation. As you can see, there are multiple variants of how data foundation is defined because generative language models return unique results. Combing through these, I personally prefer the middle response and think it's the most accurate given the context of this session. Reading this out loud, a data foundation is the underlying layer of data architecture that supports the data management and integration needs of an organization. This layer often includes the technologies, tools, and processes that are responsible for data acquisition, ingestion, storage, cataloging, and governance. The data foundation also provides the foundation for data analytics, reporting, and decision-making by providing a reliable, consistent, and high-quality data source. I'd love to call out the aspects of data acquisition, ingestion, storage, and governance, as well as use cases of analytics, reporting, and decision-making, ultimately leading to reliable, consistent, and high-quality data. These are some of the very core tenets that we'll rely upon for the rest of the presentation. Next up, we'll dig into a few representative personas in the data space. We'll cover 4 primary data personas in scope for today. These are meant to be representative, but certainly not an exhaustive list. Starting off with the data producer. So starting off with the data producer, this is typically owned by software engineering in partnership with downstream teams to collect requirements on logging and instrumentation. SWEs are then responsible for creating applications that produce data that land in transactional tables. Next up, we have the data engineer. These are folks that are responsible for the design, construction, and maintenance of the core systems and infrastructure that collect, store, and process data. Down the line, we have a data analyst who is responsible for analyzing and interpreting data to generate insights and support decision-making. Last but not least, we have the data scientist, responsible for using statistical and machine learning techniques to analyze and interpret data, as well as make predictions. So, in summary, all of these personas make up the data ecosystem, and everyone benefits from a really well-structured data architecture. Let's cover that next. All right, so to set up data architecture from the ground up, we'll start with our skeletal structure here. Notice the various stages of the data lifecycle outlined from left to right, as well as the 2 horizontals on the top and bottom. Going from left to right, we typically start off with our data sources. There's an ingestion process, which leads to the raw data layer, and it will start doing some transformations in data wrangling and processing, which leads us to a staging layer, data layer, followed by core data, and yet again, aggregates and final output. So now let's take the time to dive into each of these components and fill out the blanks, starting with data sources. Data sources represent our input, also known as our starting point. They may consist of any of the following. It could be a company's internal application, various forms of event logs and event collectors, third-party applications, as well as APIs, application databases, which may live in MySQL, Postgres, etc., file storage itself, as well as free data sources that are available on the interweb. Ultimately, we may leverage a single or multiple data sources at any given point in time. Once we've identified the data sources that we're interested in, the next step is to do data ingestion. So moving from left to right in the diagram, the ingestion step consists of processing and loading our data sources into the raw data layer. There are 2 main types of ingestion. Batch processing is where data is loaded either in hourly or daily increments. And stream processing, on the other hand, is where data is loaded in either in real time or near real time based on event loggers. I am getting a lot of feedback on this. Oh, all good. That must have been you, Ben. Then on the stream processing, so some of the common messaging brokers in this space include Apache Kafka, Google Cloud Platforms, PubSub, as well as AWS and Amazon's Kinesis. So with the ingestion layer buttoned up, next up, we'll cover the raw data layer for data storage. The raw data layer is a landing zone for data storage of ingested sources. So raw data typically lives somewhere in cloud storage on AWS's S3 buckets or GCP's Google Cloud Storage. It's also possible for raw data to land directly into a data lake or data warehouse, such as Snowflake, Redshift, or BigQuery, depending on the design of the data system. There's an additional step of processing data in the raw layer. Pseudonymization is a data management and de-identification procedure to really strip away PII fields within a data record and replace them with artificial identifiers or pseudonyms. If this is a necessary process in a company's data flow, this is generally a good place to perform that process in order to open up data access to a wider employee population downstream. After data is landed in the raw layer, it's time to perform some initial processing. Let's move on to the staging layer. So once again, moving from left to right in the diagram, the staging data layer is where initial data processing and transformations occur. A few common data processing and transformation operations include, but are not limited to, renaming variables. Variables do not always have the most intuitive nomenclature being generated at the source. This is a great opportunity to fix that. Next up, standardizing data types. There's numerical, categorical, text fields. They should all be treated differently and not the same. So great opportunity at this point in time to align on the specific types of data here. Next up, we have performing data quality checks on the data that we ingested in the raw layer. This is a really important step to prevent bad data from landing in our data warehouses. It also saves on storage costs to not proliferate the same bad data further downstream. During this step, it's also a great opportunity to remove duplicates. Who wants duplicate values in their data? Waste of storage and does not result in a single source of truth. Also, a great opportunity to get rid of test records. We obviously want test data being generated during product testing and through other cycles. But at this point in time, test data should be stripped away from landing into the production data warehouse to avoid confusion and noise. Last but not least, consider unifying various identification fields. This is a great opportunity to structure your table fields, identify primary keys, so that way all of the processing that goes downstream can carry that forward. At the conclusion of the staging step, we should feel reasonably confident in our data as it's made a first pass through a rigorous set of validations. Let's move on to the core data layer, where impact gets shipped. The core data layer is where most of the magic happens. In building upon a series of staging tables, core datasets are designed to be general purpose and solve for a wide variety of downstream use cases. A few of the common operations at this stage include creating dimension and fact tables. Instituting data models that are modular and scale are hyper important as data needs evolve over time. Again, performing data quality checks. This is another critical step to ensure that data that lands in core tables are properly vetted and have passed all the necessary checks. Writing comprehensive documentation. We really want documentation to exist at both the table and column level for end users to grok, depending on their specific use cases. This is a good opportunity in the core layer to introduce or add in slowly changing dimensions. This is a place where we could introduce SCD type 2 for applicable datasets to really save on storage and processing. Next up, we have implementing privacy and security rules. So not necessarily everyone's fan favorite, but very much an important and necessary step as part of data governance. Similarly, on the data retention policies, with complex rules in this world enacted by GDPR, CCPA, as well as other institutions, row-level data oftentimes cannot be retained forever. Last but not least, we want to set up anomaly detection and alerting. Extending upon data quality validations, proactively setting up anomaly detection thresholds and alerting can really mitigate disasters early on. Next up, let's cover the features of core data. So I'd love to introduce the 5 tenets of core data. Given that core data fosters trust between data engineering teams and data consumers, these datasets often directly or indirectly power a wide variety of use cases, including analytics, dashboards, machine learning models, as well as experimentation. Additionally, it's often a direct input to generate company KPIs and top-line metrics. So the first core tenet is single source of truth. Core tables are designed to be the one-stop shop for end users to consume data. There should not be multiple copies of the same data. If there is, that's technical debt which needs to get rectified. The second tenet is all about guaranteed data quality. Data quality must be a given on core data. Data that does not pass the high bar for quality checks should never land in production. Third up, we have high discoverability. We want clearly identifiable core tables via nomenclature, such as a core dot preceding a table name in terms of the namespace or dataset, as well as making it highly accessible to all audiences. Core tables democratize data access to all employees. Continuous availability. Who wants a table that's only available part of the time? So core tables should be available to query basically literally 24/7 with strict guidelines around refresh cycle SLAs for when the latest partition of data should land. Typically, data should generally be available by the start of business every given morning. Last but not least, comprehensive documentation. Ensuring that we have crystal clear documentation enables self-service, including detailed table summaries, as well as column descriptions for end users to leverage. Additionally, commonly used sample queries can be provided to get folks a head start. Ultimately, to recap, it's really critical to build trust between data engineering teams as well as data consumers. Now, with that said, let's move on to the aggregate data layer. The aggregate data layer builds upon core data to generate summarized and aggregate data for downstream use cases. Some common outputs of this layer include analytical tables, which can be really wide, denormalized, and pre-joined entities, which ultimately yield high traffic and are designed for a variety of audiences. Additionally, we have use case specific tables, which can just be aggregated data sets themselves. An example would be like if you're building a lookml file to load into a Looker dashboard or a Looker Explorer, this is often a good starting point. Next, we'll head on over to our last vertical, the output layer where insights are generated. The output layer represents all the hard work put into data wrangling, transformations, and processing. Reaping the fruits of this labor, we enable downstream data science and analytics teams to self-service on core and aggregate data. Some of the common use cases in this department include dashboards, visualizations, as well as reports, which can constitute of company KPIs, as well as top-line metrics. Analyses and analytical notebooks. Who can ever have enough of these? Machine learning models, and last but not least, A/B tests and running experiments. So this represents the final step in the data lifecycle. Next up are 2 horizontal layers to round out our diagram. The first of which is the orchestration and transformation horizontal. This sits across multiple stages of the data lifecycle and is a critical engine that processes data. That engine typically is broken down into 2 steps. An orchestration tool of choice, which, at this day and age, most folks know what Airflow is. There's also some new kids on the block with Dagster and Prefect gaining a lot of steam as of recent months. There's also always the option of running a custom-based solution for orchestration. On the flip side, in terms of transformation tools, likewise, DPD's made a household name at this point in time. There's also options, perhaps less favorable, to run ad hoc queries or to design a custom solution, depending on the needs of the business. Moving over to our second horizontal, this one's all about data governance. So data governance really serves as an evergreen horizontal, that impacts all stages of the data lifecycle. Fundamentally, it's a shared responsibility amongst multiple functions within a data organization. Data governance consists of, but is never limited to, privacy and security, legal and compliance, data observability and discovery, and last but not least, data quality, which we've hinted at earlier. The full extent of data governance is very much out of scope for this discussion, as each of these topics can warrant a lengthy discussion on their own. Now, let's put it all together. As the parent of a young child, my 4-year-old daughter would say, "Daddy, look, we've colored all the boxes." And that is exactly correct. So this is a little bit of an eye chart, but potential owners are color-coded accordingly in this diagram. There is not a one-size-fits-all solution for all organizations and entities and companies, but this should generally be representative of how many companies do operate. Without further ado, I'm happy to answer any and all questions about this topic or data engineering in general. Let's move over to Q&A.
Thank you so much, Chen. That was great. That was great. I take it you're having to deal with plenty of data science workflows at this point. You're trying to balance how you guys create those data sets.
It's always a balance.
Yeah. Because I feel like when you worked at LinkedIn, you were more on the data science research side, right?
That's right. More on the product analytics and data science side. So I'd say less on the back end and more, creating vizzes, dashboards, and generating insights.
Yeah. Why the switch?
Great question. I gotta say the back end is so interesting, right? Once you start writing so much SQL, you see all the common patterns, and you're just like, what is behind the seam here that I don't get to do? And so I started gravitating more towards that piece, and lo and behold, flipping over to Facebook, was able to start directly into data engineering.
Yeah, that makes sense. It's just interesting how many people end up coming back to data engineering, especially from the data science side. So, like back at LinkedIn, what tools do you feel like you were using back then? I don't know how long it was, however many years it was.
Oh, it was a decade ago. So this is not going to be the best of my ability to recall all of that. Cloud data warehouses were so new. I think we were on Teradata
Okay.
at one point. So that was probably a good starting point. I do remember all the glory days of Tableau, putting together colorful visualizations that tell great stories. But that was probably the fundamental stack that we had. Again, probably spending about 80% plus of my time in some type of a SQL environment. Sans, building relationship with stakeholders and business partners, which is always critical. But really, that was kind of the recipe there.
Yeah, that's you say Tableau like it's ancient, but it's still arguably. I'm not going to say it's the most popular, but it's had staying power. Is what I usually. It's like, yeah, somehow made in 2023, 20 years ago. Like everything else, it was like some sort of, I think, research project. And we're still using it today. We'll see now that apparently Salesforce wants to blow it up, and they want to just somehow inject it straight into Salesforce, and that's the only way we're going to be able to use it or something. But big companies be big companies.
I was not alluding to the end of Tableau. That I do not see a future where that exists just yet, or nowhere near that. It was just a call out more in terms of, to your point, the usage curve of Tableau perhaps has either steadied and or given up some of that market share to other players in this space. Looker being a pretty popular choice.
Yeah. Oh, I don't think we cover this. Do you have any tools for quality or discovery, like data catalogs or?
Yeah, great question. So we're actively leveraging Data Hub for discovery.
Yeah.
A LinkedIn product, but sadly it was a product that was created after my time there.
Yeah.
So we are very much actively leveraging that platform. Seems to have do good in terms of the integrations, playing together with the rest of the modern data stack that we are leveraging.
Yeah. And then catalog, do you have catalog. Quality, do you have a quality solution?
So for quality, assuming this is data quality, we're leveraging dbt test. So we're on the modern data stack, leveraging dbt for transformations, and so very much kind of neck and neck. We're leveraging dbt test. Really run through from the point of ingestion onward within our warehouse.
Yeah. Maybe at some point you'll need something more, but I guess probably for now it's probably sufficient. I think this is a good question because there's always this question about, okay, what's right for whatever size you are. So, what would you suggest for a small company in terms of if they're just getting started on this whole journey? Where should they start? What should they color first?
It's a fabulous question. Honestly, I'd see it as really just two ends of the spectrum, right? So there's obviously the piece of understanding what the fundamental business requirements are and working our way backwards from those in terms of figuring out what data infrastructure and data architecture to set up. With a small company, there isn't so much luxury around budget and headcount and all of that. So things are never going to be picture perfect. So I'd say 80-20 thinking, coming up with first principles design around what a fundamental data model could look like, and then building for efficiencies of scale as data tends to grow, teams tend to grow. The best case scenario is to not have to redo that exercise over the span of a couple months or years, and to be able to build on top of things in a very modular and scalable fashion.
Yeah. No, I think it's iterative to some degree, and modular. It's like modular to some degree, iterative in some degree. It's like you just kind of have to pick the pieces you think are most important and build as time goes on. I have an article somewhere where I said, you know what? For some people, Excel is your data stack. Well, you are a 4-person company. Well, welcome to your what's probably the most maintainable, going forward. So it just depends on what you have and what you need. Like maybe you need more, maybe you don't, but you have to just kind of see what you have. Let's see. In your experience, what has been the most challenging aspect of building a solid data foundation?
Yeah, it's a great question. So it's also a very generic question. So in terms of various challenges, I would bucket them into different departments. Or different buckets, I would say. So there's obviously the stakeholder management piece, right? As you're taking time to build up a data foundation that's right, oftentimes, you might already have a data stack that's already in production. So how do you manage something how do you deliver on the promise of, tomorrow you're going to get the next greatest thing, but you have to be content with what you have today. So there's the piece of, incremental gains for what that looks like. And then there's a piece of, moving from 0 to 1. If you do have the rare opportunity of, kind of throwing away tech debt and being able to start from scratch of what a data model or data architecture design looks like, thinking together through what first principles for that org or business line or company are doing. And it's working backwards from the specific goals that you're trying to solve. Are you designing around company KPIs and the specific set of metrics that are basically not going to change? Or are things dynamic enough that, this is a data model and architecture that we need to revisit in 3 months or 6 months or 12 months? And that very much changes the scope for how you kind of put together these types of architectures.
Yeah, no, I think that's a great way of putting it. So I had this thought, but since they've asked, do you feel like DBT tests are enough? And they followed up with, compared to maybe like Soda SQL or Great Expectations, which I think are both open source, so they're technically free. You can pay for the paid option, but just curious if you looked into those.
Yeah, great question. So we have evaluated Great Expectations, and it is we don't have a clear, definitive answer in terms of whether that's a direction we're going or not yet. But clearly, it is an available open source package that we are well aware of and will piggyback on should the needs arise. Again, we've relatively recently moved over to the DBT stack, and so we are in an incubation phase of getting things up and running. So there's the classic adage of you don't know what's around the corner until you turn that corner. And so we're in a little bit of that state, but very much Great Expectations is a possibility. There's also just additional add-ons and bundles in this space that are very convenient to stick on. So kind of hence the modular comment from earlier, things such as elementary data, for example, as another platform that we could have robust end-to-end DQ evaluation.
Yeah. That makes sense. Yeah, I do remember. I think when we had, you came to the happy hour too at SF, but like the dinner, I think we did. You referenced switching over to DBT. So if you've already migrated, that was actually pretty fast.
That was only a couple months ago. So yes, we're on that journey.
That's must have been fun. Any takes? Lakehouse versus traditional warehouse? Do you got any takes there?
Yeah, good question. Personally speaking, I'd love to see this space mature a little bit. There's obviously a lot of players, and I'd say we don't have a clear direction in terms of what's going to stick around for the next even year or 5 or 10. Traditional data warehouses, as dinosaur as they may be, have proven, to deliver on business impact and value. Lake houses are obviously a much newer concept. And so I'm not in one camp or the other in terms of preferring a specific technological solution. It ultimately comes down to, I think, what types of business problems are we faced with? What's the capacity, volume of data that we're dealing with to really make those decisions? And things like, do we need real time, near real time, or are we satisfied with batch?
Yeah. Are you guys satisfied pretty much with batch at this point for a lot of your work?
Well, we do have both. So we have a batch and stream ingest process, pretty heavily relied upon on GCP. So being able to leverage PubSub in the event broker system there, bringing those pieces in. And so ultimately our data models, as you can imagine, are kind of a Frankenstein approach across some production snapshots on a daily basis versus other things that come in via event loggers, which are much more frequent than daily.
Yeah. Do you report on them in real time or near real time, or do you just store them in real time?
It's more of the latter at this point in time.
Okay.
Again, until we hit the crucial point for a business need on the former, that's very much an avenue which we'll explore.
Yeah, I mean that's probably the right answer, right? Like you don't want to be like, let's go invest all this time in trying to figure out real time. When it's like, well, technically though, our stakeholder only looks at this report, whatever, once a week.
There's plenty of other problems to solve.
Exactly. There are far more important problems to solve. Any thoughts on MLOps? Do you have any favorite tools for helping bring your DS and DE teams together?
This is a little bit early for us, at least on the Discord journey. So not going to be the best person to be able to comment on this front as of today. In terms of experimentation as well as machine learning as a whole, very much areas that we are invested in, but an area that we're just starting to hit the tip of the iceberg.
Yeah, no, there's a lot to do. I only poked at you about this yesterday. Do you see a lot of work with your new public acquisition of gas, a lot of data stitching together?
We're bringing on a couple additional team members. What can I say? From a percentage basis, it's not a large, sizable component of the employee population, but very critical in terms of what it means in terms of growth prospects in what we do. I think a little bit too early to speculate on what it all means in terms of roadmaps and focus areas, but really excited nonetheless to have additional viewpoints and a vision to work towards with the founders and the leaders from Gas.
Yeah. No, I saw that yesterday, and I remember I posted it to you, and I was like, "This sounds like a lot of work."
You caught that one within an hour when it released.
Yeah, I just happened to see it come across Twitter. I was like, "This sounds like too much work. This sounds like this is why data work is never done, because companies buy other companies or split off from other companies, and then you have to piece together and pull apart systems all the time.
And less an iterative cycle.
Yeah. Yes. All right. What best practices do you feel is the most difficult to implement or get buy-in from leadership? Any good tips in avoiding data swamps?
Sure. Great question. Let's see. So I guess two parts to the question. The best practice to most difficult to implement or get buy-in from others. It kind of depends, honestly. I think depending on how an organization is structured, for example, one organization might have a really big challenge with manifesting clean and clear data quality, like being able to sell the notion of what that actually means and investing the time and resources to fix that. On the other side, people might get that as a problem, but they may or may not understand the specific use cases for downstream processing. So once you've got your kind of core tables, is that enough, or do we still want to expend data engineering resources on creating those meticulous aggregates and the very specific details that can power P0 dashboards for KPIs and whatnot. On the second question of tips to avoid creating a data swamp, honestly, especially if you're in the middle of a project or you're inheriting some kind of a data warehouse or data process, the best thing is to really nip it at the bud if it's at all possible. Oftentimes it's not going to be. And so my suggestion from that point onward is to avoid creating future technical debt. There's a piece where you can continue building on something that's already flimsy and perhaps broken and call it a day, or you can take the time to, compartmentalize that. And at least the piece that I'm building as of today, we know that this is going to work, and perhaps I can carry it over, lift and shift to a new source system whenever I have an opportunity to do that. So it's really about just holding up the stop sign, realizing where you're at right now, and to really stop creating net new technical debt to the extent possible.
Yeah, I imagine that's a fight. Like I don't remember. Do your data scientists also create their own DBT models? Do they kind of create their own data pipelines? Do you have to kind of fight that at all? Not to say that they can't, but sometimes there's a little more chaos when it's just like, let's just put this in production kind of approach.
Chaos is a great structured word. The historical piece here is, data engineering actually arrived relatively late at this company. And so prior context is we did have SWEs and a combination of SWEs and DS sticking together a lot of core data sets, data pipelines, as well as tables. So with that said, it did enable a lot of the foundational business to be run, but perhaps with an asterisk around what was modular, scalable, and reproducible over time. So it's the age-old adage of who should own what type of specific piece of the data stack. And I do strongly believe that data engineering has a really firm grip and a unique skill set to kind of own all of the pieces from ingestion and raw data all the way to the point of end user facing products that generate insights.
Yeah, you should write an article about that so I could stop quoting or referencing the Airbnb article that says the exact same thing, where it's like, we used to let SWEs and data scientists used to take care of all the data pipelines. No one wanted to own said data pipelines. So, they all kind of would just eventually kind of die or get old. And so we hired data engineers and we started putting in better practices. So it's interesting how many companies are just like, you think like, oh, they're a big tech company, they must be doing this. And it's like, actually Airbnb 2018 apparently was very slowly getting there. They did, but it took them time too. So yeah, it's interesting.
Great plug. I may just take you up on that offer, Ben.
I mean, it's the modern world. ChatGPT can only write what has been written. So, if you've got specific context that it doesn't have, yeah, it's a little bit of a content moat, so to speak. And have you been writing anything on the Discord, like engineering? Is there a Discord engineering blog?
There is a Discord blog. Haven't been hyperactive on that front. That said, we've got a foundational data engineering unit here, and more than happy to start contributing on that front.
Yeah. And are you guys hiring currently?
We absolutely are. So I guess thanks for the shameless plug, Ben. But if any of this stuff resonated with any of the audience members, we very much are hiring. So please feel free to venture over to our career site.
Yeah. So I mean, I just might as well. You're here. You're talking. Someone out there probably is interested in doing what you're talking about, and I'm sure would love to kind of help implement some stuff. And it sounds like, again, your team is about to take on at least a new kind of integration project with gas. So like you said, you're going to need some people to help with that, and it'll probably be fun and a great thing for someone to put on their resume and be like, I helped integrate whatever gas's data is, unless they happen to pull a Frank. I don't think they pulled a Frank on you, but yeah.
We don't know what we don't know, so we'll figure that out.
Yeah, if they have 1,004,785 users or whatever it is, just double check. You do know what I'm referencing, right? Like, I'm not crazy.
You're in the ballpark, I would say.
Yeah. No. I meant like the article, not the article, the whole thing with JP Morgan.
Yeah.
Okay, cool. Yes. Cool. Let's see. There's one more question here. I feel like this is probably Data Hub, right? Is that how you handle data documentation, I assume?
Yeah, Data Hub's a great, kind of tool itself in and of itself, but there's obviously processes around this, right? So this is like ensuring we go from 0 to 1 when we're launching core tables, of having proper documentation both at a column level as well as a descriptor for the table in terms of what it's actually meant to do. Even basic stuff like, what is the granularity of this table? Is it a user table? Is it a user combined with another secondary field? Sometimes it's obvious to us as data engineers, but may or may not be as obvious to downstream consumers. So I very much err on the side of over communication, even in the lens of documentation.
Yeah, no, what was I thinking? Data Hub. So when I've been doing this whole, again, data infrastructure analysis, what people are using, There's not a lot of people using data catalogs, but I think Data Hub might be one of the more used ones. But it's a massively underrepresented market in terms of like there's so much market share to gain for everyone. And then, actually, like what do you feel like are the benefits that you get from using Data Hub or just any data catalog?
I mean, centralization, if anything, right? You've got one place to look. Honestly, I've been spoiled by having great internal tools in my past life at companies like Facebook, where there's basically internal versions of all of the aforementioned technologies that we've covered here, and documentation being one of them. So being spoiled on that side, I think just having the nature of being able to cultivate everything into a single surface, and then having that single surface ideally integrate with the rest of your tooling technologies is a game changer. That said, Data Hub is still very much growing and getting better day by day, and so I'm excited about what their roadmap looks like and how we can benefit from further features and releases.
Yeah, nope, that makes sense. Yeah, it's just again interesting space, often neglected. I loved the data catalog at Facebook, so and it like made my job easier. I could just look up things and then go look for an owner and then wonder why that owner's like, oh, I haven't managed this thing for 8 months. So
asking the hard questions.
Yes. Apparently you have neglected someone. Someone applied and never got it. No, I'm kidding. It's what it is. Where do you store?
I mean, on that note, I do want to address that. Our DE internship piece is very new. That job posting actually I think went up within the span of a week or so ago.
Okay.
So that is for the incoming summer of 2023.
Oh, fun.
In full transparency, we haven't really reviewed any of those pieces yet, just given how new that is. But very much on the docket of the long list of to-dos.
Long list. Oh, to be the manager, director, head, have to do too much stuff. Where do you kind of store, I mean, more specifically, where do you store your kind of staging core? Like, I don't remember if you covered exactly where Discord kind of does it. You said GCP. So yeah.
Happy to cover this one. I mean, this is obviously, it could be a nuanced answer depending on the specific needs of an org. For us, we do actually heavily rely on GCP as a platform, and specifically BigQuery. So in a way, we are treating BigQuery both as a lake as well as a warehouse. And so anything from the point of ingestion, which is raw data, to staging, core, aggregate, and beyond, all of those pieces do reside kind of neatly and uniquely within BigQuery for us.
Nice. Okay, nice. That makes sense. Cool. I think that hits most of the questions that we have. Any questions from you, Chen, for me on anything?
No, it's just been a pleasure having this opportunity. I really appreciate it. I know this is like an absolute marathon affair for you, Ben. I do not know how you're pulling through this without a proper lunch hour or even like bio break time. But yeah.
That's why I keep like shutting off my camera. Actually, so it's funny. So after the first talk, Mehdi, he like made that comment, and then like 20 minutes later, someone from Mother Duck like messaged me, is like, here's a $50 gift card, go eat something. So thank you, Mother Duck. I definitely got some food from Grubhub and have eaten like an entire Qdoba burrito. So I have eaten, despite it looking like I haven't. I did manage to go get some food. So it is. I do look forward to laying down though, because last night I also did a dinner, which was like a 3-4 hour thing with a few different vendors and data leaders, and I'm ready to lay down.
I concur. Well, got I think a couple more legs on this marathon.
Couple more,
but we'll pull through here, and I'll see you on the other side.
All right, see you on the other side. Thanks so much, Chen.
Awesome. Thanks, Ben. Thanks for having me.
Bye. All right, so we're gonna wait a few more minutes. Chad Sanderson, one of the the data influencer on data contracts, will be here shortly. After him will be Ananth. Honestly, another person in the data contracting space. I accidentally said 5:45 for that last talk. It's going to be 5 p.m. Mountain Time. So there's going to be Chad and then Ananth, and then we're done. That will be all of the talks for today. I'm really looking forward to these last two. We can start talking about data contracts, and then after that, functional data engineering. I really kind of tried to keep it like kind of practical, maybe more of like a product, kind of practical, kind of a product kind of talk, because I think both have their merits and their value. So I'm really excited to kind of do these last few. Thank you all for who's been here. It's been really, really fun, honestly. I want to do this again, hopefully in the next, 8 to 9 months or maybe 12 months or something, and just keep trying to put these on. And we'll keep kind of figuring out how to do it and how to make them more impactful. So, if you have any comments in terms of like how you feel like this could be run better, feel free to either, send them here in the chat or, ping me. You can find me on LinkedIn. I hopefully will not have my LinkedIn DMs as completely flooded as usual. If I don't ask for people to comment and then I have to respond to them constantly. It is the one downside of doing the whole LinkedIn asking for comments. It's great. It gets tons of traction. I get tons of people who are interested in an event, but then I have to go email and message and DM all of you one-on-one. But the problem is if I just post the Eventbrite link or something, no one sees it. So it's just this one or the other situation. But thanks for all being here. And anyone who came from LinkedIn, thank you. The other thing I've learned is that LinkedIn only has a 4-hour limit. So I'll figure out if next time I do it on LinkedIn as well. It's kind of a bummer that they only have a 4-hour LinkedIn streaming limit, and then it just dies. That's why if you were on LinkedIn, it just died exactly at pretty much 4 hours and 45 seconds. I kind of get it to some degree. I think people like YouTube actually offers a really big service in free, like storing your data for free, essentially storing gigabytes and gigabytes of video data. I'm still waiting for Chad. I'll probably be here in the next minute or so. Let me just double check. It's not supposed to be here till 4:15, but let's check. And there he is. All right, I'll bring him up here and then we can kind of get started. Hey, Chad, how's it going?
Hey, how's it going, Ben?
It's going great, going great. You
Thanks,
enjoying Seattle weather right now?
No.
No? I heard it was kind of sunny over there.
It has been recently, but today it's been a little overcast. Yeah.
Well, yeah. We have like 8 inches of snow outside, so it's
yeah,
kind of nice because I've been inside. So
nice. How's the conference been going?
It's been going great. It's been lots of good questions, lots of good talks. Yeah, no, I'm kind of excited to keep kind of going and hear where you're going to be talking about.
Awesome.
Yeah,
let's do it.
Let's do it. Awesome. Let's add. All right. Just double checking. Are you adding in the slides?
Yeah, I can. You want me to do that now? Just start doing the screen share.
Yeah, screen share, whichever you prefer. Yeah, you can do screen share actually, so it's just you. Yeah.
Yeah.
Do it.
Okay. Let me share my screen. Share screen. Can you see?
Now we can. Yep.
Okay.
Awesome.
Should I just go whenever?
Yeah. Oh yeah. Just feel free to give an intro to yourself. Sorry. Okay. Maybe I'm assuming everyone knows who you are, Chad, and so I'm like, Chad doesn't even get an intro. Actually, I didn't know you were a 2-time Olympian until I think like the last talk or something. I was like, what?
Yeah. Well, hey everyone. I hope you folks are doing great. Can you see those Slack things? Hold on one second. I'm just gonna.
I do not see any Slack thing.
Oh, you don't see any Slack things? Okay, that's great.
It's like, oh no, super private information. No.
Yeah.
All we see is Chad Sanderson.
Okay, perfect. Okay, well, I hope everybody is doing great and enjoying the conference. A little bit about me. My name is Chad Sanderson. I have worked in data for the last just over the last decade or so, and I've worked at a bunch of companies, from late stage startups. There's a company called Convoy. It's a freight technology company. I ran their data platform team. I worked on the artificial intelligence platform team over at Microsoft, which is like the internal sort of big data arm of Microsoft. It supports the sort of real-time computation for the biggest internal businesses at the company. So this would be like Bing and Azure and Office and Xbox and these other types of things. Before I was ever in data, I lived a very, very different life. I was a junior Olympian in Taekwondo, and I did a variety of other things. Like I worked on a reality TV show and did some creative writing. It's, whoops. Looks like we... Okay, so today we are going to be talking about data contracts. But before we jump into that, because there is a lot to cover, I want to talk a little bit about why we, how do we use data at businesses, and potentially how should that change so that data engineering teams and data teams in general can get more value out of the data that they collect. So at Convoy and other places that I've worked, data is usually seen as the core to what I call like the decision infrastructure. Really anything that you're making a decision on, or any tooling that you're using to make a decision, of course, it's fundamentally based on data. And this is especially true at more mature tech companies. And that means that the infrastructure that we need to support those decisions needs to elevate with the times. If our data is being treated as a product, if we're producing a machine learning model, or the data is being used in a production application, then we need to think about the entire pipeline as in the same way that software engineers think about supporting their production services. So what are we talking about today? How is data commonly used? I'm sure you've probably heard a lot about the modern data stack already today, so I'm going to cover it again very briefly, but from a slightly different angle, which is more like, where does the modern data stack as it's implemented typically fail? Like, where does it fall over? What are the sort of challenges that this world of modern data stacks create within the data engineering organizations? And then how do we think about solutions for these problems through data contracts as a vehicle of implementing data quality incrementally at scale? So like I said, lots to cover. So let's just dive in here. So first of all, I'm sure everyone knows this, but I just want to set the stage a little bit. When we're talking about how data is used at any relatively mature company, there's machine learning. Your business may or may not be doing machine learning, depending on how advanced it is. Experimentation is really common. So this is like A/B testing, trying out different versions of the product, and then defining metrics and trying to understand if those metrics moved significantly for one version of the product versus another version of the product. Of course, you have automation that can be built on top of core data assets, what we're all used to, BI and analytics, and then tracking OKRs and weekly business reviews and sort of executive reports and things like that. So the data platform team, and this is the team that I used to work on at Convoy, but the way that we thought about our role was essentially supporting all of these functions that I just described in the cheapest way possible, with the highest level of trustworthiness in the data, that sort of maximized innovation velocity, so that teams are making the largest amount of decisions as quickly as they possibly could. So this is where I spent a lot of my time thinking, and this is ultimately what this train of thought is what led us to data contracts. So this is just a high-level view of some of the stack that I worked on during my time at Convoy. I sort of broke this down into like data sources and ETL transformation, tools for discovering data assets, tools for deploying new things. So that could be deploying features, deploying models, experiments, and then tools for doing analysis. So this is really what a relatively comprehensive stack looks like from soup to nuts, and it very much fits into the modern data stack framework. But there are some challenges with the modern data stack that we, and I mean I specifically, started to feel as we grew. One of those problems was it's primarily designed to move fast, right? You get started quickly. Some executive wants you to answer a question about their core business, right? Like how many customers churned in the last 30 days. We don't have any data infrastructure set up. So we turn to open source software. We turn to tools like dbt and Airflow or cheap sort of automated ETL systems like Fivetran. And then the goal is to just push as much of this as quickly as we can into a central environment, transform it to answer that question. So this is what Convoy did. We were a very early adopter of this stack. We've been using it for the last several years. And it's the stack has evolved to the point where there's a lot of pros and cons I think I'm qualified to talk about. So the great part of the modern data stack is that it's very self-service, easy to learn, not particularly hard to implement. Most of these open source tools are awesome, super fast to stand up. It's not that expensive in the beginning, right? When you're running your initial pipelines, it's very cheap. And then the teams, based on all of the above, can move quickly. The bad part is that because we never really establish a scalable governance system, a lot of times the producers that are generating or they own the data sources from a transactional capacity don't really own the data quality for the analytics and other use cases of data. And that's a bad thing. And that manifests into a lot of problems later. Oftentimes the ELT, and if we're running like a change data capture system, we're exposing the internals of our databases. So we might have a Postgres table and we're just dumping all of that into Snowflake or Databricks or Redshift or what have you. And that's not a good thing because that data was never intended to be seen by anyone from the data team 99% of the time. You also lack a lot of that good centralized modeling. So there's not a lot of great context on the data. You don't really have good understandings of the semantics, like what does this data actually mean? And if you do, it isn't a particularly scalable system. So like maybe one team understands it because they looked into it for like 3 weeks, but every other team in the company doesn't. And you see the data model, because of this, start to evolve in these little silos. Like I said, some teams will have a relatively robust data model that they build out for their very particular entities, and some will have very little data model at all. And all of this makes governance really, really challenging to implement at scale. It becomes very costly. It's hard to wrangle teams together. It's hard to get anybody on the same page about what data is actually important and what's not. So where I felt the company needed to go was to, number one, establish that collaboration between the producers of the data and the consumers of the data, and start treating the data as part of the product. And that collaboration, the bridge, was a contract. So like a handshake agreement on what is this data, where is it coming from, what is the shape that it needs to be in, and how should that definition be enforced. We also needed to know, we needed to define very clear semantics that were inherited throughout the pipeline, that the consumers were taking an active role in the design of the data, like very clearly expressing what data they needed, what should this data represent, and if it changed, who is it going to impact. The producers needed to take ownership over the data quality at the very least from the producer side, right? It doesn't mean they need to implement monitors throughout the entire pipeline, but they do need to think about, from the production side, from the database side, what is the data going in or out, and does it adhere to some level of quality? Minimal duplication, clear ownership, yada, yada, yada. So this sounds like a utopian vision, but our goal was to figure out how we get here in the most efficient, inexpensive way possible. There's sort of 4 key points that we wanted to keep in mind as we were thinking about how to solve these problems. Number one, we really needed to make the life of the data developer easy by having clear definitions of all the core data concepts, great documentation, very clear ownership. And then number 4, and probably the most important, we're treating data as part of the product, not as digital exhaust. It's not a byproduct. So this is something I posted on LinkedIn. It's kind of a tongue-in-cheek, but it's a quick description of what I think a week in the life of a data developer is. And I'm not going to go through all of it, but the general gist is there's a lot of steps just to get to something as simple as, hey, how many customers do we have doing X or doing Y? It's not a straightforward process. It can take days, it can take weeks, depending on how responsive other people in the organization are. And this is like fundamentally not a very good thing. So, okay, so now that we've talked about some high level architectural things, let's spend a little bit more time focusing on implementation and why our implementation was not ideal. So number one, this is a relatively common setup, I find at a lot of companies, where they're collecting some event data through a tool like Mixpanel or Amplitude or Snowplow, oftentimes through some front-end tracking. Convoy had this. We were using Mixpanel. We push that data out to the cloud. They have like a SaaS service. And then we were extracting that data from this SaaS platform through Fivetran and then dumping it all into our data platform, which was Snowflake. We could have done this for some of our backends tracking as well, but we weren't. There's some complexities there that I'm not going to get into, but just it wasn't as straightforward as you think. But we were extracting data from our production databases. In our case, we were using Postgres. We were, again, pulling that through Fivetran and dumping it. Now, there's no real centralized modeling here. What arrives in Snowflake is just a bunch of stuff. It's like a lot of JSON. It's a lot of crazy stuff. It's not particularly, like, no one really knows exactly what it is. Our initial data engineering team tried to build a core layer of data assets at first, but this very quickly became unscalable. So we said, hey, data analysts and BI engineers, you guys are free to use a BI layer to spin up whatever data models that you want, leveraging dbt. But that also got out of control for reasons that you might be able to predict, right? No centralized governance means people are just going to do whatever the heck they want. So oftentimes, this is a pretty. Actually, Mehdi, I know he presented earlier in the day. He put together this image, and I think it demonstrates the problem very, very, very clearly. Is you have these operational use cases that are supported by the databases. The software engineers that are maintaining these databases aren't like thinking at all about analytics or machine learning. It's like there might be some data, and that data is supporting, displaying your name and face and age in the Facebook profile. But we also need this data to build out a recommendation system. It's just that the software engineers aren't actually aware of that. And so in order to get around that, we've implemented tools like Fivetran, which I call non-consensual APIs, to pull out the data without an engineering team in the loop, store that somewhere, transform it, manipulate it into some data warehouse-like shape, and then do all our analytics downstream. But of course, this is a garbage in, garbage out problem. If the data coming from those operational use cases changes in an unexpected way, if it doesn't mean what we think it means, then it essentially causes the whole pipeline to be filled with CRUD. And this was happening in Convoy on a regular basis. So the pain that we had, which is something I feel a lot of folks felt, is that the producers didn't really take accountability for data quality, not because they're bad people, but because no one ever really asked them to or explained to them exactly what this data was and how it was being used, nor did they have a mechanism to do it. They weren't even aware how the data was used in most cases. Like I said, we were using Snowflake, and the data was just kind of getting thrown over the fence into a black box that none of the software engineering team understood at all. It wasn't clear what the data meant semantically. There was no real source of truth, et cetera, et cetera. And this ended up just, costing everyone an enormous amount of time. And this is kind of what things look like for us, right? Like we had all these tools. We had tools for transformation. We had tools for orchestration. We had an awesome visualization tool. We had ETL, and the data itself was a garbage dump, right? It was on fire. And if the data itself is bad and is low quality, then all the other infrastructure that you build around it is ultimately going to fall over. And this is the core problem that we were trying to solve. Okay, so let's very briefly talk about data products. Data products, what's going on? Why can't I move forward? Sorry, looks like we skipped a little bit here. Data products are this relatively new paradigm in data, where the idea is that each sort of object or domain is treated as a microservice. And there's a bunch of companies that are implementing this already. Convoy has also implemented this. Jamak, who is an amazing individual, sort of really pioneered the idea of a mesh with data products at their core. And you can see through the illustration here that you sort of have this quantum data product object at the center of the domain. You have the operational service on the left, so the system that's generating the data. And then you have these inputs and outputs that manage the transformations internally, how we're aggregating that data and creating a product that we can ship out and make available to other customers that sort of forms an ecosystem which looks a little something like this. You might have an artist domain and a podcast domain and a user's domain, and then within these domains there are the operational systems that are generating the data. And of course, in this sort of universe, it implies that the owners of the data from the production side, from the transactional side, are collaborating really closely with the folks who are doing the analysis on the data, right? This isn't a purely, this is very clearly implying strong collaboration between the two teams. Otherwise, it's not really possible to generate these sort of clear, well-defined and well-owned inputs and outputs. So the core paradigm of data products is that, number one, data is a first-class engineering citizen. So it's a first-class object. It's not just treated purely as exhaust used to run some operational database. The second is you have these semantic categories, which we'll call domains, or nouns is another way to think about them. And those are owned and maintained by the product team. The data is explicitly designed for the purpose of some business use case that is intended to be productionized. And the product teams are accountable to, we call these pods, but basically they're accountable to other teams within the company for the data that they produce. And the vehicle that they use to do this is a contract. It is the agreement between that producer and consumer. And this is just like any other part of the product, really. Engineering teams have been using contracts for decades. We call them service contracts. You might call them APIs, but it's simply a contract is applying this API-based paradigm to the data itself. So quick highlight of everything that the data product paradigm solves. Number one, it solves the lack of a contract between the production services and the consumers. Number two, the goal is to capture all the data that those consumers need, not just what the production system cares about. So that means being a little bit more explicit potentially about the events that we're generating and the data we're generating and where it's coming from. This is solving the collaboration problem between the engineering team upstream and the data teams downstream. It reduces a lot of complexity in the warehouse, gets rid of the spaghetti SQL, yada, yada, yada. It's really great. So the credo that actually there's one more thing I do want to say. The last point is pretty important. Today in the old world, the data team has to scale linearly with business complexity. This is bad, right? It basically means that as the business gets more complex, we have to hire more data people. That fundamentally starts to break down unless you're Google or Uber or Meta and you have all the resources in the world. If you're trying to be efficient with your data budget, which most teams are definitely trying to do right now, then you actually need to have some mechanism to control that scale and the corresponding complexity. So the creed here, the things that we believe in, or I believe in rather, is that science and analytics are actually first-class consumers of production applications. They're not these, nameless, faceless people that are just extracting data and we don't need to care about them. We need to treat them the same way we treat any other customers of our applications. And in this universe it's the responsibility of the consumer to define the data that they need as expressed through a contract. And we'll get into a little bit more about what that means, but in the end, the consumer team and the producer team need to align on what that data contract should look like. What are the constraints? What is the schema? What are the monitors we should put into place? And then that data should be vended explicitly and it should be trustworthy and discoverable and all the rest. The data should be treated like an API via a product or like a product. And we should have a federated ownership of the system. That means no bottlenecks where you have a single person or a single team that's responsible for the governance everywhere. It just doesn't scale. It doesn't work. Those systems always fall over unless you have, you're talking about big organizations with huge support. They are usually moving very slowly. The modern tech team that's trying to move quick, ship product all the time, they're just not going to be able to. They're not going to be able to operate with those sorts of bottlenecks. And then the final creed is like meet teams where they actually are, the tools that they use. If you're going to try to get engineers on board with this, you should be probably using the workflows they're already familiar with and not trying to get them to do something totally different in the name of great data quality. Okay, so old world, analytics is an afterthought. New world, data products. Old world, unclear ownership. New world, data emitted from production as contracts. Okay, great. With that in place, let's talk about data contracts. So what are data contracts? Contracts are API-based agreements between some individual or team that is producing some data and a consumer of the data. They are consumer-defined versus producer-defined, like a traditional API, and they are generated for some production-grade use case. And when I say production grade use case, I mean this is some ROI generating asset. It could be a very valuable dashboard. It could be a machine learning pipeline. It could be a data product that's embedded in an application. But the point is there is a cost to contracts, and that cost doesn't need to be rolled out everywhere in your data architecture, but only where incremental data quality results in incremental business value. And you might be saying to yourself, well, that sounds kind of like an API. And you'd be right about that. It is like an API because it is an API. The difference is software engineers are generally not used to thinking about APIs in the same way that we data people are used to thinking about data. So for example, when we think about what would be valuable as an API, we might say we care about the schema. We care about semantics. So if I have a column and that column is called shipment distance in miles, I really care if the underlying business logic of that column is changed to mean kilometers, right? So part of my contract is expressing these semantic constraints, the constraints on the schema, and the SLAs that are meaningful to data like freshness. So there's a lot of tools that are already in place that facilitate some of these things. Change data capture is a vehicle you can use, the schema registry to store the schema itself. And there's a lot of open source tooling that you can use to implement data contracts. But the thing that you have to do is sort of tie all these tools together in a coherent system. So in the rest of the talk, we'll go for the next 10 or 15 minutes. We're going to talk about the different types of data contracts and how they get used, how you implement these contracts, and then overcoming some of the engineering and cultural hurdles of actually getting to this, idyllic state. So we already covered the why of data contracts, clear ownership definition, great for, I would even say required for data products. And this is really important, this last piece here, but a single surface for collaboration between the producer and the consumer. We're going to get into that more in a second. So here's a great way to visualize the idea of a contract. You have either an entity or an event with some schema, some semantic constraints around that's expressed as an API. It's that schema is and all the constraints are defined somewhere. And once the data is actually generated, then there are some checks that run. So there are some checks that run at runtime that if there is a backwards incompatible change made to the contract, you break the build, you stop the engineer from making this change that could potentially damage you. And then as the data is coming over the wire, you're checking it at the row level to say, does this each individual row of data correspond to the rules of my contract? And if not, I need to do something with it. Now, you can use Kafka for this. Convoy was a relatively mature system, so we were doing everything in streaming, and I strongly recommend implementing data contracts in the stream for a bunch of reasons. So that's mainly what I'm going to talk about today, but if you want to know more about how to do this in a batch process, I'd be happy to talk about that with anyone as well. So there are 6 commandments to the data contracts Bible, if you will. The first is that contracts require enforcement at the producer level, meaning if you're not able to actually enforce the contract through some programmatic means, then you don't really have a contract. You basically just have, you know, a set of requirements or a handshake agreement. These things also, contracts must be public. We have to treat them like APIs. They need to cover schemas and semantics. So both are actually required. Schema management and schema evolution is a well documented, but not necessarily well supported set of technologies. But they aren't enough in order to make up a true data contract. The contract implementation shouldn't make developers go slower. This should be a part of their existing workflows. And then the contract should also shouldn't hinder the implementation speed for the data scientists or the analytics team or anyone else that's accessing this on the consumer side. So 3 types of contracts here: paper, entity contracts, and event contracts. We're gonna actually focus primarily on the latter 2 in the interest of time. A paper contract basically is just like a written agreement. It's a Word doc. It's a Google spreadsheet that lays out the constraints of the contract. But really what we care about is the programmatic enforcement of these things. So what I'm going to do is just skip ahead to entity contracts to ensure we can get through and have some questions at the end of the presentation. So high level, what are entity contracts? So entity events basically refer to a change in semantic state. So some object in your business, a noun is a good way to think about it. So in freight, we might think of it like a ship or a shipment, a contract, a customer, a facility, right? Anytime the state of that object changes, that's usually where we apply change data capture to some production source, some dimensional table somewhere, and then we push that update through to our data platform. These types of events actually make up the significant majority of most data use cases. And so this is where I recommend folks to start when they think about data contracts. So the contract itself, when we're talking about entity contracts, is the API that is generated by producers who are putting constraints and taking ownership on top of these semantic objects that are most relevant to the downstream consumers. Why is it good to have an entity-based contract? Well, if something goes awry, if there's a regression, if some unwitting engineer introduced a bug into the system, we'll know exactly why, and we can spot exactly when the data started to be bad. We'll have a log of essentially an audit log that shows us the history of all these events as they flow through. The system will be version controlled, so we can easily roll back changes, and we can also practice good change management and communicate these types of updates down through the entire pipeline. So the really great thing about entity contracts, it's good for leveraging CDC-based systems. I'm a big fan of CDC. I am not a big fan of what I would call raw CDC that just sits on top of, Postgres or whatever, and there's no sort of abstraction layer in between sort of the database and your ETL processes. I think that's bad. But if you have a contract that sits in the middle, it's a good thing. The software engineer can then sort of manage the database however they want, as long as they vend a certain data through the contract, through whatever ETL process that you're using. So CDC in that world becomes a real amazing thing. You can use streaming systems for real-time alerts. You can think of it sort of like integration testing for your data. And like I already mentioned, sort of the last point there, it's this really powerful layer of abstraction between producers and consumers. The cons is it doesn't really tell you necessarily why something changed. It just tells you that it does change, and it can be costly to implement. You can also do this in batch, though, like I said. If you're not familiar with change data capture, just very, very quick, high level, the basic idea is anytime a change is made in the scope of one of these sort of dimensional tables, we log that change, and then we push it. We push the row level change into our storage system in real time. let's skip through this. So this is sort of a high-level view of what a data contract-centric architecture might look like. So if you sort of look in the box that is most to the left there, you'll see a contract definition. That means we take some schema serialization framework. I mentioned the importance of defining the schema as part of the contract. So this could be like you could use protobuf as I've shown here. Avro works. JSON could also work. And then you want to have some mechanism of actually implementing the contract through some stream processing layer. If you look all the way to the right, then what we're doing there is we're taking that sort of contract definition, we're storing it in the Kafka schema registry, and then during the CI/CD process, we're running a check against what's in the Kafka schema registry. If it's backwards compatible, then if it's backwards compatible or not, we'll do a test. And if it fails, then we'll break the build. And then in the production, sort of all the way to the right on the production contract fulfillment stage, as we see these entity updates come in through our databases, we use the CDC system and we run the checks in the stream processing layer on whether or not the data itself actually meets the contract. Okay, so I basically ran through the actual implementation just then. So the last sort of major implementation detail we'll talk about is application events. So I think of most data in a data storage environment expressed really as two pieces. You've either got the nouns, which are entities in dimensional tables, and you've got the verbs, which are events. So we call these semantic events or application events. So this refers to the specific change in state. So for example, if we have some shipment that is canceled, that the moving from on deck or in progress to canceled is a state change. We would capture that as a CDC update, but we might also want to know when the event happens, specific properties of that cancellation, that real world cancellation event. We might want to know, when the cancellation happened, what was the reason for the cancellation, where on route did the cancellation occur. And these are things that we would need to event directly from the production code itself in a way that is fully decoupled from the databases. So this makes some things easier. You don't really need to think about all this, like crazy CDC stuff. But in some ways, it gets a little bit more complicated because it requires your engineering team to know enough about your services to figure out where are all the places in the code that this specific event actually happens. So the pros are you still use streaming, you still have integration testing. You don't really have to think that much about like, okay, we have this pre-existing ETL system that we need to like piggyback on top of, but it can be very costly and it can be challenging to implement, like I said, and it can also be challenging to prioritize if the engineering team doesn't really understand or doesn't know exactly where all these events are origin from. So here's an example, just so you sort of can get a visual of how this all works. The first step of defining the contract is to specify the schema. We had an internal IDL that we built, which was called Philo, but for all intents and purposes, you can think of this as protobuf or Avro. And then we had an SDK, and that SDK did a few things. The first thing that it did is it auto-generated a lot of the sort of publishing code that engineers needed to deploy these events. We had a bunch of compile time checks that ran, backwards incompatibility checks. If there was a schema breaking change that was made, then sort of they would get that alert during their build, and then all the checks would run during CI/CD. We also used a pattern called transactional outbox for data integrity. I'm not gonna. I may actually have a slide on that, but this was basically the library that the engineering team would use. And then whenever they were ready, they would sort of just use a method, just like publish whatever the name of the event was. And then like 5 minutes after this code was actually deployed, then the event was, it was available. It was in Snowflake. You could access it. and the schema was logged in the registry. So this is a breakdown of what I mentioned earlier, just in terms of like how you might want to think about organizing your contracts and where you might want to start. The left is the status of objects. The right is sort of the snapshots of real world behaviors or verbs. So that's that. And you might be saying to yourself, okay, well, this all sounds amazing. And it sounds like this, beautiful sort of utopian vision where engineers care and we've got quality everywhere and we've got all these like objects represented. But how do I get an engineer to care about this? Because they don't really think about data today. So I came up with this concept at Convoy, which I call the contract maturity curve. And the idea is you can't start implementing contracts from the most complex, business logic constraints you can think of. You actually have to work your way up from sort of stage 1 all the way to stage 4. And this takes time, and it's not something that any tool can really provide to you. It just requires work and talking to the people within your organization. So the first step is awareness. And awareness basically means the software engineering team needs to understand how their data is actually being used, right? And I don't mean that in a conceptual way. I mean, they need to see it, and that it needs to be tangible. So we used data lineage for this. There's a lot of really great applications of data lineage here. And you can essentially say, hey, software engineering team, here are some of the tables. Here's some of the production tables that you manage. And we ran lineage, and here's like 4 or 5, data products that are supported by those tables. And you should just ensure that whenever you're making a change, you're not affecting these things. Ownership is next. So ownership really centers on the contract itself. Is the engineer willing, after they're aware, to say at the smallest atomic unit of data ownership, like, we have one column and we need that, it's an ID column and we need it to be null. Can you ensure that? That's a great place to start. Next is the API. So this is getting into the CI/CD, specifying very clear inputs, outputs, great documentation and versioning. And then last, at the very end, is the constraints. So we're gonna move through some of these to the impact, right? So like when you roll out a system like this, what happens? So we had hundreds of contracts rolled out at Convoy. And every single day we're seeing more. And there's a question there about like, oh, well, we have a bunch of contracts. How do you start to manage these? How do you prevent the contracts from getting out of control? I'm happy to talk about that. There's a whole nother sort of effort there. But we're seeing the contracts modified thousands of times. The most important thing to me, and really my internal KPI when we were managing this effort, was, can we get the software engineering team and the data team to talk to each other about the data? And it's a productive conversation. It's not an angry conversation. A lot of the fragility in some of our core data assets, like machine learning models, was decreasing substantially. And we had a single place where people could go to see, here is our source data, here are the semantics attached to these objects, here's who the owner is, and here's what we can trust and what we can't. So big takeaways is that if you're starting to build data as a product, you need to think about contracts. They're really, really important for establishing that upstream ownership. You can certainly implement contracts through culture just by getting people to sit down and write some stuff on a piece of paper and have a handshake. But doing this programmatically and connecting with engineers with the tools they already use, like GitHub and potentially Protobuf and Avro and Kafka and things like that, is super valuable. It's an active collaboration. Abstractions are really important. And then the goal is not just to accept the garbage that we get a lot of times from production databases today, but to really define the data that we need and ensure that it's high quality. And that's the presentation.
That was great. That was, as one comment said, very, very thorough. Has it been a year in the making kind of level of talk?
Oh yeah, I mean, I think this was I think all in all, we were working on this from soup to nuts for about 2 years. And when we started this process, there were no guides, there was no roadmap on how to do this. So it was literally all just taking the machete and sort of cutting through the jungle.
Yeah. Any major goals with data contracts this year as we're starting off January?
So one of the big things that we have now is we have a community called Data Quality Camp. I don't know how many folks are aware. We have a Slack channel, and in that Slack channel, we spend a lot of time talking about what are some of the open standards around data contracts, where and when should you start with data contracts. We talk about a lot of other things, but there's a lot of great discussion about data contracts there. So I would definitely recommend checking that out.
All right, I'm gonna post that right here. Data Quality Slack, so I'll post it below. So if anyone wants to join, it is there. So feel free to jump in, talk data quality. I think you've got almost 3,000 people, or have you passed it at this point?
Just past 3,000 people.
Nice. So, and it's pretty active. I occasionally get tagged, and then I occasionally remember to actually check. But I know it's pretty active, just based on skimming it every once in a while. So. Yeah, awesome. Well, we still have like 2 minutes. Any quick questions? One quick question, maybe. Any more? Y'all can't be more tired than me. It's not allowed. No, I'm kidding. What was I thinking?
You've been going. How long have you been going?
8 hours and 40 minutes.
8 hours and 40 minutes. Wow.
I mean, I did walk away, like while you were talking. I was like had it on my phone, and I finished. I have a burrito from Qdoba that I've been nibbling, but
so you ate the burrito during my talk. I see.
No, it's been through everyone's talk. To be clear, every time you see my camera go off, it's a big burrito. I can't eat it that fast.
I'm just messing around.
Yeah, you're all good. All good. All right. Let's see. Hold on. Yeah, okay, I can do that as well. I was just looking at the private chat. All right, cool. Well, I'll kind of let you go for the evening, and we'll wrap this up with our what should you call it? The finale, the grand finale talk. Let's do it. All right, thanks, Chad.
See you, folks.
All right. Hello.
Hey.
How you doing?
Good. It's been a long day.
It's a long day. It's okay. We're wrapping it up here. I'm excited to finish up with you. We're ending on a very practical note. So I'm excited to hear about functional data engineering. Hopefully you're psyched too.
Awesome. Yeah.
Cool.
Let's do it.
Awesome. Feel free to bring up your slides. I'm looking at these things.
Can I share my screen?
Yeah, or share your screen, whichever.
Okay. Slides. Okay. I need to figure it out how to do this one. Share screen. Slide. Okay.
Go.
Perfect. All good?
All good. You are good to go. Enough.
Awesome. Hey, yeah. Welcome everyone. Great to see you all in the State of Data conference. I realize this is the last talk, so I'm really thankful for people staying till the end. I'm watching this conference all the day, so totally enjoyed a lot of interesting conversations around that. So what are we talking today? I'm going to talk about functional data engineering, blueprint for adopting functional principles in data pipeline. I really wanted to have this conversation in the State of Data conference specifically. One of the things that I realized when I'm talking to multiple people is there is a sudden uptick of conversations around data modeling. Is the data model is dead? Is it the re-emerging of data model? When should we do a data model? Should we adopt it early? Who should own the data model? There's so many conversations went on. Should we adopt Kimball, third normal form, data vault, or activity schema? I believe this conversation never going to end, and people are always going to debate a lot. At the time of this conversation, I realized from my experience, there are two founding principles in the data pipeline that I believe that if you follow, that we can build a very robust data ecosystem, right? So this is nothing new. This concept has been like well established like 4-5 years back. So I'm going to resurface this and reignite these conversations again and see where it goes, right? So who am I? So I'm Ananth Packkildurai. I'm an author of Data Engineering Weekly. It's a weekly newsletter of like kind of aggregation. It's kind of a curated newsletter for reading what is happening in 1 week or like latest trends in the data engineering field. If you want to follow what happening in data engineering side, I highly recommend to follow Data Engineering Weekly. I'm also happen to be a creator of Schemata, which is a data contract platform. Chad talks a lot of, just talked about like what is the importance of data contract and then how to kind of structure it in a very thorough way. Schemata is like an own approach for you to kind of take in to do that one. So, but this talk is like more or less focusing on the data pipeline, not necessarily on the data contract side of it. But this principle is also essential for you to build a data contract on top of it. Recently, I'm a principal data engineer, Zendesk and Slack, and right now. So, what is any functional principles here? There's, Max, who's a creator of Airflow, wrote a significant, a signature paper or a blog about functional data engineering, a modern paradigm for batch data processing back in 2018. And during all this data modeling conversation, I found out this particular block is kind of missing. This concept is missing. So that's one of my reasons kind of resurfacing that concept into my recent blog about functional data engineering, a blueprint. It's cumulative, it's a pattern that I seen successfully implemented in multiple companies. So I thought making it as a blueprint and then kind of share with everyone. Right? When we talk about functional data engineering, there are two important principles. One is reproducibility and recomputability. Reproducibility, essentially, if you compute a metric day one, if you're rerunning the same metrics again, can you reproduce the same metrics? Like, if you're running a data pipeline at T1, time 1, and then like you're running the same task like at time 3, will you be able to get the same result? That essentially very important for you to build the trustability of your pipeline. And the recomputability is absolutely critical for your pipeline. What I mean by recomputability here is, let's say your pipeline is building ARR or computing active monthly user, and then 6 months down the line, your business changes what is the meaning for an active user, and there's a whole lot of logic being changed, and the business also wanted to see like, hey, can you go back in 6 months, recompute my new logic? I wanted to really compare what is the current definition, what is the next definition, how it is going to really impact my day-to-day curve. Like last 6 months, I wanted to understand what is the trend for my new definition. The goal is like, will your data pipeline be able to do that? Will your data ecosystem be able to produce that kind of an insight, adapting to the changes in the business dynamics? So the one key takeaway I wanted to give everyone here is like, go back to an understanding from your data ecosystem. Ask these two questions. Is my data pipelines are reproducible? Is my data pipelines are recomputable? Right? If the answer is yes, you're really doing an amazing job. If it is not, and I think that's a whole lot of conversation here, right? So when I talked about this blueprint, every good system adopt the underlying architectural changes and then evolve on top of it, right? What is the state of data in 2023 here? We have seen systems of lakehouse architectures. We have seen data warehouses here, but I call them collectively a modern data cloud. All these systems, the modern data cloud, has 3 properties in common, right? There's a clear separation of storage and compute. We no longer running like a one vertical boxes. The storage and compute is largely separated. We're able to scale it independently. unlimited scale data repository. What I mean to say unlimited data repository scale, essentially, since the separation of storage and compute is there in many of the warehouses and lakehouse, literally using object storage as the data lake, as to store the data. So you have certain capability to kind of store large amount of data. Right? You're no longer limited to one single box. And all these systems now supporting AC transactions, right? You can do AC transaction. BigQuery recently announced the transaction support. Mutation support is available, so you can really mutate this. So these are the three fundamental characteristics right now. If you take any data warehouses right now, and if you're working on that, so putting to this all together, we talked about functional principles. We talked about the state of the data ecosystems right now. And what did that mean for me to build this data engineering data pipeline, right? Chad talked about there is an entity contract and event contract. The very similar concept, any schema that you take, you can classify as an entity or an event. So entity by definition, in a very simple way, it's a mutable data that represents a noun, maybe an actor of your business. Could be a user, could be a product, and it must have a primary key because it has to be uniquely identifiable. And event, on the other hand, are immutable in nature. Events are essentially a business activity. Essentially, two or more entities act on each other's, create a business activity that is essentially we capture as an event. There are many ways to capture the event. I don't think we should go deep on that in this talk. An event by definition is immutable, and it must have an event timestamp. It has to have recognition of when this particular business activity has essentially happened. So we talked about the schema structure, and when we capture this data, how are we going to store the data? What does the physical representation look like? The physical representation essentially looks as a datetime partition. Right? Datetime partition is absolutely critical for establishing the functional paradigm here. So if you are representing a users table in user entity in a data warehouse, you might be seeing a create table and then a partition by some kind of a date timestamp. Or if you are storing into an object storage, typically using a lakehouse architecture, you might just store it as your S3 location and then datetime as a key, and then all the data just goes to this thing, right? So there's a clear separation of what is entity means, what is the event means, and there is a corresponding representation of how the data getting stored in the table level. So now let's go deep dive on what does the entity modeling look like? What would some of the blueprint look like? When you talked about entity, and when we capture those entity modeling, there are two different types of way to ingest those data. One is incremental snapshot, and one is full snapshot. Not every data source will have the luxury to get full snapshot. Maybe you are sourcing data from MongoDB, or maybe you are sourcing your entity from CDC pipeline. So what you are really getting at is an incremental data that coming in, what has happened maybe last 1 day or that. So incremental snapshot, to reproduce an incremental snapshot into a datetime partition, what are the steps looks like, right? You take the incremental snapshot, putting that into an incremental table, which is in your staging area essentially. And at the very first time of taking any entity, you need to have a bootstrap table that you take what is the current state of an entity from any data sources. It could be a MongoDB, it could be a MySQL system. Take that entity and put it into a bootstrap table, and really merge the incremental pipeline into the base table. Once you merge it, you take the snapshot out of the merged data and create a datetime partition out of it, as I pointed out here, right? And all your downstream pipeline essentially running on the particular time, like it's at hour 11, it is running this datetime partition table. All the downstream pipeline depends upon your datetime partition, not the base table. This is essentially an internal table for you to kind of recreate the current state into a datetime partition. And then some other entities, like maybe you are importing some CSV files from third party or any other system, you have some luxury to kind of, or importing some Google, Google Sheets or any other data, you can potentially get a full snapshot. Getting a full snapshot and creating a datetime partition is much easier because you don't need to do any merge process, and then you just create a datetime partition materialization on top of it from the full snapshot. The merge operation is particularly very appealing because all the lakehouse architecture, if you do, like if you take Apache Hudi, Delta Lake, Iceberg, everyone now support those kind of an operation that help us to build this kind of an system here, right? And then the latest view come here, right? Why are we creating this latest view? You could potentially create a latest view out of from the latest datetime partition, you create user underscore latest, which is a view on top of a latest datetime. Many of the ad hoc analytics, many of your business users don't really wanted to understand or don't really care about what is your underlying datetime partition strategy going to look like. They are not going to query every time adding a predicate filter of datetime stamp. So for those users, they always wanted to know what is the current state look like so that I can query that quickly. So creating a view on top of your latest partition will help those kind of users to directly go and query and understand, do some ad hoc analytics here. Event modeling, there is no mutation involved. So it's very, very straightforward to do that. All your data that you are capturing, it could be a hourly bucket or even a minute bucket. It depends upon what level of granularity that you are taking here. You can take that granularity and then and you can put it a datetime partition on top of it here. So it's fairly straightforward for you. I'm sure many of you are already doing this. So this is all great, so establishing this kind of pattern help us to reproduce or reprocess the whole pipeline and again and again. But there are few key challenges, right? When we're talking about the functional programming, and especially we are talking about timestamp and the date partition being is a promoter as a first-class citizen in our data modeling perspective. There are key challenges coming, whatever the timestamp can bring in. One is late arriving data. How are you going to handle the late arriving data here? And what about data deletion? GDPR compliance comes in, some fact kind of your computing, but we don't want it to kind of gather, we don't want it to hold the data for a very long time. It can be subjected to certain retention policy. For an enterprise SaaS companies, a client or an account deactivated, we have legally obligated to delete those data. What will happen to a functional principle, essentially, right? So when you're talking about the late arriving data, it's important to understand the window of processing. In the batch data processing, we predominantly use tumbling window. What I mean by tumbling window, let's say a data pipeline runs at T2. It's wait for all the hourly data that comes in and wait for the data to complete, and then it just process whatever that inside the window. We often discard the late arriving data, and it just strictly focusing on looking at the pipeline. Essentially is looking only the window that we are processing, and then we just keep on going on. One way to kind of mitigate the late arriving data is using the sliding window data processing technique. So what I mean by sliding window data processing technique, essentially, let's say you are processing a data pipeline on hour T2. You go and look, you look back 1 hour and say, figure it out, okay, what is the T1 and T2, and filter it out any data arriving data that comes in and include that into the T2 processing bucket, trying to process on that. So this kind of a sliding window is conceptually much easier, but it is very hard to implement. The reason being that the more and more volume of data that we are kind of gathering, the more and more delay that kind of bringing in. And also you need to kind of process more data than what you needed. It could increase your constraints on the cost aspect. So if your data is much simpler, and if you're okay to process, or if you have if you're not having a much scalability problem, it might be an easier approach to adopt, making a sliding window to kind of holding the late arriving data. The other approach you can do is apply the watermark period. So watermark essentially a set of window time. So instead of starting at top of the hour for processing your data, you wait for a specified window time. You may be waiting for 15 minutes or 20 minutes for your hourly batch processing pipeline, allowing some late arriving data to come in so that you can start processing the data here. Right. So that is one approach that predominantly used. Many of the data ingestion pipeline that ingesting the data from Kafka that comes into your data warehouse usually apply the watermark time before writing any success file. So though data ingestion processing, it's far more efficient, it's much more simpler for it to implement. But again, it adding a more pressure on your speed of delivery, latency of your pipeline. So this is something that you have to be really careful about, like what is your window time that you are going to define, and what is a acceptable time delay your pipeline can hold, not only for the current processing task, but data pipelines obviously highly interconnected with each other. So if you're introducing some latency upstream deliberately, it can just trickle down towards all the way end of the pipeline here. The third approach you can do is adopt a reconciliation pattern. This is a very predominant pattern for most of the pipeline that deals with financial data and or any significant data points that can potentially result in some kind of a monetary benefit or a financial numbers. Reconciliation frameworks often being used. Reconciliation framework essentially you keep processing your Hour 1, Hour 2, Hour T3 pipelines, regularly, and then at some point of a time, maybe you're closing the book like 24 hours once. You go back and then reprocess the 24 hours pipeline to build the daily view of the particular pipeline, right? So reconciliation framework is also one way to kind of mitigate the late arriving data here. So when we talk about this late arriving data and all those things, right? So the window time, the reconciliation framework, the sliding window, it's not really like 100% correctness. In a data pipeline, there's always a trade-off between your speed and the correctness. You can satisfy only. Actually, like it's a trade-off between speed, correctness, and the volume. If you want higher speed of your data pipeline, then you cannot process all the volume. Like you don't have a luxury to wait for the later arriving data to come in. You might have a very small window function adopted. So your pipeline tuned towards giving more and more speed. So it's potentially correct, but it is not exactly the correct. But if your pipeline tuned towards correctness, then you have to increase your window time or increase your reconciliation process time. So that means that you are compromising on your speed velocity. So when you are designing this data pipeline, it's very important for you in your platform to choose your confidence window of correctness. When you say that, okay, 10 minutes is the window time is my confident window of correctness, and this is where I'm closing the book, and make sure that you publicize that and make sure that you stick with that approach so that you can have you can find balance between your speed and correctness, essentially. Right? And the last part is essentially the data deletion part, right? as usual, if you don't have data, you don't have nothing to delete. So that's something that you have to be very careful about it. Like when you're doing a data processing pipeline, the earlier that we mitigate not carrying your PI data throughout your metric pipeline can potentially remove the need for a lot of reprocessing. So similar to reconciliation process, data deletion, you can also trigger a reprocessing pipeline. Or automatic way to do a backfilling of the data. Let's say you wanted to delete one particular account from your SaaS business in your data warehouse. That account active users might have influenced some calculation, and if you're deleting this data and you're reprocessing, you might get a different result. So you're essentially violating the functional principles there. But it's just the nature of the game. Like if you're going with a pre-processing approach, that is totally going to happen. The second approach, which is not adopting the reprocessing, but having a delete audit log. So you don't need to trigger the reprocessing as soon as the data get deleted from your tables. But when you are doing some backfilling or any other system that you do, you might get a different result. But at the time, most of the time, the confusion happens that it is a wrong result or it is not a wrong result. Having a clear audit log when you are deleting this data, like what are you deleting and how much, let's say you are deleting, number of active users from a particular account, having a stat audit log that contains like how many number of users that we deleted from this particular table. This can potentially eliminate a lot of confusions when we are doing this reprocessing when it needed, not an early reprocessing, not an eagerly reprocessing, more of a lazy reprocessing techniques to that one. So I think these are the two important characteristics when you're adopting this functional principle. The late arriving data and data deletions can potentially give you the side effects to adopt these principles, and there are several mitigation steps that you can do, like from adopting a window function, reconciliation framework, having a deletion audit log. Establishing these best practices can really help you to reliably build this ecosystem. That brings end of my conversation. So essentially, so this entity relationship and functional principles, I feel like this is very critical for us to adopt, regardless of what kind of a technology, what kind of a data modeling technique that you use. You might be using dimensional modeling or that normal form or any other systems. These are the data modeling techniques primarily focused on establishing the link, establishing the relationship between the dimensions and fact. But then the key critical characteristics of a data pipeline is enabling a time travel, enabling a date versioning. So these are the two first-class citizens, often hidden away from all the data modeling conversations. Adopting a functional principle establish you to these two characteristics as a first-class citizens. On top of it, once you establish the date versioning and the time travel in your as a building block in your data pipeline, you can potentially replace with any data modeling technique in the edge. Like in the data mod, you can choose to use dimensional modeling or data vault, because you can go back and reproduce the format that you wanted to do that at any point of a time. So that's all for me. Thank you so much for watching.
Yeah, we appreciate all you just shared. It was definitely very beautiful slides. I really appreciate that whenever someone's like got some both color coordinated and beautiful charts. Yeah, do you have a preference? I mean, I know you said it doesn't matter in terms of data modeling. Do you have a preference in terms of data model?
I don't really like. I mean, each has its own merits and demerits. If you take dimensional modeling, it's very easy to read and understand, and then publicize across the people. Whereas if you're taking a third normal form or data vault, it requires certain level of literature to do that one. So it's really like what kind of an audience that you wanted to do that. Whether essentially, I feel like there's subtle difference between the data vault and data modeling. Essentially, it's all boiled down to how do we handle the story changing dimension? How easy to handle that? Are you going to create this like a punchy bridge table to do that for capturing everything, or you wanted to build everything as a hub, and then call it out, right? So it's a two different way to handle that, but subtle is same. I think as long as if you're adopting these functional principles and you're able to reproduce, and it should be totally fine on that. I'm not really opinionated on any modeling technique here.
No, that makes sense. It's fine. There are too many sometimes. Quick, where'd it go? Oh, question just disappeared. Here it is. Okay, question from the audience. Does a sliding window require double the storage / memory compared to like tumbling in order in order to manage state?
Yes. I mean, it depends upon where is your storage. If you are doing a stream processing, obviously a sliding window will store that everything in the memory, so that you will need an extra memory footprint there. But if you are doing in the batch pipeline, it doesn't require a specific storage. Like it doesn't require a dedicated storage, because you are just looking back to the bucket. You are not really creating a new storage, or you're not doing a hard copy of any storage, any of the data. So you don't have that double storage when you're doing a batch processing on sliding window. But it can potentially have more compute and an IO operation, because you are reading more than what it's supposed to be reading.
Makes sense. And now going back to that data modeling topic, how important do you feel like data modeling is for someone just starting out as a DE versus, or is that something that senior architects are supposed to do?
I would highly recommend for anyone, right? You are an entry-level data engineer, or even if you are wanted to start or thinking of having a career in data engineering. Why I say that, data engineering, the whole reason why we exist is to empower data, using the data to empower certain decisions or certain analytics, certain insight that never been discovered before. And how do we do that? We have to first understand what is the domain, what is the business actually looks like, and capturing how do we understand what is your business is doing from a typical data engineering perspective. You look into this, data model first, how those data have been represented, how it is connected, okay, this is a product. Is it having a category? Does it having any other layer of connectivity? And then going back and look back into, your business use case. That is very, very powerful. One funny incident is like when I started a career in data engineering, and I asked a mentor, like, what should I do? Where should I start? So he asked me to okay, go to this shopping center and tell me what you are seeing. Come up with a data model, or come up with how these objects are there, how it is connected, and just walk through the shopping mall and then come up and give me your table design, and then I'll tell you whether you are eligible for a data engineer or not. So I highly recommend data modeling for any level of engineering.
Yeah, that's funny. That's so usually when I tell people to learn data engineering, one, I tell them to pick up a book. There's like all these free Kimball PDFs, so I always say that one. And then I say, now think about your favorite app, and now design it like from a high level. Like, it doesn't have to be super in depth, just from a high level. Right. What would this look like? For DoorDash, for Uber, right, whatever it would be. It's just like, what does that look like? Because that honestly, that's like what Facebook basically does. Like when they do their interview, it's like, all right, imagine you're in this what kind of your shopping mall situation or whatever. It's like, what do you have? What are the different entities? What are the transactions that are going to occur? What are you tracking? So it's a great way of really doing it. So if anyone wants to practice data modeling, that's all I'd say do. That's a real way of doing it.
Yeah, I mean, and once you started to do that, the way you look at the data the way that you look at the world is completely different, right? So you will look everywhere data. So sometimes it's scary. So
everything is data, and then you realize how crazy and complex it can get, because not everything is this nice transaction. Sometimes it's like these super nested things in order to have flexible functionality for a software application, and then you're like, oh god. Like I'm sure Slack and Zendesk have some funky data somewhere,
That's another conference talk completely.
How to model data for Slack and Zendesk. Man, that's too funny. Great. If anyone has any questions, I'll wait another minute. But do you have any questions for me before we kind of wrap this up? It ends up being.
What is your favorite data modeling technique?
Oh, I don't know if I think. I think it's just easiest to do the like your traditional like facts and dims, and it's just easy to lean on. But obviously, there's reasons to do other ones. You know, and I think we're getting to a point where it's often a mix, right? Like sometimes it's like, okay, do you store it in a dictionary or something in this case, or do you store it like do you use a separate table, right? Like in some situations, in most situations, it's like, okay, mostly store a separate table or something. But sometimes it's like, all right, in this situation, either because no one's going to access this data or the way they're accessing it for the moment, it might make sense. So I've often found there is some meshing that sometimes goes in between to make sure things work the way people need it.
Yeah.
As long as there's a core idea, then you kind of make sure you know what decisions you're making and why you're making said decisions. It's like, okay. Yeah.
Totally.
Cool.
Awesome.
Yeah. I don't see any other questions. Anything else from you, Ananth?
Yeah, check out Schemata, and Schemata is kind of it's kind of a decentralized data modeling framework. One way when you are designing this entity and events, and then you give the power of data modeling to everyone, it quickly can go out of hands. So Schemata implemented something called Schemata score, which is essentially programmatically measure how well connected your entity is, how well connected your events. So
nice.
we can give you systematic feedback, like how good your data model is. Is there it's always a constant question for me, like will be able to measure programmatically the data modeling robustness, and I think this is one of my attempt to do that. So take a look at it, give me feedback.
I mean, if you're able to do that, then it just connect it to whatever the future version of ChatGPT is for data modeling, and then just dump it in. And,
yeah.
And it'll just go through all the iterations until it designs one that hits the correct score.
Yeah.
Done.
Possible.
I don't know. We might be a little bit away from that, but okay. One quick question, and then maybe we can wrap up. Do you have any books that you recommend for data modeling?
Yeah, I think Kimball one is really interesting. I highly recommend to read, regardless of what kind of a data modeling technique that you end up. I feel like the data warehouse toolkit is brilliant, in my opinion. It has a lot of conceptual more thoughts that is very, very relevant still. As I mentioned in my slide, this is my criticism on Kimball modeling. Essentially, the techniques that has been described is invented when we have a storage scarcity, right? We have only one box, so how do we optimally store the storage changing dimensions? So take the concept and then also understand like what are the underlying cloud data warehouse changes being there. We can afford to store the entire copy of the data in the new partition, which is what I'm talking about here, right? Data partition, essentially, like you don't need to track individual storage changing dimension. You can just take a snapshot and store it at a different time. So it's a fact. It's a fact on a given time. So those are the things that changed, but I feel like maybe you will be carrying less about conformed dimension, but I think most of the concepts are very, very relevant. So I highly recommend that book.
Do you feel like there's any like with that because when you make a copy, it's great when you're doing analysis for that day, right? Like if you're like, okay, I'm analyzing for today, it works great. But then when you want to do like have things changed over time, and every day has same data changed for one row, right? Like it's not for all rows, just for that one row, same day. 2 rows are different. What do you still feel like it works well, especially for like analysts? Because I feel like that's usually sometimes the limitations. Like if you give them that, then they have to figure out how to put some logic over all of that and join every partition and figure out what the difference is day over day.
Yeah, that's actually a good question. I was hoping to cover that. I somehow missed it, right? So what we call it as typically it's called snowballing. Snowballing, essentially, you look back the previous day to influence your computation of today and then do that one. So usual approach that we do, don't do snowballing if it is absolutely, they do it only absolutely necessarily. The reason is that, like, if you introduce any bug in the middle, so you have to reprocess the whole thing. It's not like one thing that you reproduce it, because it's not a standalone matrix. The second approach you took, like, if you have to really do a snowballing, which is like any metric computation that you do, that going to depends upon the previous day. Isolate the metrics alone. I isolate that particular metric computation alone in a separate pipeline. So even something goes wrong, you are minimizing this pipeline disruption. The third part is that we usually store those metrics in a key value pair in the map as a one field. So you don't need to go back and join multiple, multiple partitions. You compute that and then store the map. Day 1, this is a value. Day 2, this is a value. Day 3, this is a value. And there are very sophisticated JSON functions and like not much performance impact of doing that kind of analysis. So adopting a complex data type like a map to store the history of the metrics in one column will fully eliminate the need for you to kind of recompute the partitions again and again.
Okay, I see what you're doing with the metrics at least. Like earlier, Brian Zan, I don't know if you know Brian, he referenced FGF, which is like fixed granularity framework, which kind of does something similar, where it ends up like storing like a daily, every day, it's like a snapshot of the metrics for the last like X amount of time.
Right, exactly.
So it's very nice.
Yeah, exactly. Same concepts there. Yeah.
Awesome. Well, I think, again, if there's no more questions, we can probably wrap this up. Again, I appreciate everyone who showed up. It's been a long, fun day. My live says 9 hours and 20 minutes. In 3 hours, YouTube would be like, we're done with you. So thanks for everyone who's been here this long. And hopefully we can do this again in the next, 9 or 12 months or something.
Take care. Bye.
Bye, everyone. Thank you. Yep. Anyways, if I haven't said goodbye already, thank you all. And I will see you all hopefully in 9 or 12 months. But I really appreciate everyone who showed up. And we will see you at the next conference.